Dr. Sachin P. Ballard, Dr. M.M. Shirgan sir as resource persons. We are really honored to have such intellectuals with us for this conference today. ನಮ್ಮ ವಿದ್ಯಾಲಯದ ಧ್ಯೇಯ ವಾಕ್ಯ ಕಾಯಕವೇ ಕೈಲಾಸ. म्हणजेच श्रम हाच ईश्वर हा मूल मंत्र महात्मा बसवेश्वरांनी भारतीय अर्थव्यवस्थेला दिले. त्याप्रमाणे आपल्या महाविद्यालयाचा पाया रचला आहे. तेव्हापासून तो आजतागायत आपल्या महाविद्यालयाचे प्रगतीचे आनंदाचे क्षण संगमेश्वर गीत मधून अनुभवूयात. Now may I request Head of the Department, Mathematics, Dr. A.S. Dhone sir for welcome and present the preamble.
Good morning, one and all. Respected dignitaries on the dais, today's chief guest, Professor Dr. V.B. Patil sir, Director, Innovation and Incubation Center, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. Today's keynote speaker, respected M.M. Shikhare sir, Dr. Professor, General Secretary, IMS, and formerly Head Department of Savitribai Phule, Pune University, Pune. And also our resource person, Dr. S.B. Ballar sir, resource person, M.G. Srigan sir, academic advisor, planning and evaluation, Dr. P.M. Dargopatil sir, our beloved principal, Dr. R.P. Boa sir, and all vice principals present over here. Dear participants and my dear friends. On behalf of the organizing committee, I extend a very warm and heartful welcome to everyone present here at the inaugural function of the National Conference on Recent Trends in Mathematics. I am Dr. Appa Sahib Dhone, convener of this conference. We are excited to engage in meaningful discussions on the latest advances in mathematics, and I am confident this platform will provide valuable insights and foster opportunities for collaboration. I would like to begin by welcoming our chief guest, Professor Dr. V.B. Patil sir, Director, Innovation and Incubation Center, Solapur University, Solapur, whose distinguished career and leadership in the field of conducting polymer-based gas sensors and supercapacitors, hybrid solar cells, has been an inspiration to us all. It is truly an honor to have you with us today. Your presence here adds immense value to this event, and we look forward to hearing your enlightening address, which will no doubt set the tone for the conference ahead. I also welcome to our keynote speaker, Dr. M.M. Khare, sir, formerly Head Department of Mathematics, Savitribai Phule, Pune University, Pune, and Professor, presently working as Professor Emeritus, JSPM University, Pune, a respected authority in the area of mathematical modeling. We are privileged to have you here, and we are eager to hear your perspective and insights on mathematical modeling of some real-world problems. I extend a warm and heartfelt welcome to resource persons, Dr. S.B. Ballar sir and Dr. M.G. Srigan sir. Your involvement ensures that the conference will be both academically enriching and practically beneficial. To all the participants who have joined us from various academic institutions, research organizations, we welcome you with great enthusiasm. So I would also like to extend a warm welcome to all the students who are participating in this conference. Your curiosity and eagerness to learn are the driving forces that will ensure the success of this event. It is always inspiring to see the next generation of scholars and professionals engaged in important discussion like the ones we will have here. Let's take full advantage of this time together to learn, exchange ideas, and contribute to shaping the future of mathematical research. Before we begin the conference, I want to sincerely thank each and every one of you for your valuable contributions in making this event a success. This achievement would not have been possible without the support of everyone here today. Let me first express our heartfelt gratitude to all those who have contributed to making this event a reality. So we are truly grateful to the college management, Honorable President Dharmaj Kadaji Sahib, and Honorable Secretary Ma'am, Ms. Jyoti Kadal Ma'am of Sangameshwar Education Society, Solapur, for their continuous support, without which this event would not have been possible. Your dedication and commitment to advancing academic excellence play a crucial role in the success of initiatives like this national level conference. Sincere thanks to our principal for their continuous encouragement and guidance. Your leadership has always been a source of inspiration, and it is with your support that we are able to organize such impactful events. So I would like to take a moment to express our deep gratitude to the keynote speaker, Professor Dr. M.M. Sikare, formerly Head Department of Mathematics, Savitribai Phule, Pune University, Pune, General Secretary, IMS, Resource Person, Dr. Sachin Balla sir, and Dr. Sri M.G. Srigan sir, for their willingness to share their knowledge and expertise with us. Sir, your contribution are invaluable, and we are truly honored to have you here. So heartfelt thanks to all the participants for participating in such large numbers. Your involvement is what makes this conference meaningful and successful. And we are excited about the knowledge and experiences that will be shared during this event. In today's fast-paced world, organizing a conference like this is essential. Mathematics is the foundation of numerous scientific advancements and technological innovations. The objectives of this conference is to provide a platform where both researchers and students can benefit from the invaluable insights shared by eminent experts in the field. The topics that will be covered in the sessions range across various areas of mathematics, ensuring that the conference is comprehensive and informative, offering something for everyone. One of the key goals of this conference is to encourage interaction, to the exchange of ideas, questions and discussions will provide young researchers with an opportunity to interact directly with the experts, gaining valuable perspectives on the recent trends in mathematics. So while the conference will cover a broad spectrum of topics, it aims to highlight the diverse nature of mathematics and its applications across science, engineering, and technology. So we'd like to express our heartfelt gratitude to the Vice Chancellor, Professor Dr. Prakash Mahanoar sir, for their gracious cooperation and unwavering support. They are invaluable also. So we are also deeply thankful to Dr. V.B. Patil sir for graciously accepting our invitation to be the chief guest at this conference. So a special thanks to our organizing committee members whose hard work and dedication have been crucial to the smooth execution of this conference. Finally, we are very much thankful to Professor Dr. P.M. Dargo Patil sir, who consistently guide us on every moment. So, and also I am thankful to the technical staff and non-teaching staff for their assistance and cooperation in ensuring that every aspect of the conference runs smoothly. I am pleased to share that the participation in this national conference on mathematics has been remarkable. We are fortunate to have paper presenters from diverse states, including Andhra Pradesh, Telangana, Karnataka, Rajasthan, and various corners of Maharashtra. In total, we have received over 50 research papers from distinguished contributors covering a wide range of topics in mathematics. Furthermore, the total participation in this conference, both online and offline, is around 125. So with these words, I conclude my introductory speech. So thank you all for presence and participation. And I wish you a fruitful and engaging experience throughout the conference. We look forward to having a successful conference, and we hope that all the attendees enjoy and benefit from this conference. Thank you once again.
Thank you very much, sir. Respected audience, lamp is the universal symbol of truth, knowledge, and spreading the knowledge wherever possible. I request all the dignitaries on the dais to lit the lamp and inaugurate the national conference on recent trends in mathematics. Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityorma Amritangamaya, Om Shanti Shanti Shanti. Meaning, lead us from unreal to real, lead us from darkness to the light, lead us from the fear of death to the knowledge of immortality. Today for this conference, we have Professor Vikas Patil sir as chief guest. Sir is Director, Innovation and Incubation Center. Today, we have renowned chief guest, Professor Dr. Vikas Patil, Director, Innovation and Incubation Center, Punyashlok Ahilya Devi Holkar, Solapur University, Solapur. Keynote speaker, Professor Dr. M. Shikhare, sir, ex-head Department of Mathematics, Savitribai Phule, Pune University, Pune. General Secretary, Indian Mathematical Society. Sir is also Emeritus Professor, JSPM University, Pune. We have the resource persons, Dr. Sachin B. Ballard, School of Mathematics and Statistics, University of Hyderabad, Telangana. One more resource person, Dr. M.G. Shrigan, Department of Mathematics, JSPM University, Pune. I thank all the dignitaries for inaugurating the conference by lighting the lamp. Today, we are honored to have with us renowned chief guest, Dr. Vikas Patil, sir. I request Dr. Mahendra Kavle to introduce the chief guest to the program.
Thank you, madam. Good morning, one and all. Respected principal, sir. Respected chief guest, Professor Dr. B.B. Patil, sir. Respected academic advisor, Professor P.M. Durga Patil. Respected dignitaries, remaining dignitaries of the dais and on the dais. It is my honor to introduce Professor V.P. Patil, sir. He is working as a Director of Innovation and Incubation Center in Punyashlok Ahilya Devi Holkar, Solapur University, Solapur. Sir has 29 years of research and teaching experience. He taught the PG students in Solapur University, Solapur. He has completed 13 research projects funded by various agencies of Government of India. He got 4 patents, and I do remember that recently during COVID pandemic, he got a patent regarding the mask. 18 PhD students completed their PhD and 6 students are working. His H index is 56. Total number of citations are more than 8,982. Sir has published more than 550 research papers at international level. Sir has completed 13 research projects and he has written more than 13 international books. And this is a very brief introduction of Professor V.B. Patil, sir. Thank you.
Thank you very much, sir. Really, we are honored to have Vikas Patil, sir, as our chief guest for today's conference. Respected audience, arriving of guests brings happiness, celebrations, and more joy in the ambience. Now, as our Indian culture says, Atiti Devo Bhava, I request the president of the program, beloved Principal Ruturaj Bua sir, to felicitate today's chief guest, Dr. V.B. Patil sir, Director, Innovation and Incubation Center, Punyashlok Ahilya Devi Holkar, Solapur University, Solapur. And also I request today's president of program, our beloved principal sir, to felicitate keynote speaker, Professor Dr. M.M. Shikhare sir, ex-head Department of Mathematics, SPPU Pune, General Secretary IMS. Sir is also Emeritus Professor, JSPM University Pune. I also request our beloved principal sir to felicitate Dr. Sachin B. Ballal sir, Sir is Assistant Professor in School of Mathematics and Statistics, University of Hyderabad, Telangana. I also request our beloved Principal Sir to felicitate Dr. M.G. Shrigant Sir. Sir is Professor in Department of Mathematics, JSPM University, Pune. Now I also request our beloved Principal Sir to felicitate our guide, Dr. Pramod Dargo Patil sir, who take their time and joined us for this conference. Now I humbly request our chief guest, Professor Dr. Vikas Patil sir, to felicitate Senior Professor Dr. Alankar sir. Now I request our academic advisor, Dr. Pramod Dargo Patil sir, to felicitate B.B. Patil sir. Thank you, sir. Dear audience, research is what propels humanity forward. It's fueled by curiosity. We get curious, ask questions, and immerse ourselves in discovering everything there is to know. May I now request eminent chief guest, Professor Dr. V.B. Patil sir, for inaugural address.
Namaskar. Good morning. For this inaugural function of one-day national conference on recent trends in Mathematics, that is NCRTM 2025. On the dais, Principal of the college, Professor R.P. Bua sir. Resource persons, Professor M.M. Shikre sir. Former Head of Department of Mathematics, Savitribai Phule University, Pune. Research persons, Dr. Sachin Ballal sir, University of Hyderabad, Telangana. Dr. M.G. Shirgan, JSP University, Pune. My friend, Professor P.M. Durgo Patil sir. Convener of the conference, Professor Done sir, and Dr. Gade sir. Then here, Dr. Kunte sir, Dr. Mamane sir, many friends are here. Professor Alankar sir, Professor Pujari sir, Dr. Molkar sir, Dr. Dahitnekar sir, Dr. Kara sir, Dr. Mitri madam, Dr. Mahajan sir, Dr. Sheikh sir, and dear participant friends. It is both an honor and privilege for me today for this inauguration function of this national level conference on the recent trends in mathematics. I would like to extend my sincere gratitude and thanks to the organizing committee members for giving me the opportunity or as well as for inviting me for the inaugural function. Basically, this is a treat for me to interact with the research persons like Senior Professor Shirgan sir and the many other key persons invited from other states also. So you all are aware that is the Indian higher education, it is in tremendous mode of transitions. And new norms, new trends, they are coming up. You know that recently, Government of India, that is Government of Maharashtra, as well as the Department of Education, Government of India, they have introduced National Education Policy 2020, and we are going in that process. Basically, organizing such kind of the conferences, which will give you the new dynamic to the particular. So this conference, it is related to the mathematics, and you know that the role of the mathematics, that is the mathematics is the core subject. So without mathematics, it is not possible to do anything in the science and technology. Now we are discussing related to the AI, artificial intelligence, cloud computing, traffic, complex systems, only these things, but physics, chemistry, biology, all science and technology related disciplines. So it is based upon all the mathematics theories, complex systems or number systems. So mathematics, I feel that mathematics is the catalysis. So Mamane sir is there, you know the role of the catalysis. That is, it helps to make a reaction. Similar fashion, so mathematics plays a vital role in all the science and technology subject. So basically, we are talking about the National Education Policy 2020, and this is the first autonomous college in the city. And I was pro vice chancellor at that time, and we have submitted the proposal for the autonomy of this college. And so there are many things related to the National Education policies, and this college also may have introduced national policy from 2022 or 23, maybe 23. And this is maybe second or third phase of a national policy. Okay. Yeah, which one? Second year. Okay. So, and basically, I'm proud to say that I'm working as an academic council member of this college, as well as the IQAC external member of the college. So during meetings, I'm giving my suggestions to improve the curricula and other things also. So regarding this National Policy 2020, so no doubt it is introduced in 2020, but actually it is implemented from 2020 because the Corona hampered many things. So you have, that is the new education policy. This policy is good. The main, you know that the highlight of this policy, it is the increase in the GR. Basically, present GR, the gross enrollment ratio, it is a 28%. And so in this policy, it is suggested, it is recommended that GR should be above 50%. And so we have to change the many things in the curricula of every disciplines, not only science and technology, but humanities also. And we are moving in that direction. You know that after 34 years, this policy is implemented. No doubt, all policies are very good. At that time, these policies are very good. But as far as the present scenario is concerned, so these policies are outdated because now you know that the importance is given to the skill, innovation, startups, okay? And you know that in NAC system also, in NRF also, this ecosystem should be there. That is, the innovation ecosystem is there. So these things are mentioned in the national education policy, and all these will cover or hopefully will get in 2047. Initially it is stated that we have to achieve a 50%, more than 50% GR in 2035. And last year, Honorable Prime Minister of India, they have introduced the one policy of India, that is Vikashit Bharat. India Vikashit Bharat as a 2047. So again, we have extended our goal. That is, so we have extended our GR up to 2047. It is a 50%. So this is the first thing. It is mentioned in the GR, mentioned in the national education policy. Second, the aspect of the national education policy is that the multiple entry and multiple exit. So this facility is not given in earlier policy. So this is very, very good. So basically many things are there. So main thing is that the more and more students should attract to the UG as well as the PG. And even that recently in the budget also, the government has given a very good amount of the fund to the research. And another important thing is the ICAS. ICAS is introduced in the national education policy. Means many things are introduced in the given in the national education policy. And only thing is that implementation. So we have to implement the national education policy in a true spirit. And for true spirit of implementation, so we have to change our curricula. So in earlier days, so our curriculas, they are teacher-centric. But as far as the NEP is concerned, now the curricula should be a student-centric. And we are going in that direction. University as well as the colleges, they are making their curriculas and they are related to the student-centric. So we have added on-job training, we have added the skill-based courses, we have added innovation ecosystem, and surely it will help to increase the GR as mentioned recommended in the National Education Policy 2020. So surely such kind of the challenge, you know that many challenges are there. While implementing the National Education Policy, many challenges are there. So main challenge is that we have to attract the student from 18 to 20 years into the colleges for the UG admissions. Okay, so this is the first challenge in that. And then only we can see the increased GR, that is a 50%. 50%. So such kind of the conferences, such kind of the deliberation surely will help to increase the GR. Because what happens? What are the advantages of such kind of the conferences? No doubt, this many more discussions, interactions with the resource persons like, see, Professor Shikre sir is there, then the Balla sir is there, and Shirgan sir is there. So such a kind of the eminent persons are there. They have a lot of experience in their field. So the interaction with these peoples or also other research persons will help the student to grow, the nurture, the research, new research ideas. Because in the conference also we can discuss the new ideas, new trends in the research. The conference name itself is the recent trends in mathematics. So just see, that is we are discussing now the AI and cloud computing. What is the base? What is the fundamental behind that? The fundamental is the mathematics and statistics. But what is the present scenario? So present scenario is that students are not getting admission to the maths and stat. Why? So we have to change the curricula. We have to organize such workshops so that students get interact, faculty get interact, and according to the suggestion of the students and the faculty, we can modify the thing. So this is the purpose of the organizing such kind of the conferences. I congratulate once again the organizing team by considering the all aspects related to the new trends in the mathematics for organizing such a conference, and selected the selected area, the recent trends in the mathematics. So it is appropriate, I feel, that as per the present scenario is concerned. And just I have said that is mathematics. As we all know that it is a universal discipline. Just I mentioned, it is a universal discipline. So it finds place in the physics, it finds place in chemistry, it finds place in computer science, electronics, and botany also. So that it transcends the borders, it connects the disciplines, and serve as the backbone for the many science and technology subject. And surely this conference will provide invaluable platform for the students as well as the faculty members for exchange their ideas. For collaboration is very important. In the NEP, the collaboration is also mentioned in that. That is, and so what is actually the advantage of these collaborations and MOUs and exchange of ideas? Basically, it will explore the new research frontiers in the mathematics, no doubt. So these things will be discussed in the conference. Just I have seen the today's program, and these things will be covered in the conference. And no doubt, see, the one thing is that you have the beauty of the mathematics is that it is never confined to one area. So mathematics is not confined to one area. You cannot fix mathematics to a particular area. So it is connected to. So that I mentioned that it works as a catalysis. Basically, and I urge to students and young faculty research present here, and I encourage them, you engage with these resource persons, renowned research persons, and fellow participants, and draw your inspirations from the work being presented during the conference in terms of the poster presentation or the oral presentations. And in a closing, I would like to express my gratitude to everyone involved in this conference, organizing team, and thank you for organizing team and the principal of the college and trust of the college for inviting me for this inaugural function. Thank you, and best wishes for you for this conference. Thank you.
Thank you very much, sir, for your elaborative lecture, for explaining the advantage of NEP 2020 and many new policies added in the NEP 2020, and also motivating the teachers and students to move further by taking the inspiration through such conferences. Thank you once again, sir. Always your guidance plays a key role in developing our curricula. And now with your presence, really that catalyst role you have played with us. Thank you very much once again. Respected intellectuals, as it is rightly said, mathematics is the backbone of scientific exploration and technological innovations. The march of science, technology, and research does not imply growing intellectual complexity in the lives of most of people, but it often means the opposite. To explain the research and development and recent trends, now request the keynote speaker, Professor Dr. M.M. Shikhare, sir, ex-head Department of Mathematics, Savitribai Phule Pune University, Pune, to deliver the keynote address. The topic of the keynote is mathematical modeling of extremely sorry. So there is a small change in the program. Now I request our beloved in charge principal, Dr. Ruturaj Bua, sir, for the presidential remark.
Good morning to everyone. Honorable V.B. Patil, sir, Honorable Shikhare, sir, Dr. Ballal, sir, Dr. Trigand, sir, Management Representative Dargo Patil, sir, esteemed dignitaries, respected resource persons, and dear participants. I have two roles to play as a host, particularly in the role of principal, and again, the new responsibility of the president of the function. I'm feeling quite awkward amongst the scholars of international repute because I'm not a mathematician by my profession. So I will play the role of host more and not, it is not at all in any way presidential remarks I'm going to deliver. Just it is something welcoming all the dignitaries. That is my limited role. We are honored to have Sri B.B. Patil sir. He's our friend, philosopher and guide who is guest of honor to inaugurate this event. His contributions to the field of physics have been commendable. Patil sir is a renowned researcher with multi-crore projects. I think my colleague Kavale sir has not mentioned about the financial outlay because it is not very important from the research point of view. But I think I can say, as a popular going says, he is a crorepati, not by luck or chance, but by his tireless efforts in the contribution of field of education. So we are really privileged to have such an eminent guest. Sir, we value your comments and your inaugural remarks. So it is really a contribution to the field of education. We are equally honored to have with us Mr. Shikhare sir, the distinguished keynote speaker for this conference. I think when I was discussing something related to mathematics that I'm not the, rather I'm the odd man out, Shikhare sir has given me the comfort. He says, mathematics is not limited to only science or statistics, or mainly, it is not a different field from social science. Even he referred, I think he's the member of Maharashtra State Backward Classes Commission. So it refers that mathematics is also related to social responsibility. He's also the General Secretary of Indian Mathematical Society. So the society is playing a very key role in developing mathematics, not only for the persons who are interested in it, but it will spread the subject and the importance of the subject. Rather, as Patil sir is saying, each and everything, whether it is artificial intelligence, whether it is machine learning, or whatever the new courses are coming, the base goes to mathematics. That is the basic thing. So thank you, Shikhare sir, for giving me comfort in the company of many eminent scholars. I think when we proceed for the next part of the conference, we will get the experience of these research scholars. All these scholars are international scholars. So I must say that we are fortunate to have world-renowned experts, educators, and innovators here to share their insights. And I urge each of you to approach this event with curiosity and open mind. To all the participants, researchers, students, practitioners, this conference is your space to learn, to teach, and to grow. It is a time to engage with like-minded individuals, to form lasting connections, and to take away new perspectives that will inform your work in years ahead. I once again welcome all the dignitaries. Thank you. Thank you for the patience.
Thank you very much, sir. Your words are always motivating us. Now I call Dr. Suhas Gade, sir, for vote of thanks.
Good morning to one and all present here. It is instead to a great honor and privilege for me to stand before you and express my heartfelt gratitude on this national conference on recent trends in mathematics. First and foremost, I extended my sincere thanks to our esteemed chairperson, Honorable Dharmaraj Kadadi sir, for his constant support, visionary leadership, and continuous encouragement. Sir, thank you for being a constant source of inspiration for all of us. I would also like to express my deep gratitude to our respected Secretary, Honorable Jyoti Kadadi Madam, Sangameshwar Education Society, Solapur. Madam, your belief in innovation and research has given us the platform to learn, share, and grow. Your support and encouragement have always been instrumental in shaping the academic and professional aspiration of our students and faculty. I would like to express my heartfelt gratitude to our chief guest, Dr. V.B. Patil Sir, Director, Innovation and Incubation Center, Punyashlok Ahila Devi Holkar, Solapur University, Solapur, for taking the time to be with us today. Your presence and inspiring words have truly enriched this event. I extended my sincere thanks to our respected principal, Dr. R.P. Buva sir, Sangameshwar College, Solapur sir. Your dedication and leadership have been the driving force behind the event's success. Sir, your continuous support and encouragement have provided us with the platform to learn, innovate, and grow. I extended my sincere thanks to Dr. P.M. Durgo Patil sir and Dr. S.S. Gamande madam for motivation and guidance. I would like also thank to keynote speaker, Professor Dr. M.M. Shikare sir, ex-head Department of Mathematics, Savitribai Phule, Pune University, General Secretary, Indian Mathematics Society, Professor, Department of Mathematics, GSPM University, Pune. I extended my sincere thanks to our resource person, Dr. S.B. Ballal sir, School of Mathematics and Statistics, University of Hyderabad, Telangana. Also, Dr. M. G. Srigan sir, Department of Mathematics, GSPM University of Pune, Pune. I extended my sincere thanks to Professor Dr. V.K. Purohit Madam, Vice Principal, Commerce Faculty, Professor Dr. S.G. Pujari sir, Vice President, Arts Faculty, Vice Principal, Arts Faculty, Dr. D.S. Mamane sir, Vice Principal, Science Faculty, and Mr. P.N. Kunte sir, Vice Principal, Junior Section. I extended my sincere thanks to convener Dr. A.S. Done sir, Head Department of Mathematics. We truly appreciate your time and efforts in making this event a great success. We are grateful to our sponsor, Punyashlok Ahila Devi Holkar, Solapur University, Solapur, for their support, which has helped us in organizing this conference. Last but not least, I warm thank you to all the participants, research scholars, and delegates for joining us. A big thank for the organizing committee, teaching, non-teaching faculty members, and volunteers for their hard work in the making this event successful. Your efforts are truly appreciated. On behalf of the President, I hereby declare that the inaugural function has concluded. Thank you.
Thank you very much, sir. Now I request all the delegates to wait in the hall itself for the next session of the conference.
the department, Savitribai Phule, Pune University, Pune. And he's a professor in mathematics, as well as he's presently working in as a emeritus professor of mathematics at JSPM University, Wagholi, Pune. Professor Shikre sir is General Secretary of Indian Mathematical Society. He published more than 45 research papers in various national and international journals, and he guided 8 students for PhD degree. He visited many countries like USA, Australia, Spain, Brazil, Indonesia for giving lectures in the conferences. Professor Shikre is a member of Maharashtra State Backward Classes Commission. Am I right? This is the brief introduction about Professor Shikre sir. So I request Professor Shikre sir to deliver the keynote address to us. Welcome, sir.
Principal of this college, Professor Bua, and the organizer of this one-day conference, head of the department, Professor Done, his colleague, and their participants and students. So the title of this one-day conference is to know the recent trends in mathematics. Now, 4-day conference is like a test match. 2-day conference is like a one-day match. And 1-day conference is like 20 match, T20. So they are shorter period, but they are interesting like that. So it's a good thing to be here and share my views on the topic that has already been displayed. That's mathematical modeling of some real problems. Because my topic should it should be related to the recent trends. Now, when asked that why should we consider the recent trends? The reason is because during these days, very rapid changes are taking place in mathematics and in other subjects also. And that is happening because of computational mathematics and the subjects which are related. That is happening because of the data science, artificial intelligence, machine learning, deep learning, and other things. So you should know that how it is changing, in which direction which branches of mathematics are changing, so that you can modify your curriculum. Because for mathematics, physics, chemistry, there are problems now getting job. That is also we should understand, that. So to review this trend, explore the possibility where our people can get the job so that you can modify the curriculum, train then our students according to the new trends, so that some employability chances will be increasing. That's why there is a need to review or to consider the recent trends. So maybe you can go to the so So the first slide of my presentation consists of that why should we consider the recent trends of mathematics, whose answer already have a given. Because by reviewing the recent trends, you can judge which branches of mathematics have the potential. Then, okay. Then coming to mathematics. Mathematics is divided into two parts, pure mathematics, and the other part is not even pure mathematics, applied mathematics. And the pure mathematics is that branch of mathematics or those subjects which have only theoretical part, only theoretical proofs, less applications, like algebra or complex analysis or pure number theory. And the other branch of mathematics is applicable mathematics, like hydrodynamics, fluid dynamics, mathematical modeling, which have more applications. So the mathematics is divided into two parts, pure application, pure mathematics and applied mathematics. And both of them have their own properties. So I'm just trying to figure out what are the properties of pure mathematics. Pure mathematics, how there is focused on learning theoretical aspects of mathematics. And then what is the nature of studying the mathematics? It is just like proving the theorems, solving the problems. Example is like abstract algebra. You know that you study the nature of the groups. Groups are abstract. You cannot visualize. What you do is only with the help of the axioms. Some axioms are satisfied to be a group. You cannot draw the picture. They do not have the smell. They do not have the color. They are abstract. Abstract things have that property. That's why abstract things are a little bit difficult to study. And then coming to the applicable mathematics, applied mathematics, they have the focus on using mathematics to solve the problems. Problems in mathematics, problem outside the mathematics. And the nature is that you can carry out some experiments, you can make some practicals. And they have more chances of getting, the people who pursue mathematics have more chances of getting jobs in software companies, in private firms, because the first pure mathematicians mostly go to teach. But now teaching employability have some restrictions. Everybody can note it. Whereas for applied mathematics, there are chances to get job in various software companies, in various pharmaceutical companies, and elsewhere. So this is all about thing. Now coming up, what are the recent trends? Some few examples that the recent trends that take place in mathematics. So what is the mathematical? You are adding the word computational. Computational mathematics, that mathematics which is done or which takes place with the help of the computers. When you take the help of the computers, you need to have some different kinds of arrangement. Like you need to design algorithms, you need to design programs and do the computer mathematics with the help of the computer. Then you can see mathematical modeling. Several problems can be modeled as day-to-day life problems, can be converted into mathematical forms, and they are solved with the help of the mathematical tools. So mathematical modeling, data science, artificial intelligence, they use on the large basis this mathematical modeling. Even in day-to-day problems, we will give some examples of the day-to-day problems which can be converted into mathematical modeling, can be solved in mathematics, and again they interpreted it in the original form. Then advanced numerical methods. Then you can say fractional derivative. You know that the ordinary derivative, the derivative of x square is 2x. You can find only the derivatives of integer order. But now you can find 1/2 derivative of x square. You can find 1/3 derivative, 1/3 derivative of x square. So that is kind of fractional calculus, fractional differentiation. Similarly, there is a branch known as a fractional integration, and they have a tremendous application. Many people are working on this fractional calculus. Then comes for data science, artificial intelligence. Nowadays, you know that you take most of the job, they are available in data science, artificial intelligence, and machine learning. So, So, for data science, what kind of mathematics you use? For artificial intelligence, what kind of mathematics? The focus is in the direction. Then you can say that use of artificial intelligence to study mathematics and to make research in mathematics. You'll be knowing, if you are aware of the ChatGPT, there is a website, chatgpt.com. You can go to that website and you ask any question. You can say that I would like to prepare a lecture on mathematical modeling. It's just like conversation. You put your query and within 5 minutes, you will get the answer that you consider introduction, you do this, and you can give the talk on the following topics. How interesting it is. If you have any problem, put into ChatGPT. It is like an advisor. Very surprising. If you have not tried it, you just try it. So you ask any problem, you say that I am suffering from the headache. It will say answer. You say that I want to from Solapur to Pune, what are the different ways? How can I optimize? You get the answer here. So just try to add up the ChatGPT. And then the next one is the use of the blocks. You can study or you can make the use of the block. Block is the website which is used by expert to write his comment, to write his article. So blogs are very useful to study mathematics, to make the research in mathematics, and then use of mathematical softwares like MATLAB. You know that if you want to draw graph of y is equal to x, you have to take the points, take the graph paper, and visualize how it. Next time, you would like to visualize the graph of x minus 1, taking longer time. Maybe x square minus 1, taking longer time. Maybe sine x plus x, how do you do the graph? But this MATLAB will give within just 1 minute. You just put the values, that will give you the graph. So that make the visualization very clear. It is just like curve or the surfaces or any kind of equation you can visualize. You can find the eigenvalues of any matrix, however large may be, because you have the limitation. 3 by 3 matrix at the most you can handle. But you have a matrix of the higher order, 4 by 4 or 4 by 5. We don't have that much capacity. So with the help of these softwares, many things are possible to carry out. So with this, I'm just trying to figure out in which direction, in which subject most of the mathematics is going on. There are some other things which are not been mentioned here is optimization, numerical optimization, discrete optimization, like financial mathematics also. Mathematical finance is there, financial mathematics is there, statistics is there. Because data science is a combination of mathematics, statistics, and some other allied subjects. So I just wanted to let you know 2 areas, because total branches of mathematics are 30. Out of them, all the 30 cannot go in the recent trend. These are some of the branches in which direction the recent mathematics is advancing very fastly. And with this, you see the mathematical modeling is one of the direction in which the recent trends of mathematics are going. So I will be touching to this part of mathematical modeling. I'll just try to bring out to your kind attention how day-to-day problems can be handled with the mathematics. And before going to the presentation, I will like to ask you 2 questions. Suppose in some forest, 3,000 tigers are there today. And what happens in every year, 4% tigers, the population is decreasing by 4%. That may be because they do not get the food. That may be because they are affected by the disease. But 4% tigers are. So my question is, after 12 years, what will be the number of tigers they would be added? 12 you can replace by 3. 12 you can replace by 50. But this is the problem. Then another problem, you have a cup of tea. If somebody is served, put it on the table. The initial temperature of the coffee or tea should be 97 because water boils at 100 degrees centigrade. When the tea is put in the cup is put on the table, suppose the initial temperature is 97 degrees. In 1 minute, it goes to 95 degrees. Okay, in 1 minute, it goes to 95 degrees. Question is, find the temperature of the tea after 14 minutes. 14 you can replace by 13. You can replace by 30. You can replace by 2 hours. Find out that. And then you try to work out your brain and see whether you can find the solution to this problem. And it's very difficult. But we say that if you know simple mathematics, simple kind of mathematics, you can find out the solution to this problem. So next thing is, what is mathematical modeling? Mathematical modeling is the process. Mathematical modeling of the world real problem to mathematics. So first thing is, given problem, it may not have anything to do with the mathematics, but that problem is converted to suitable form of the mathematics. It may be mathematical equation, it may be a graph, it may be linear programming. I am giving in which form the mathematical models are made. So the question is, given problem, as I said, the tiger problem or the coffee problem, convert them in one of the suitable mathematical form. Model it is called. It may be equation, it may be set of equations, or it could be any suitable form of the mathematics. Then first thing is that convert that problem into equivalent mathematical form. Second way is solve that using the mathematical tools. Why should it be converted to mathematics? Because you can utilize the powerful tools of mathematics. And the third thing, once you find the solution in mathematics, go back to the original problem. So this is how this process is split up into 3 parts: conversion, solving, going back. Next, the forms in which probably the problems are converted. I'm just saying linear difference equations, because I pointed out there are 30 branches. So out of those 30 branches, what are the popular branches of mathematics into which are used as a mathematical model? One is linear difference equations. Then second is dynamical system. Dynamical systems are nothing but the set of differential equations or differential equation, partial differential equation. Then third is differential equation. You start studying the differential equations from 11th standard onward, order of the differential equation, degree of the differential equation, how to solve them, and those of the things. Then partial differential equation. When the function involves 2 or more variables, you differentiate each of the individual variable and you get the partial differentiation. Then you consider the graph theory. If you have heard about the Königsberg bridges, 7 bridges problem, that is the one order that 7 bridges problem converted into mathematical graph theory. Using the techniques of graph theory, it was solved, and then again the solution of the original problem was interpreted. Then you can talk about the linear programs. Linear programming, you study linear programming. Given problem, which doesn't have anything to do with the mathematics, like several problems are in linear programming. They're making of shares and tables on 2 machines. Machines have certain capacity. So then by selling 1 share, such profit is made. By selling 1 table, how much profit is made? So how can you utilize the use of the machine so that your profit will be minimized? Such kind of problems you have handled in 12th standard. You convert them in the language of the linear programming. You write the optimizing function, you write the constraint, you write the constraint, the variable, solve them using the concept of graph theory, or there are various ways to solve the problem. You know that one is using the graphs, another is using simplex method. You solve that problem and interpret. So linear programming. Then statistical models. There are several, that I said that data science. Data science, what is done in the data science, large data is studied and their patterns are identified. Climate change. Your department tell that tomorrow it will be raining. Why? How? They will say that during this 4 days there will be hot. They will be saying something about the temperature. They will let us know what will be the situation after 4 days, how it is happening. That is happening with respect to because of the modeling. They have patterns. If such kind of temperature, humidity, have this kind of thing, they will say that this and this kind of situation will occur on the particular day. So statistical model. Then the last one is, you can say, game theoretic models. So there are some other models, but to give example, I'm just pointing out some of the mathematical subjects or the structures into which given problems are converted. Then go to, I say that specifically we would like to tackle a tiger problem and the temperature of the tea. So when you want to convert problem into mathematical form, so you need to know what is that mathematical form, whether it is differential equation or it is a graph or it is a group or it is a vector space or anything. So here we consider the part of the mathematical known as linear difference equations. So what are the linear difference equations? You may have sequence 1, 2, 3, 4, 5. Nth term you can express in terms of the previous terms. So if you have the sequence of numbers u1, u2, u3, and you consider the expressions like u0 into un minus 2 plus c1, some real number, un minus 1 plus c2 into un minus 3 f of n. N is a natural number, right hand side is a function of n. Then this equation is an example of a linear difference equation. And C0, C1, C2, they are real numbers. So coefficients. And that UN minus 1, UN minus 2, UN, they are the, you can say, they are the terms of the sequence. So when linearly, now I set the sequence 1, 2, 3, 4. How you write 4? 4 you write 3 plus 1. How you write 10? 10 you write 9 plus 1. So this is a, you can write the linear difference equation. Then you define what is the order of this linear equation. You see the suffix of n, you see the largest suffix, you see the smallest suffix, and you make the difference of them. So that is the order of the linear equation. So we say that the highest suffix of n minus smallest suffix of the 3 term, because you have suffix of 3 suffix, n minus 1, n minus 2, n. So you consider the largest, you consider the smallest, and look at the difference. That is the order. And then we give some examples of, these are some of the examples. So you consider first one, we just write it consists of just 2 terms of the sequences, and then we find out its order. Then we have the first one is if right hand side is 0, it is homogeneous. Second equation consists of 2 terms, again un plus un minus 1 is equal to n plus 1. And then you determine its order. Then we have third equation, we have the fourth equation. So you can write your equation involving 2 terms or 3 terms. And then we give one equation that is not linear, because linear is that where power of un, all the powers of un, they are 1. And then right hand side, or the coefficients are real numbers. But here we give the example where the power of un minus 1 is 2. It is not linear. Linear things have the power 1. But in the example of non-linear difference equation, we consider one equation where the power of un minus 1 is 2. So this is example of non-linear difference equation. We consider linear difference equation, non-linear difference equation. So we use linear difference equation to tackle this problem. So I'm going to the direction to get this, that will help me to get the solution, the problems which we have specified. That we consider a very specific type of equation, un minus k times un minus 1 is equal to 0. Or you write un is equal to k times un minus 1. And the example of this is, that un you can write some multiple of the previous term. An example you can take 1, 2, 4, 6. How do you write it? The next term is 2 times of the previous term. So k is equal to 2. Or you take it 1, 3, 6, 9. un is equal to 3 minus 1. Right? So in general, you write the linear equation un is equal to k times un minus 1. How to solve you want to find out, because if you do not know the sequence and just equation is given, then we want to find out the sequence. So here, if we are un is equal to k times un minus 1, then you put the value n is equal to 1. You write u1 is equal to k times u0. Then you put n is equal to 2. You write u2 is equal to k times u1, but for u1, you substitute from the earlier equation. This way you go on and find out u3, u4, and finally you will come to that un is equal to k to the power n into u0. So that is the solution to the sequence. So that is one thing. Next equation that we consider, that un is equal to n term is equal to a times a is some number times un minus its previous term plus b. So n term you can obtain by multiplying by a to the previous term plus b. And I think you can consider 1, then 3, 5, 7, something like that. Or you consider 1, 2, 3, then 5, then 8. And then you know that 8 you can write 3 plus 5. Then 5 you can write 2 plus 3. So if you continue pattern, then you can say that un is equal to un minus 1 plus un minus 2. What is the sequence? 1, 2, 3, 5, 8, 13, 21. You can write some of them. But this sequence has the pattern that un is equal to un minus 1 plus un minus 2. A is equal to 1, b is equal to 1. So you have different pattern. Now, what is that sequence? I have stated one sequence, but in general, if the value of a is changed, in my example, a is 1, b is 1. But if a is equal to 2, and this equation is given, b is equal to 1, and you determine un, that will find the solution. So we do it systematically, that what is given, un, you consider the equation, un is equal to a times un minus 1 plus b. Then in that equation, you put the value of un minus 1. How do you write un minus 1? It is true for all n. So un minus 1, you write a times un minus 2 plus b. So substitute the value of there, un minus 1, and you go on substituting the value of un minus 2. That will be a times un minus 3 plus b. Then minute minus Tn, temperature in nth minute, divided by the duration, 1 minute. So the right hand side, the rate of change of the temperature of the object, that is denoted by Tn plus 1 minus Tn. By giving the meaning that N is the temperature after the n minutes. Each proportional to the difference between two quantities. What are the two quantities? One is the difference between the own temperature of the copy or T minus the temperature of the room temperature. So S minus Tn, and it is proportional. So it is multiple. So we are multiplying by K. So what we do here is Newton's law of cooling, which is stated in physics, has been converted into mathematical equation. Right? Next. Then we use the initial condition that about the change in the temperature of the copy during the first minute, how it is changing. So look at the situation in first minute. So if we put write the equation for the first minute and the initial minute, so T1, T0 is the initial temperature. T1 is the temperature after 1 minute. So T1 minus T0, the change in which that occurred in 1 minute is equal to K times S minus original temperature. But you look at the values given in the problem. T1 temperature, initial temperature is 190. After 1 minute, it had come down to 180. So T1 is 180, T0 is 190, is equal to K. Yes, room temperature is 70. And then initial temperature of the copy is 190. Just write this equation, solve it, and you get the constant of proportionality, that is 1 upon 12. 1 upon 12. Rewrite the equation again. So Tn plus 1 minus Tn. Now we put the value of constant 1 upon 12 and then room temperature 70 minus Tn. So you get the equation in Tn plus 1 Tn. Just simplify it and you get Tn plus 1 is equal to 11 upon 12 Tn plus 70 upon 12. So 11 upon 12 is A. Look at the equation. Un is equal to A times Un minus 1 plus B. Here you write Tn plus constant. A here is 11 upon 12 times B is 70 upon 12. You take the help of that solution. So what is this is A times N plus B. What is the value of A? You say that A has three probable values. A is equal to 1 in the original value. Here A is not equal to 1. 11 upon 12 is less than 1. So use the appropriate form of the solution. But we say this is the form of UN plus 1 is equal to AUN plus B, whose solution is given by N is equal to A times here. There is 11 upon 12 times to the power here. Then T naught, here 190 plus B, here 70. And then 1 minus A to the power N. 1 minus 11 upon 12 to the power. This is the formula. Then you put substitute the values. Right. So you just simplify it. Simplify and you get 70 plus. So you simplify the quantities and here you write 70 plus 120, 1 upon 12 to the power N. For N is equal to 1, 2, 3, 4, 50, 5,000 gone continuing. And then our question is, so this gives the solution. Here you look at the meaning of Pn. Pn is the temperature of the copy after and you found the formula that will give the value of Tn. Coming to our specific value, N is equal to 15 because we are asked to find out the temperature after 15 minutes. So put N is equal to 15. So T15 you are finding. Simplify and you are getting 102. So the temperature of the copy after 15 minutes from 180 Fahrenheit, you will come to 102. Now, as I said, 15 you can reduce by 6. It could be 9. It could be 30. It could be 27. You can find out the solution after 32 minutes. So that. Okay. Next. So again, suppose a saving account is opened that pays 4% of interest compounded yearly with initial deposit of 10,000 Indian rupees, and a deposit of rupees 5,000 is made at the end of each year. Find the amount accumulated in the account at the end of n year. N could be 6, could be 10, could be 20, could be 30. So we write the mathematical modeling of this. So mathematical modeling is if n is the amount, you see, you know that rate of interest is given. Initial amount that is deposited is given. It's 10,000. And at the end of each year, 5,000 rupees are accumulated, is deposited. Question is find out the amount that will be accumulated after 16 years. You write the mathematical law modeling giving some symbols. If n is the amount of the A at the end of the year n, for n is equal to 0 and onward, then A1 amount after 1 year will be equal to initial amount, that is 10,000, plus R, its interest, because the rate of interest is R. So interest on A naught, when 1 year completed, what will be the amount? That will be the initial amount plus interest on that. So that is written A naught plus R A naught, simplify 1 plus R A. Then A2, you can consider the amount accumulated after 1 year, A1 plus its interest, R into A1, right? 1 plus R A1. And then you can write out the value of n plus 1. The amount accumulated after n plus 1 year will be dependent on an, the amount at the end of nth year, plus R into an, interest on it. So you are getting 1 plus R. Now, initial deposit is 5,000, is made at the end of each year. Initial was 10,000. Then the dynamic model which describes the scenario is given. An plus 1 is equal to the amount that is accumulated at the end of nth year, which we have found as per the other discussion, plus 5,000 rupees on which no interest will be given because that is added at the end of the year. And if you combine these two things and simplify, you get 1 plus 0.4 AN plus 5,000, and you get the final form 1.04 AN plus 5,000. Thus, the amount for the first 3 years will be. At the first year, you will be getting 1.04 A naught plus 5,000. You simplify, and what will be the amount? 15,400. Then you use the formula, and the amount at the end of the second year will be 21,016 rupees. And after the third year, the amount accumulated will be 26,000 something more. You continue, you find the amount after fourth year, fifth year, sixth year, after 10. Like, what was the initial assumption? Some initial fixed deposit made, its rate of interest is given. And at the condition is at the end of each year, it is 5,000 are added. Okay. Next. So, And in February, we will after 2 months. They were predicting what is going to happen after 1 month, that they were giving the intimation to the government, then corporations, so that the corporations of the government used to make the appropriate. The epidemic, मराठीमध्ये epidemic म्हणजे महामारी म्हणतात. म्हणजे एक एक्झाम्पल महामारीचं म्हणजे Corona. Corona is the example. All of us for 3 years. So how we can get it made? How we so that was through the mathematics. I'm not giving a perfect model. My model may not be one, but you can get the judgment how mathematically you can put in that epidemic. So it is important. In second paragraph. In epidemic model, the population can take the area around this college, maybe 1 square kilometer or something like that. You particular area in your region, and you can take the population in the total number of people. So the population is divided into 3 parts, 3 main classes. And first class is a susceptible class denoted by ST. T is the time. Suppose today is that date, so we can take T to be. And capital S is the susceptible class between the persons who can easily be infected. Right now, he is healthy, but it is likely that he can easily be infected. Then second class, infected class of people who has already infected by them. So we denote that class by RT. And then third type of person, that will be the recovered class, the person who was infected and they now recovered. So any person will fall in one of the 3 classes. How? Then well, this is the known as, this is built up by what? I will give you the name of the book. You will say that why. So susceptible infective model. Susceptible already one class. Infective is another class. So what the model says? That let a population consist of n plus 1 people. N plus 1 equal to 100. You take n value of n, you give 100 persons, of which 99 persons, n persons are susceptible, healthy. And only one is infected. So that means ST, healthy people, plus infected number of people will be n plus 1. If I have 100, so 99 healthy people, 1 infected person, you will be getting 100, like that. And then H0, 0 is the time. At the beginning, H0 is equal to n. 100, all the 100 people were healthy. And infected people, no, H0 is equal to n. Yeah. So we have n plus 1 people, n are susceptible. So H0 at the initial stage, H0 is n. And how many people are infected? Just 1 person is infected. So I0, T is equal to 0. Initial stage, that I0 is equal to 1. So what we do is, the information given in the earlier 2 lines has just been put in the mathematical form. Next, a susceptible person, healthy person gets infected. It is likely to get infected when he comes in contact with an infected one. And mathematically, we can say that the rate of increase of the infected class is proportional to the product of the susceptible and infected person. Hence, the susceptible class also decreases at the same time. The system of differential equations given by, I give some reference of one book that person has built up. So what does it take? S ds upon dt. In differentiation in mathematics, dy upon dt. What does it give? Dy by upon dx? Rate of change of y with respect to x. Here ds upon dt. What is s? is the class of susceptible person. Yes, it is a function of T. When T changes, S changes. S depends on T. The number of people, S depends on T. Today, if suppose 200, tomorrow there will be change. Day after tomorrow. So if T changes, S changes. So S is a function. So ds upon dt, rate of change of susceptible person, it is reducing. Susceptible, healthy people, because some of them are going infected, and that will be reduced. So we say that you should the last two line. The susceptible class also decreases at the same rate. It is proportional to the product of susceptible person, infected person. So proportion means alpha times ST, decreasing, so negative sign. And then what about the infected people? Infected will be, rate of infected people will be going up. And how they are increasing? They are in proportion of the product of susceptible people and infected people. So it is multiple of alpha times SC. So di upon dt, rate of change of infected person is alpha times SC. Now you would say that S is given, I is given, what is alpha? But alpha can be found. So what do we want found? What we wanted to find? We wanted how many susceptible. If T is equal to 10, today's situation is given. If T is equal to 10, what will be total number of susceptible people? What will be total number of infected people? This is the purpose. Initial stage is given, and you can fix up T. You start from today, and you say that after 17 days, what will be total? Because at initial we have 100. Out of 100, 99 are healthy, 1 is infected. You want to predict after 18 days, how many people will be susceptible, how many people should be infected. And then if you solve this, what will give you if you solve the first equation? What you get? ds upon dt. You can separate the variables and find the value of st. What does st give? T. We have t is equal to 18. You find the value of st. We solve this equation and get the value of st, and like. So maybe depending on the assumptions, we just refine our equation ds upon dt, put out di upon dt, rewrite them, integrating and using the integrating. So if we find the solution, you can get S number of susceptible person, healthy people at time t. Will be given by n into n plus constant. They can be determined in a given situation. And what about IT? Number of infected people at time t. Is equal to 18. You find IT. Is equal to 20. You find the infected people on 20 days. So that is given by the formula IT is equal to n plus. N is already given upon n, already known. P already known. Minus n plus 1 already known. Beta can be decided. T is equal to 20. If you want to fix up the number 20. And at T becomes larger. If T becomes 20, T is 50, T is 60 days, what happens? If T goes to infinity, number of healthy people will go to 0. All people should be infected. So ST will be going to 0. And that you can observe of the formula. And then IT, number of people, all healthy people will be infected. So IT will be going to n plus 1. And this I can observe. So thank you very much. I have some other things, but considering the notation, I.
Yes, sir. So thank you, sir, for giving such a nice lecture. Sir covered the topics, pure and applied mathematics, as well as computational mathematics, mathematical modeling, Sir has given the touch to use of AI in teaching and learning and research, use of mathematical softwares in teaching, learning, and research in mathematics. Also, he explained mathematical modeling of a real-world problem, various forms of mathematical models, bank account problem, Newton's law of pooling. So he explained in nice manner. If you have some doubts or problems, you may contact to Dr. Shikre sir. Any questions regarding this? You may ask the question. If you have any question, you may ask. Or okay.
Reference book. If any one of you are interested, you can find more. Right now, I am our more things we are doing there. Rigorous. In our syllabus, and you will not, but you'll get just idea, that how mathematical modeling is done, because within half an hour or 45 minutes, you can't do much. But I think you get the flavor how this mathematical modeling is done. So if you want to know more things, maybe you can go to.
Thank you, sir, for delivering a nice lecture. If there is no doubt, I conclude this first session and hand over the charge to Maitri madam. Thank you.
Thank you very much, sir. I request all the participants for a big round of applause for chairman as well as keynote speaker. Now, may I request our principal, Dr. Ruturaj Boa, sir, to give a token of love to the keynote speaker, Professor Dr. M.M. Shikhare, sir. Please, sir. Thank you very much, sir. Now the next session will start. The chairperson for the next session will be Dr. J.D. Mashale, HOD, Department of Mathematics, Punyashloka Ahilya Devi Holkar, Solapur University, Solapur. Welcome you, ma'am. May I request our academic advisor, Dargo Patil sir, to call upon the chairman of the session with a memento. Achha. Thank you very much, ma'am. We are really happy to have you with us. I'm the resource person for the session 1. That is, the topic is recent developments in graphs and hypergraphs on algebraic structures. The resource person is Dr. Sachin B. Ballard. Sir is from School of Mathematics and Statistics, University of Hyderabad, Telangana. Sir, please. Thank you very much. Now I request chairperson of the session 1 to welcome the resource person, Dr. Sachin B. Ballard, sir, with a memento. Thank you very much, madam. May I now request the resource person to please come on the dais. I now hand over the dais to the chairman of the session.
Good afternoon to all. Firstly, I welcome all the delegates for this one-day national conference on recent trends in mathematics, organized by Sangameshwar College, Solapur. I take this opportunity to share with you all that I am the alumni of this college, passed my BSc in 2005 under the guidance of Dr. A.S. Dhone, sir. Dr. A.S. Dhone, sir, has played a crucial role in shaping my career as a teacher. Thank you, sir, for being with me as my teacher and guiding also. I take this opportunity to thank each and every teacher who taught me during my college days. Also, I thank Principal Dr. Bua, sir, for giving me an opportunity to be a part of this conference. Thank you one and all. Now let me introduce the resource person of this session, Dr. Sachin Ballar, sir. Dr. Ballar, sir, is currently working as an associate professor in School of Mathematics and Statistics, University of Hyderabad. Sir is having an educational qualification, MSc, SET, PhD. Sir has completed his PhD under the guidance of Dr. Vilas Kharat, sir, and also received a Padma Shri late N.S. Venkateshan Gold Medal Award for Best PhD Thesis in the year 2015-16. Sir has started his career as a lecturer in ZP Patil College, Dhule in 2008. Later got selected at Savitribai Phule Pune University, Pune, and worked there from November 2008 to June 2022. Then switched to University of Hyderabad as an associate professor. Sir has organized total 11 academic events, which includes national and international level workshop, conferences, SETNet workshop, etc. Sir has given many contributions to academic and administration, such as member admission committee, member library committee, earn and learn scheme, hostel in charge, department exam cell, member IQSE, class coordinator, member placement cell, head department of mathematics, chief rector, member Avishkar, syllabus committee, and much more. Sir is actually having a quite extensive biodata. I am just focusing on the key points. Sir has a large number of publications to his credit at national, international level journals, UGC Care journals, also the Scopus Index journal. Sir has actively participated in more than 30 national and international conferences for presenting his research work. Sir also worked as a resource person, session chair in more than 10 conferences, also giving expert talks at various universities of Maharashtra, including Shivaji University, Kolhapur, Pune Shlok Ahilyadevi Holkar, Solapur University, Solapur, Savitribai Phule Pune University, Pune, North Maharashtra University, Jalgaon, Swami Ramananda Tirtha Marathwada University, Nanded, Institute of Science, Mumbai, SGM College, Karad, Dattakala College of Engineering, Bigwan, Kaveri College of Arts and Commerce Science, Pune, Tuzaram Chaturchand College, Baramati, Modern College, Baramati, Indira College, Pune. Sir is also a life member of Indian Mathematical Society, also working as a reviewer for American Mathematical Society Reviewers, and received many prizes to his credit. Also working as a BOS member of various colleges and universities. And heartily welcome you, sir, for this session. And today, sir is going to deliver a talk and sharing his insights on the topic, recent developments in graphs and hypergraphs and algebraic structure. Welcome you again, and I request you to please start the session. Thank you.
First of all, let me thank organizers, Principal Dr. Bua sir, convener of this conference, Dr. Dhone, Dr. Gade, co-convener of this conference, and all the organizers. And so, as title of this conference is Recent Trends in Mathematics, so I have decided to discuss what are the recent developments in the area of algebras. Now, this talk involved many basic subjects like group theory, ring theory, module theory, graphs, and say some lattice part and algebraic topology. So these many topics will be involved in this. So that talk will be technical. So I'll try to the level. I will try to adjust the level because as I discussed with Professor Dr. Gade, that he told that the crowd will be mixed. That there will be BSc students and MSc students and faculties from various colleges. So I think that this will suit the audience. So let me. So this is outline of my presentation. It consists of basically hypergraph is a generalization of graph which is introduced in say 70s, and it has many more applications as compared to the graph, because in graph we have a vertex set and edge set. Edge means we are connecting two vertices. That is the limitation in case of graph. But in case of hypergraph, we can connect any number of vertices. So if we limit our vertices to 2, then that will be an edge. And then in that case, in hypergraph, we can connect any number of vertices. So in this talk, so first part, so this work which I am presenting here, which is my work this with my students. One student is Miss Ardra, and she is working on hypergraphs on groups. And we are specifically working on hypergraphs of finite groups. And this work is truly recent because just we have communicated this work, and this is started. The first paper on hypergraphs on groups is published in the last part of 24. So this is more recent. There is nothing like recent than this. So this is the right time. So this is introduced by Peter Cameron, and the paper which I listed here, which is published in 2024. Now, till now, that page numbers are not assigned, but paper is published. And before that, let me tell you, before this paper published, we started the work of hypergraphs on groups in 2023. My student registered in December 23, and she was completing her coursework. During that time, we started working on it, and the people, this group, this is abroad, and so two people, Indians, they worked and they published the work. So in research, we have to be on toes. If you start something and if you be lazy, then there will be a risk. Okay, so the topics, this is a very hot topic, and those who are interested, there is a tremendous scope to work, because nowadays working in only one area will not be sufficient. There will be an interdisciplinary research is expected, and algebras and discrete structures together, there will be a more scope. So as I mentioned, it's a hypergraph is a generalization of graph. And in the second part, so I will be distributing this work in 3 parts. That first part will be a hypergraphs on groups. Specifically, I will discuss only one type of group here, which is easy to understand. And in the second part, I will talk about the hypergraph on rings. And that is the joint work with one of my postdoc student. Now she is in UAE. And whatever work we did together, so I'll present that work if time permits. And third part, that is with one of my student, we worked on modules. So modules with lattice theory structure. So basically, so all those topics, students already they are introduced, groups, rings, and modules, and with the graph structure and little bit lattice theory and some kind of topological and specifically algebraic topological approach. Okay, so I'll see that at what level I can go, but I'll try to give justice to all these topics. So this is the formal definition of hypergraph. Hypergraph is a pair consists of vertex set and edge set. And here the edge set is nothing but the subset of vertex set. So here, for understanding purpose, what is this structure? I have just given a day-to-day life examples. So what is mean by vertex collection? What is mean by edge? How we connect the vertices? So for a very first example, I have consider set of peoples, whichever group. Suppose this is the collection. These are the peoples, and how to have an hyper edge. The hyper edge is family. Okay, so family. What are the members in the family? They will be in the hyper edge. Suppose some family, mother, father, and son, daughter. Suppose that these members. So how many combinations? Some families has 2 members, 3 members, 4 members, 5 members, and so on. So that is the basic example. So you can collect whichever collection you choose. It may have that some family may have a singleton element. So this is isolated vertex. So second example is consider all students in this hall and connect what are the hyper edges if they belongs to the same college, because here the students may be from different colleges. Then who are the people? Maybe 10 students from the one college, 5 from the another college. So they will constitute an hyper edge. So hyper edge, in case of graph, we can join only 2 vertices. In case of hyper edge, we can connect more. Third is collect all authors of books or publications, and hyper edge if 2 or 3, whichever members, if they are co-authors together, then we can have then in one hyper edge. So all authors, you have a collection of authors, and then check which of them are co-authors of paper or co-author of whichever article. Then next is collect all students from the college or university, and what is the hyper edge between them is the students enrolled for the same course. If some students are registered for, say, course Algebra, say economics, which are say chemistry, whichever courses, so this will be the hyper edges. And so on. So quickly, because without spending too much time. So if you go to the supermarket, is those many people in the supermarket, and what is the products in the supermarket is the vertices, and what are the hyper edges? So what number of items you purchase in the basket, that is the hyper edge. So you can have, so these are the examples, and say actors, directors, crew members, and what is the hyper edge is belong to the same movie. Okay, so movie is the hyper edge. As many actors, they are working in different films. So collect actors, directors, and crew members. So you can define your hyper edge. So these are day-to-day examples of graphs and hypergraphs. So take computers, all computers here. And what is the hyper edge? That group data transfers. For example, video conferencing. Whatever computers you are using for video conferencing is the hyper edge, and so on. Say this is again a day-to-day example that collect all ingredients in your home, and from that you prepare some recipes. Okay, so that is a hyper edge, and so on. Now you think about examples, you can find out as many examples are possible. These are day-to-day examples. Okay, so what are the applications? Because this is not my topic of just to give the idea where are this you can find. So chemical graph theory already Professor Shikare pointed out many mathematical modelings. Okay, so in chemistry, Dr. Sheikh sir is here, and so he can relate more that models have a structures, and those structures there is a very advanced what I remember is Professor Shikare has one publication with very eminent chemist, and who got very large number of citations. So he is working in graph theory and chemistry. So chemical graph theory, I'll just highlight the some topics. So hypergraph theory for telecommunication, and hypergraphs in machine learning and data modeling, classifier regularization, and image retrieval, databases, recommender systems, and bioinformatics, and so on. There are many areas where this hypergraph is nowadays, because this artificial intelligence, whatever is going on, effectively using these hypergraphs. So there is more things to do by using these hypergraphs. So let me now, this is the technical part. So whatever just I discussed is just the introduction and applications and basic examples, which are related to even non-mathematician can understand whatever I just discussed. But now what is the technical thing? As I told that my topic is hypergraphs on groups. So very first part is this. So here how one can define hypergraph on groups. So take any group. Here we are specifying ourselves to finite groups, but definition will be general. For general group, given a group, collect all non-trivial proper subgroups of G. And what is the vertex set? Vertex set consists of non-trivial proper subgroups of G such that whose intersection with some another subgroup should be equal to identity. They should be non-trivial proper subgroups. So they are not equal to G and they are not equal to identity. So collect all this. This is a vertex set. And what is the hyper edge set is nothing but we are collecting if two members in the hyper edge means that their intersection should be identity. Note that they are not proper and they are non-trivial. And this set must be maximal with respect to this property. Then this will be a hyper edge. Now, to understand basic, here we are restricting ourselves to the one particular type of well-studied group, that is a dihedral group. Dihedral group means where we can draw the geometry. Okay, so that is, it consists of elements are rotations and reflections. So we have a control over the geometry. If you consider any regular n-gon, then we can find out the symmetry of all the symmetries of that regular n-gon, and we are denoting it by dn. So very first example is called as a Klein-4 group. Before that also you can consider a group of symmetries, but consider Klein-4 group. It consists of 4 elements, identity ABC, and what is the operation is the multiplication. Here ABC elements are of order 2. And what is the multiplication between A and B? A, B is C, and BA is C, and so on. Okay, so definition, formal definition is given here. And what is the hypergraph? So I have here, because this EA, EB, EC are the subgroups of Klein-4 group, and because EA is one subgroup and EB is another subgroup, and they have only identity in common. So they will form, so they will be a part of the hyperedge. Even EC is an hypergraph, sorry, is a subgroup of G, and it will be its intersection with, say, I will say H1, H2 will be identity. So all these subgroups will constitute an hyperedge. So there will be only one hyperedge. So if I consider second example, suppose dihedral group with 4 elements, that is D4. The definition is, because it is D4, A to the power 4 is identity, and B square is identity, and BA, B inverse is same as A inverse. So in this group, dihedral group with 8 elements, so I have listed the subgroups H1, H2, and so on, so which are listed there. And by using them, I have constructed a hypergraph. Here you can find out that circles or oval shapes are nothing but the hyperedges. I have given their names. So if you look at the E1, what are the members of that E1? E1 consists of H2, H3, H5, H4, H6, and H7. While E3 consists of H3, H5, and H9. E4 consists of H4, H6, H8, and so on. Okay, so here we can observe that the number of vertices in hyperedge will be different. In case of E3, there will be 3 vertices. In case of E4, there will be 3 vertices. But in case of E1, there will be 1, 2, 3, 4, 5, 6 vertices. So So this is the formal definition of dihedral group of order 2n. It will be generated by two elements, AB, and A raised to power n is identity and B square is identity, and BAB inverse is A inverse. So we are referring very important theorem by Conrad, and which says that, which categorically enlist all the subgroups of dihedral group. Number one, all the subgroups type 1 are cyclic, and second, again we are calling it as a dicyclic subgroups. Okay, there will be only two types of subgroups in this group, so it is easy to understand, easy to handle. So any finite subgroup can be handled if you know their subgroups. So here, as I mentioned, that subgroups of type 1 are called as a cyclic, and subgroups of type 2 are called as dihedral subgroups. So here we note that we are not taking n equal to 1 for D1, because if you take D1, then there will be, this graph will be the empty graph, and we are not interested in empty graph. So onwards, if I refer Dn, means I am referring n is greater or equal to. So here, the very first result that we have proved is that the graph, hypergraph on Dn is non-empty, because that is our first requirement. Whatever we have to study, a set, the set must be non-empty. So whatever hypergraph we are considering, we have to ensure that it is non-empty, and that is guaranteed if you assume that n is greater than 1, that is n greater or equal to. And not only that, in this case, all non-trivial subgroups constitute the vertex set. So all non-trivial proper subgroups of Dn will be in the vertex set. So very first result that we have obtained is that those hypergraphs will be connected. So very important property of a graph. So in this constraint, that hypergraph of a Dn is connected and its diameter is less equal 3. And not only diameter less equal 3, we have established when diameter is equal to 1, when diameter is equal to 2, and when diameter is equal to 3. Diameter is 1 if n is a prime number. Diameter is 2, so diameter is 3 if n is of the type 4k. And in all other cases, the diameter will be equal to 2. Please stop me exactly after 30 minutes. So here, so for the sake of completeness, to understand how these algebras and graph theory works together, I have given proof for understanding of, because I know that here even UG PG students are here. So how this proof works and how these two interdisciplinary subjects are connected together. So I have given the proof here. If you want, you can discuss me after the class, but just let me quickly go through. So here, because we are working on finite sets, so we have to deal with the cases. That what happens if you choose, if their intersection is identity of two subgroups, then definitely they will constitute a hyper H. If their intersection is not equal to identity, then we will have a cases. So what happens if both the subgroups are of same type, type 1? What happens if one is of type 1 and one is of type 2? Then in that case, we are getting two hyper edges, and there will be one vertex H3 will be common to E1 and E2. Okay, so in this case, the distance between H1 and H3 will be H2 equal to 2. So third case will be what happens if both are of type 2. So these are the only exclusive cases, and in all the cases, we are getting that in the case 3, we are getting the distance between H1 and H2 is equal to 2. So here, so in case 3, so this is the situation that H1, for H1 we are finding a subgroup K1, and for H2 we are finding subgroup K2, so that we will have H1 K1 is in E1 and K2 H2 is in E3, but there is an hyper H connecting K1 and K2. Okay, so in this case, the distance will be between H1 and H2 will be equal to 3. So how to calculate a distance? You start with one vertex and start with the raised to that vertex, but in between you have to connect it by E1. Means it is H1, E1, then K1, then E2, then K2, and then X2. So also we have considered some subcases, and here what happens if that n we have chosen, if it is a prime number, in that case we are saying that this hypergraph has exactly one hyperedge. That we have observed in case of Klein 4 group, because it is D2. Klein 4 group is nothing but D2. So because it has 4 elements. So 2 is a prime number. So in prime number, we observed that there are all the 3 subgroups that were in the same hyperedge. So in that case, also we have characterized this graph is nothing but a star graph. And this is the explicit proof. But due to the lack of time, I'll just skip the proof. But if someone is interested, I can discuss the proof with them. So I need some preliminaries to establish more results about, say, hypertree. So a host graph for a hypergraph is a connected graph on the same vertex set such that every hyperedge introduce a connected sub-hypergraph of the host graph. And hypergraph is called a hypertree if there exists a host tree such that each edge of that hypergraph introduces subtree in T. So there are more results. So Hilly property, a subgraph H is said to have a Hilly property if for every subfamily of its edges have the following property. That is, if every 2 edge of subfamily has a non-empty intersection, then all subfamilies have a non-empty intersection. So by using this definitions and known results, we have established that the hypergraph on Dn is a hypertree if and only if it must satisfy Hilly property as well as the line graph of that hypergraph must be a chordal graph. And one more characterization we have obtained, that it is a hypertree if and only if. What is the restriction on n? So n should be either a prime or n must be equal to 4. In all other cases, it will not be a hypertree. So we have established the algebraic, we have used the algebraic property, or in fact number theoretic property of say numbers, and we have characterized that hypergraph on Dn is a hypertree. And this is the proof, but I'll skip it. And this is very important aspect in case of graph. So what is the girth of this graph? So here we have proved that the girth of this Dn, girth of hypergraph of Dn is either 2 or infinity. And we have given the explicit proof for this. So one more approach to look at very celebrated problem. This is called as a coloring problem in case of graph theory. And so we have studied what happens to that coloring problem. There is one famous conjecture in case of graphs, which is called as Beck's conjecture. It has to do with the chromatic number and clique number. So for establishing that Beck's conjecture, we have found what is the chromatic number of hypergraph on Dn. So here we have proved that only 2 colors will be required to color the hypergraph on this Dn. So this coloring of hypergraph, there are multiple approaches to look at the coloring of hypergraph. There are various definitions. Coloring with the help of vertices, coloring with the help of hyperedges. So we are following here the coloring of hypergraph in the context of hyperedges. So here the proof is given. And now this is very famous result in case of hypergraph with respect to the planarity. Slowly we are marching towards discussing the topological approaches of graph. There are some topological properties established for graphs. One property is the planarity of the graph. Means can we draw the graph on the plane? So plane is a 2-dimensional object, And the next approaches will be, can we draw it on the 3D object? And what kind of 3D objects will be there? So that we'll discuss in the latter part. But for graph, what is known result is that graph is planar, means we can draw the graph on plane. If and only if there will be two forbiddance for it, contains no subdivision of K5 or K33. If they are present in your graph as a subgraph, then your graph will not be planar. So we have make. So this is for understanding purpose. This is K33. So when to say that hypergraph is planar? So there is a one characterization that hypergraph is planar if and only if its incidence graph is planar. So if you want to deal with the hypergraph, so it's easy to deal with its incidence graph. And some few more results that theorem 7 says that for any hypergraph, the girth of hypergraph and girth of the incidence graph will be same. So planarity of this hypergraph is characterized with the help of numbers. So the hypergraph is planar if and only in two cases, the number will be prime or that number will be equal to 4. These are the only two possibilities in which the graph is planar, means there is a much more scope to deal with non-planarity. And if you go with non-planarity means you have to go for the higher dimensions, more than dimension 2. So dimension 3, dimension 4, and so on. So here the problem is interesting because you don't have a control. You cannot draw it on the plane. So geometry will be interesting. Okay, so things will be complicated after 2 dimension. Writing on the board is easy, but if in 3 dimension, the visualization is difficult, so things will be complicated. So we need some more concepts like orientable genus, non-orientable genus, and cross-cup, and so on. So these are the technical things. And so I'll avoid, but what I'll discuss is when this graph is non-orientable, and that we have non-planar first. If it is non-planar, if and only if its orientable genus must be at least 2. So means we can draw, when it is not, we cannot draw it on the plane, then the next approach is, can we draw it on the torus? What is torus? Torus means it is the, you can attach, so you can think of a mug, coffee mug, and a donut. Okay, so that is nothing but, and there is a joke. People say that topologists cannot distinguish between coffee mug and the donut. They will feel that they are same things because one can be deformed from one to another. So it's a funny thing. So means what? Can we draw a graph on the, say, donut or torus? Okay, that is the now 3D object, because here you have an edge. You can pass through the hole which is in between the torus. So second approach is, can we draw it on the double torus? Because there will be 2 holes and so on. So first approach is, can you draw the graph on sphere? Next approach will be, can you draw on the torus, double torus, triple torus, and so on. So this is called as genus 1, genus 0, genus 1, genus 2, genus 3, and so on. So here we are saying that if the hypergraph on Dn is non-planar, if and only if the orientable genus is at least 2, it should be different from genus 0 and genus 1. It may be 2, it may be 3, it may be 4, and so on. Okay, so there is a much more scope that what kind of numbers, for which number n, you can find out the genus is exactly equal to 2, genus is exactly 3, genus is 4. So I am giving as many problems, and at the end I will discuss what are the recent 2024 open problems raised by Peter Cameron in case of groups. So this is the proof that is showing that the genus is greater or equal to, and here as a consequence, we are saying that this is non-planar, then it cannot be embedded on the torus, because torus means the genus is 1. So it cannot be drawn on genus 1. So you have to go for genus 2, means at least you have to go for double torus. And in this case, so these are some things required for proving again non-orientability. So the first result says that when it is orientable, and second result says when it is non-orientable. In both the cases, the non-planarity of the hypergraph is guaranteed if the genus is at least greater or equal to. How much time? Huh? Okay. So these are the graphs which are obtained from, in case of non-orientability of the genus of hypergraph, and with respect to the different cases. So here cases are considered. So first case is what happens if n is equal to 6, if n is equal to 8, and when n is greater or equal 9. So in the remaining cases, this doesn't work because we have to avoid prime number and we have to avoid it is different from 4. So all the numbers before 4 we have to avoid, and 2, 3, 5, these are prime numbers. So we have to avoid prime number and we have to avoid the 4. So what happens for 6, for 8, and for 9 onwards? So we have dealt with all these cases. And as a consequence, so we can say that this graph is non-planar, then it cannot be embedded on the projective plane. Means it cannot be embedded on the sphere. And in case of this graph is either planar or has both orientable and non-orientable genus to be greater or equal to, at least 2. So this is one approach. So far, I have discussed results with respect to the intersection. If we take two subgroups, which are non-trivial proper subgroups, then if their intersection is identity, that graph, hypergraph, we are calling it as intersection hypergraph. And that work is communicated 4 months before, and we are expecting the result soon. But this is the work started in this direction. And just only one paper, their approach is altogether different. They are working for the elements of the group, and we are working on the subgroups of a group. So approaches are altogether different, but we started the work at the same time, almost same time. So the second approach, in case of the same group we are tackling, but we have defined some another hypergraph. You can define various types of graphs on the finite group. So second approach, we are calling it as a co-maximal hypergraph. Here also the vertex set is same. We are collecting all non-trivial proper subgroups, but here hyperedge will be different. What is the hyperedge here? Hyperedge is if we collect two vertices, then they will be in the same hyperedge if their product is equal to G. So because we know that in case of subgroups, the intersection of two subgroups is a subgroup, and the product is a subgroup, product of two subgroups, because it is the maximal subgroup containing both subgroups. So this is also a subgroup. So we are ensuring the existence of subgroups, and that is guaranteed if you take their intersection and if you take their product. So this is called as maximal, and if you take two vertices, then their product will be equal to G. And whatever collection you choose, that collection must be maximal with respect to this property. If you choose any two member from that collection, their product should be equal to G. And there should not be any now subgroup outside that set, so that its intersection with all will be equal to G. This is called as maximal with respect to this property. And so we have, so this is again examples. So if you remember the hypergraph, the intersection hypergraph on Klein 4 group looks like the same. But if you observe that the intersection hypergraph on DN was looking different from this group. So all these collections, even if vertices are same, the graphs, hypergraphs drawn are altogether different. So you can have a different information, different knowledge from whatever we discussed. Okay, so in this case, again, the similar kind of results we have obtained. Then in that case, whether this graph is connected, then in that case, what is the diameter? And so again, the cases we have discussed, when that hypergraph is a star hypergraph. In the previous case, it was a star hypergraph if and only if that n is prime, if you remember. But here in this case, it will be a Star hypergraph, if and only if it is if P n is power of a prime. And so what is the girth? What is the girth of this graph? It will be again 2 and infinity. And when it is infinity, if n is 2 and or n is power of a prime. In these two cases, we are getting the girth is equal to 2. And otherwise, in all cases, we are getting girth to be equal to 2. So explicitly, we have proved that when the girth, what is the girth of this hypergraph? So it is interesting to note, can you find out a graph? Can you find out a group, finite group whose girth is equal to 3? So I am here raising a problem to find out a group, finite group, whose girth is equal to 3, whose girth is equal to 4. So these are the problems one can tackle. So like in this case also, the chromatic number we are getting it is equal to 2, means only 2 colors will be required to color all the vertices in this graph. So here, these are some important lemmas and theorems which we required, which we have effectively used to prove some deeper results in this case. So here, very important that I told you that in the hyper edge, there will be different number of vertices. So can we have, do we have a situation where whatever hyper edge you choose, it can have only say 2 number of vertices. So that is possible because it's our regular graph. Okay, so hypergraph in that case, it is a so 2 uniform hypergraph because every edge consists of 2 vertices. But can we have that situation where there will be only 3? Whatever hyper edge you choose, can we have there will be only 3 hyper edges? So this we call it as a 3 uniform hypergraph. So likewise, we can have 4 uniform, 5 uniform, and k uniform hypergraphs. Means what? Whatever hyper edge you choose, all hyper edges will have a similar same number of vertices. This is called as a k uniform. So here we have characterized the 3 uniform hypergraph when the hypergraph on Dn is 3 uniform if and only if that n should be power of 2. So question remains when it will be 4, when it will be in general k. So when that is a hypertree, again, it will be equal to n equal to p to the power alpha. So this results that when it be planar, when it is a power of a prime, if it is not a power of prime, then it will not be planar. So there is a much more scope that if it is not planar, things will be difficult, but you have a scope to work on. Then if it is not planar, then the genus will come in picture. That what is the genus? It is 0, it is 1, it is 2, and so on. So here, 5 minutes. Okay. So quickly, I will go through this. Orientable genus for this hypergraph is again at least 2 for pi of n. Pi of n is the notation involving product of distinct number of primes involved. So there should be at least 3 distinct primes involved in the product of a number. Means what? For example, if you take n equal to 16, is it a product of 3 distinct primes? It's not. It's a product of only 1 prime. So it's not allowed. So in that case, the genus cannot be, genus should be 0 or 1. So if you want genus to be greater or equal to, then your number, whatever you are choosing n, should be contains at least product of 3 distinct primes. And this is the proof. And what we have proved that if your number n consists of 3 distinct primes at least, then in that case, your hypergraph cannot be embedded on the torus. So it means that the non-orientable genus of this hypergraph is at least 2 if your number consists of product of 3 distinct primes. And it cannot be embedded on a projective plane. So this is the first approach that what are the possible hypergraphs on subgroups of a finite group. So I have discussed 2 approaches. There are many that we are working on. And the second approach, as I told you, because of time constraint, I am just giving the idea that I'm skipping the work on graphs and hypergraphs on rings. But there are many people are working in this area from last 10 years. People, all algebraists who are working in different algebraic structures, because working in only one area will be, after some time, it will be very difficult because there will be many technicalities involved. So you have to go to the interdisciplinary approach. So the second topic that I'm discussing here is the Lie modules. So here is the formal definition that Lie module means, here I'm considering M to be a Lie semigroup, means it is a commutative monoid with 0 element, and here we are introducing a lattice structure on it, but that we are considering over a commutative ring with unity. So here we are involving commutative monoid, means a more general structure than a group, and lattice, but specifying a specific type of lattice, which is a complete lattice, and over a commutative ring with unity. So multiplication we are taking over commutative ring with unity. And so these are some examples, and this work is started in 2019. And in last 2 years, we have published 2 papers in this area. One is in 2023 and one is this year just published, and one is today I only got that, which is online available, is the 3rd paper. Backside, okay. Sir, what is the question? It's not VI, it's less equal. So this M plus is a commutative monoid. M with respect to less equal is a partial order relation. With respect to that partial order relation, it's a complete lattice. Okay, and that E stands for, this is the special element in this Lie module. It is the maximal element of that complete lattice. Okay, so this M plus is a commutative monoid, and this less equal is a partial ordering. So we are defining ordering on a algebra. So this is one of the approach that ordered algebras, so ordered groups, ordered rings, ordered modules, different algebras, there you can draw the pictures. And if you draw the pictures, then you can easily understand the algebras. Many properties you can deal with if you know the diagram, then you can easily understand how this group looks like, how that subgroup looks like. Many properties you can derive with the help of that. So this is another approach to look at. Correct. So that is hypergraph on DN. So yes, because just we have started the work, we are exploring different types of groups, because see, handling finite graphs is comparatively easy. Handling finite graphs will become comparatively easy. So that's why we started with the DN. But we are working on all finite groups. We are restricting different classes of groups, and we are working. So there is correct. 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 So what is meant by diameter is infinity means what? To reaching from this end to that end means you need an infinite graph. No, because we are considering finite graphs. No, in case of, if you want diameter to be infinite, you have to go for infinite graph. Possible. See, but handling will be difficult, because see, if you take infinite graph, there will be infinite subgroups, and handling them will be difficult. See, whatever. It's possible. You can draw the graphs. It's possible. It's possible. But handling them explicitly, studying them will be difficult. See, because finite things, in case of applications, even cryptography, you are handling only finite things. Even whichever matrices, mostly you are dealing with finite matrices only. Even infinite matrices handling is possible. But as an application point of view, handling those and doing more exploration about those studying those things in detail will be more helpful, because for the application point of view, most of the things will be finite, but you can handle this one. We can handle. That is not an issue. Okay. So let me quickly, so these are some natural examples of Lie modules, which is in terms of algebra. So here we can derive it from, so we did a task and we are succeed in it that, see, starting from, we have two approaches to look at the structure. One structure is that look at some algebra, say groups or rings or modules, and from that derive the examples of Lie modules. And second approach is because I'm trained a lattice theorist and algebraist, so I started it from the lattice theory. You give me whichever lattice, and then from that I can derive any number of examples of Lie modules. So number of things are possible, and see, this approach is completely new. Approach is that given any Lie module, can you find out number of possible additions and number of possible scalar multiplications. So we have tried many possible cases. We have obtained all possible additions and all possible scalar multiplications. So let me quickly go to this concept. So here we have defined a graph on Lie modules. And this paper is just published in 2021. And here how we have defined a graph. 5 minutes, okay. So here we have considered the set of all submodule elements is a vertex set, and we have, now this is a graph. We have connected two vertices if their sum of two elements equal to the largest element of that lattice. Okay, then there will be an edge. So some example here, if we consider M equal to AI and BI unions where I belongs to natural number together with 0 and E, the lattice is given here. And if you collect, we have defined addition of AI AJ to be equal to A1 and BI BJ to be equal to B1 and AI plus BJ equal to E. With respect to this addition and what is the scalar multiplication we are defining, we are saying 0 into X is 0 and 1 into X is X. But what happens if you take one element from M and one element from Z, because we want a scalar multiplication, so it will be the scalar multiplication as it is that we can naturally define. So this is the graph and these are the operations we required. Suppose, for example, if you take Z4 is a module over Z4 and look at all those elements, say 0 is singleton 0, X is 0, 2, Y is 0, 1, 2, and Z is 0, 1, 3, and E is Z4. So with these notations 0, X, Y, Z, and E, define addition, the table, Kelly table is given, then scalar multiplication table is given. With respect to this M, which is a set 0, X, Y, Z, E, becomes a Lie module over Z4. And in that case, what are the submodule elements? Are 0, X, and E. So this is the lattice diagram. And so what are the, so some properties with respect to this graph are obtained. So these are some preliminaries required. So I'll skip those. But again, look at what are the properties when this graph is a connected n-partite graph. If we have to express this M as a product of mi's, M1 cross M2 cross Mn, and then that each Mi must be a simple Lie module. So then we have tried it to connect it with the topology. We have defined a Zariski topology on this Lie module, and then we have connected this graph with the topology. And we have characterized when this graph is a complete graph, if and only if the topology on that Lie module must be a T1 space. And if our given ring, Zariski topology on the ring is a T1 space, then the graph on that Lie module becomes a complete graph. And not necessarily this converse is true, but it will be true in special circumstances. And this graph is connected if and only if the radical of M, means it is the intersection of all maximal submodule elements, is equal to 0. So here, given the properties of graphs in terms of algebra, establish the properties of graphs in terms of topology. So here you can have a flavor of algebra, graph, analytical approach. So all different approaches we have used and established many results which are, so here you can note that we have established the very famous conjecture of Beck's, that when the chromatic number and the clique number are the same, so in case of, if our Lie module is a coatomic Lie module, then in that case the Beck's conjecture is true. And there are many results with respect to this that we have obtained with the combination. So I suppose that there will be more technical things, but many more results are obtained. So I have to show these references. Just 1 minute, I will take you to that paper. So these are the references. You can find out this reference here. So here, this Cameron paper is just published in this is archive. It is available on 22, but many papers are there which appear in 2024. This is the paper that I was talking about, and this is my student VC Amruta. She did postdoc under my supervision, and I will also share that paper with you. So these are some references, all are recent one. And this work of Lie modules was started by this A.K. Bhunia, which is the recent one, 2018 and 2000 onwards. They have published the papers. And in 2019, I started this work on Lie modules. So just wait a minute, I will just share this paper with you. Okay, so pen drive is you have withdrawn, so okay, no problem. So if you are interested, then I can share you those papers, but they are available online that you can search. But my work on hypergraphs on commutative rings, if you are interested, that part which is not published, which is not communicated yet, but only thing is that I can show you, I cannot share. So most of the things which are not published yet, so I can't share those things with you, but if you want to interact, I am available. Okay, so I thank organizers once again for giving this opportunity to interact with you all. I think that this will serve the purpose that I have motivated some people to and connected with the recent topics which just started after say 2020. So more recent work and the live work which we are doing. So there are opportunities. So all the best to new students which will be entering to the research field. So thank you, Vanamar.
Thank you so much, sir. Sir has given a very remarkable session on this topic, where he has started with introducing what is the definition of hypergraph, which was actually a most recent publication published in 2024. Also, he has given many of daily life examples, mathematical examples, intersection of hypergraphs, connectedness in hypergraphs, hypertree, girth of hypergraph, coloring of hypergraph. Also, he has focused many points such as planarity of hypergraph, genus, graph on Lie modules, Lie modules, Lie tree, much more of the points he has given. Therefore, this area is actually having a lot of scope for the new researchers. Now, I think the session is open for discussion. If anyone is having doubts or queries, you can have an interaction. Sir, I have a question. Can we extend this concept of hypergraphs to soft graphs and fuzzy graphs and rough graphs, as we are working on that areas? Surely we'll figure out.
Whichever concept is there for a graph, you can definitely extend it to the hypergraph. And actually, I will tell you that because this artificial intelligence and machine learning, whatever part now they are doing, because soft graph means what? It's a direct applications to those things.
Yes.
Much more appreciated if you work on those things. Definitions, we have and define it properly so that
Yes,
we'll
yes.
have a more applications. Definitely, day-to-day life, you will find many examples of hypergraphs and you can apply. But if you have an interdisciplinary group, some people in computers and so on, and if they have a some basic knowledge of graphs, then it will be more applicable.
Thank you, sir. Thank you.
Thank you.
And I hope we'll get you a PPT for your further studies. Okay. Thank you so much, sir, for taking your valuable time, coming over here and delivering such a remarkable session on the topic of recent developments in graphs and hypergraphs and on algebraic structure. Thank you on behalf of organizing committee of this conference and Sangameshwar College on my own behalf also. Thank you so much.
Once again, on behalf of Sangameshwar College, I thank the chairman of the session, Mashale Madam, and resource person, Dr. Sachin Ballar, sir. All are waiting for the next session. Now we will have the second session. The topic of presentation is geometric function theory in complex variables. The resource person is Dr. M.G. Srigan, sir. Now I request Senior Professor Dr. Alankar, sir, to please come to the dais and give a token of love in the form of memento, conference memento, to the resource person, Dr. M.G. Srigan, sir. Dr. M.G. Srigan, sir, second session resource person. Sir is working in Department of Mathematics, JSPM University, Pune. Thank you, sir. Now may I request Chairman of the second session, Dr. V.V. Kharat, sir. Sir is working in N.B. Navale Sinhagad College of Engineering, Solapur. Now I will hand over the dais to the Kharat, sir.
Thank you, madam. First of all, I welcome all the dignitaries, all the participants for this one-day national conference on recent trends in mathematics. First of all, I am very much thankful for organizer for giving me an opportunity to work as technical session chair. And I am very much lucky to introduce and my mentor, Dr. M.G. Shirgan, sir. So currently, M.G. Shirgan, sir, was working as assistant professor at JSPM University. He is program coordinator for FY BTech students. He is program coordinator for mathematics. He is academic council member at JSPM University, Pune. He is also BOS chairman of JSPM University, Pune. So he has published national and international journals, so around 24, and he has published 2 patents. So he is reviewer of national and international journals. So he is editorial board member of mathematical analysis and modeling. Also, he is editorial board member of mathematics later. So he is also guiding 3 PhD students. So due to lack of time and a request from a resource person, with this brief introduction, I request today's resource person, Dr. M.G. Shirgan, sir, to start with his talk. And I know that due to some delay, but actually we are from mathematics background. We are very much hungry to listen new trends of mathematics. So I request Shrigan, sir, to conclude within 30 minutes. Thank you, sir. Please, sir.
Thank you, Kharat, sir. I don't want to come in between you. lunch. I will conclude my session within 30 minutes. So first of all, I will extend my thanks to the organizing committee, Professor Dr. Goa sir, Principal Sangameshwar College, the convener of the conference, Dr. Done sir, as well as the co-convener of the conference, Gade sir. Also, I extend my gratitude to Dr. J.D. Mashakar ma'am being here for the session. My today's topic for this session is geometrical aspects, geometrical function theory in complex variable. This is one of the emerging theory in complex variable. We already know the geometry of a real function. On the same line, in complex variable also, we are going to study the geometrical aspects of the complex functions. This geometrical function theory, it is one of the emerging branch of mathematics, complex variable, where we deal with the geometry as well as the analysis of a complex function. All of us have gone through the complex analysis. I will not go into the details of all the basics of the complex analysis, such as analytic function, harmonic function, then Cauchy-Riemann theorem and all. Okay, these are the base of your geometric function theory. So these are the few points on which I'm going to highlight. In this session, I will explain a few of the basic definitions and properties of geometric functions. I will highlight on very important aspects in geometric function theory, and it is the univalent function. The second, one of the important function in geometric function theory is star-like function and convex function. I will try to explain these functions using the example as well as few graphs. Also, I will explain the concept of subordination and the concept of biunivalent function. There are many concepts beyond this in the geometric function theory. Nowadays, there are many applications of this geometric function theory in various areas. This geometric function theory is a branch of complex analysis. I once again explain you, this is the marriage of analysis as well as geometry. Now, this geometric function theory, it is originated in 1907 by a mathematician, Kobe. Kobe, he has written a proof of Grunwald's area theorem. In the proof of Grunwald's area theorem, he had explained a few of the concepts of geometric function theory. See, I am going to highlight a definition which we already know, but I am putting in another words. The concept of one-to-one function and unto function we know in the real variables. The same concept here I am explaining in terms of the geometry. a function f of z, a function f of z which is one-to-one function in complex domain is called as a univalent function. So it is very simple definition. Here, the identity element, I have given one simple example. The identity element z is one of the best example of the univalent function. There are many examples. Also, if I take the example f of z is equal to z square, we know this function f of z is equal to z square. This is not a one-one function. Therefore, this is not univalent in the complex domain. Here, I have given algebraically what is the significance, what is the geometrical significance of this univalent function. That means this univalent function analytically or algebraically, I can write f of z is univalent in D if the equation W naught is equal to f of z possesses a single root or single solution. If this W naught is equal to f of z possesses more than one solution or p solutions, then that is called as a p-valent function. Or it possesses more than that, it is called as a multivalent functions. So this geometrical function theory is beyond this univalent function also. There is a concept of meromorphic function that also plays a crucial role in the applications of the geometric function theory. I will skip the, okay. Now I will define a class S here. This class S, here this class S I can define as f of z is equal to z running a z plus n running from 2 to infinity a n z raised to n. So this is the class I have defined here. This class is called as a class of normalized univalent functions. So this class of normalized univalent function plays very important role in deriving few of the properties of univalent as well as multivalent functions. Here there is a example of this class S. F of z is equal to, if I consider 1 plus z upon 1 minus z, this is one of the example of univalent function, normalized univalent function. And graphically, I tried to picturize it using the maple. Next is the definition of the star-like domain. Few of the definitions I will explain first. Those definitions are very simple definitions. Star-like domain, a domain D. I have defined here a domain D. The domain is said to be a star-like domain if I walk from a point W naught to any of the point in that domain. Okay, all my footprints should be in that domain only. Then that domain is called as a star-like domain. So pictorially, if I say all the points in that domain are visible from that point W naught. So this is the star-like domain. The next concept is regarding the convex domain. This you already know. A domain D is said to be convex if the line joining the any 2 points is inside that domain. All the points in lining the domain is inside that domain. That domain is called as a convex domain. And here there is a theorem I have stated, Nishario-Vaskowski theorem, that if f of z is analytic in convex domain D and real part of f dash of z is greater than 0, then f of z is univalent in D. So this is the one of the most important theorem in geometric function theory. Next, I will come to very important point. That point is star-like function. This star-like function is a very important function in geometric function theory. Here, analytically, Robinson, he is a mathematician who had given this definition of a star-like function. If the real part of z f dash of z upon f of z. If this is positive, then that function f of z is said to be star-like function. I have given the geometrical aspects of it also. The star-like function is a conformal mapping. This is a conformal mapping of a unit disk onto a domain star-like with respect to the origin. And geometrical interpretation of this star-like function is that for any fixed r which is in between 0 and 1, the function argument of that function f r e raised to I theta is strictly increasing when theta is in between 0 to 2 pi. So this is the geometrical aspect of this star-like function. I have given one example also. The function z upon 1 minus z square is a star-like function, and there are so many examples. The Koibe function, a very famous function is called as a Koibe function, that also a star-like function. Next definition is regarding the convex function. This convex function definition is also on the same line we have defined. If the real part of 1 plus z f dash of f double dash of z upon f of z, if this term is greater than 0, then that function is said to be convex. And their geometrical aspects as well as few of the example of this convex functions I have given. But as I said, the Koibe function is not a member of this convex function. Next, this is one of the example which I have given for the convex function. F of z is equal to minus log 1 minus z. It is a convex function which maps from unit disk to a hyperbolic region in the W plane. This is one of the next example of a convex function. Also, we have defined the closed to convex function in 1951. Kalpakan, he defined this concept of closed to convex function. Here f of z is said to be close to convex if there exists a univalent star-like function g of z such that real part of z f dash of z upon g of z, if this is greater than 0, then that function is called as a close to convex function. So geometrically the geometrical interpretation of this is also I have explained here. I will not go into the details, but here there is the proper inclusion. I have given the set of convex function is subset of proper subset of star-like function. It is again a subset of the convex function. So this is the what proper inclusion is there. Then the concept of subordination. This concept is like in a human being, we say he is a subordinate to me. The same way, the same subordination concept we use here in the complex variable also. A function f of z is said to be subordinate to g of z if there exists a source function wz which is analytic in U and satisfies few of the properties. W0 is equal to 0 and mod of that W0 is less than 1, then this f of z is said to be subordinate to g of z. So I have given few examples also for this subordination. Here I have given one example. Here the function f of z is equal to z plus z square, and suppose I define g of z is equal to z upon 1 minus z. Here the function f of z subordinate to g of z. Here I have given few of the steps how it will be subordinate to f of z will subordinate to g of z. Apart from this, I have given one counter example also. Here the function f of z is equal to z square and g of z is equal to e raised to z. Here f of z is not subordinate to g of z because there exists a source function, but 0 square is equal to e raised to z. If I take that, there is a contradiction. That's what this f of z is equal to z square will not be subordinate to e raised to z. Next, the concept of Hermite product. This is also called as a convolution property in complex variable. Here, I have defined two functions in the domain D, f of z and g of z. F of z and g of z, their convolution is given by f of z star g of z. And the geometric series Iz, that is equal to z upon 1 minus z. This is the identity for the convolution or Hermite product. Next, nowadays in geometric function theory, the research is going on various aspects or various properties of geometric functions. In 1916, Ludwig Debrecht, he posed a conjecture, and that conjecture says the value of the function, the value of, here we come across with the function f of z, z is equal to z plus summation n equal to 2 to infinity a n z raised to n. He posed a conjecture that the value of this mod of a n is equal to 2 for n equal to 2 in 1960. And that conjecture for n equal to 2 is posed at 1960, and it will be again proof for n equal to 3, 4, 5, and for n equal to n in later stage. In 1925, J.E. Littlewood, he had given the value for n equal to 3, the value of mod of an is less than or equal to e times of n. He had given the value. Afterwards, this conjecture is being proved by Garrigan in 1951 for the value of n equal to 4. And finally, in 1985, this conjecture is proved for all values of n when mod of an is less than or equal to n. So this conjecture is very important role in the geometric function theory. Nowadays, many problems are around this conjecture. Mathematicians are going to investigate this conjecture for the new classes of biunivalent as well as the bistar-like functions. Nowadays, the new area in the geometric function theory is related to the biunivalent and bistar-like function. I will explain little about this biunivalent function. A function is said to be biunivalent if it is univalent, means it is 1, 1, as well as the function is 1, 1, and its inverse mapping also exists. If the inverse mapping also exists, then that function is called as a biunivalent function. The same concept is extended for bistar-like function also. If the function is star-like function from domain D to W, then the inverse star-like function also exists. If inverse of that will exist, then it is called as a bistar-like functions. So nowadays, the many research is going on in this univalent and biunivalent function. So I have given here. Here, if f of z is equal to the series which I have defined in the first previous slides, here the inverse of that also exists. If the inverse of that exists, f of z will exist, and it is defined by here given by the equation 6, g of z, g of w. Then the function f of z is called as a biunivalent function. And the definition I have wrote here a definition: a function f belongs to A is said to be a biunivalent if in U, if both f and f inverse are univalent. So by using a few of the different methods, the coefficient bonds or distortion theorems as well as the group theorems in these biunivalent functions are to be discovered by many of the mathematicians. Here, while finding the results, The new concept of Q calculus is introduced nowadays in many branches. This is the concept where we use the notation of a limit. Without, here we are taking the differentiation of a function without considering the notation of limit. And here the derivative of any function f of z, it is defined by f of qz minus f of z upon q minus 1 into z. So this is the definition of any function f of z without considering the limit of that function z tends to 0. Now this definition we use to find out our few of the results. I will show the results. I will not go into the details of those results. See, this Q calculus, in this Q calculus, if I take the derivative of any function zk, z raised to k, it is given by 1 minus q raised to k upon 1 minus q z raised to k minus 1, where qk is 1 minus q raised to k upon 1 by q. This is, I will not go into details of this. So this is the concept of Q calculus. By using this concept of Q calculus, we have obtained few of the results in geometric function theory. Here in geometric function theory, the differential operator, many mathematicians, they have discovered differential operators using this Q calculus. One of the differential operator which I have used in my research, and that is a Salehin Q differential operator. This Salehin Q differential operator, it is given by equation number 9. And by using this Salehin Q differential operator, we have obtained few of the results. And for that, I have defined a new function class by using the few of the properties of this bi-star-like and bi-univalent functions. This is the one of the definition. By using this definition, I have constructed a class, and for this class, we have obtained the coefficient bonds. This is the theorem which I have published in recently in Koingpuk Journal of Mathematics, where we obtained the bonds for the first two initial coefficients, mod A2 and mod A3. Similarly, for second theorem, for the second class, we have obtained, and these are the few references. I will not go into the details of the proofs. These are the few references which I have referred. Thank you.
Thank you, sir. Now session is open for discussion. Any questions from audience? Due to crunch of time, it is difficult to handle this session, but experts can do it. Sir has explained the complex things in a very simple manner, and sir has touched various aspects of complex like class S, Q calculus without limit. Those who are interested, they can meet after this session also. And I'm very much thankful for concluding this session within time. And I'm once again thankful for organizing committee for giving me an opportunity. Once again, thank you. Thank you to one and all. Thank you. After this, we can take lunch break due to delay. So those who are presented their paper in offline mode, as per schedule, they can report at mathematics lab at second floor. And those who are attending this session in online mode, so technical chair sessions are ready by 2 p.m. So those who are attending online are requested to please join at 2 p.m. sharp so that we can conclude next session within time. Thank you. Thanks to one and all.
Hello, hello. Okay, am I audible, participants?
Yes, sir.
Okay. Hello. Okay. Anil Dondiram Chinde. Is he there in the meeting room? Anil Dondiram Chinde. Chennaya Durandaya Hiramat. Is he there? Dayan Vyavare.
Yes, sir. I'm here.
Okay. So we'll start with the presentations. The first presenter is Dayanand Kalyan Vyavare. Title of his presentation is Some Bounds on Line K Domination.
Sir, just a minute. Sir, I confused. I'm Sachin Vyavare.
Oh, okay, no problem. So first of all, I will say some instructions here. Each participant will be given 5 minutes to present his work. And I request all the presenters to focus on their findings rather than the introductory part. And 1 minute for question and answer session. So please note the same. Naneshwar Survase, is he there? Nitin Bodke.
Yes, sir.
Okay, sir. Please start your presentation.
Okay, sir.
I request all the participants to keep their presentations ready. Hello, please share your screen. Dr. Nitin Bodke, please share your screen and start your presentation. Dr. Nitin Bodke, please start your presentation. Start sharing your screen. Dr. Bodke, please start your presentation. Fine.
Is my
Yes,
screen
please.
visible? Sir, is my
Start
screen visible? Hello.
Bodke, Dr. Bodke, start your presentation.
Sir, is my screen visible? Hello, am I audible?
Yes, yes, please.
Is my screen visible, sir?
No, not at all. Not at all.
Okay.
If okay, if there is a difficulty, I request other participants till then to start their presentation. Dr. Bodke, are you there? No. Okay, in that case, Chennaya Hiramat, sir. I request all the participants to be ready with their presentations so that the time is not consumed and we'll finish it early. I will again announce the list. Dr. Nitin Bodke, are you there? If not, Chennaya Hiramat, sir. You just unmute and start your presentation.
Okay, 1 minute.
Yes, sir.
Yes, yes. I will start my presentation.
Sorry, sir. Sorry for inconvenience caused. Let me share my screen.
Okay, Bodke, I request you to wait until the first presentation is finished. I requested meanwhile to Chennai Hiramat sir to present his presentation. So after that, I will take yours.
Okay, okay.
So Hiramat
Now
sir,
I can
Hiramat sir,
start.
please start. Hiramat sir, please start.
Okay, okay, okay. I will share the screen now.
Is there any problem in sharing the screen?
Yes, yes. No. Yes, is it
Yeah.
visible?
Yeah.
Visible?
Yes, sir. Yes, sir. Please start.
Yes, yes. Good afternoon to one and all. Title of my paper is on the coefficients estimates of new subclass of biunit functions. In this paper, we have introduced the new subclass of biunit functions already explained by Srigan sir on the unit open disk and using the subordination principle. And we have estimated the sharp upper bounds on the modulus of first five coefficients, that is A1, A2, A3, and A4. And also we have obtained the fixed zero inequality and similar type of inequalities for this type of classes. And in this we have used this lemma. These are the basic introduction part. And we have used this lemma 2.1, that is, if u of z n is equal to 0 to infinity, un z raised to n is an analytic function from an open disk u to itself, then u naught, that is the zeroth coefficient, is less than or equal to 1, and modulus of un is also less than or equal to 1 minus u naught square for all n is equal to 1, 2, 3, and so on. Further, this u naught equal to 0, then modulus of u2 minus mu u1 square, that is a pk 0 inequality, is less than or equal to maximum of 1 comma modulus of u for any real number mu. And this result is sharp for the functions u of z is equal to z and z square. And we have used this lemma to obtain the sharp estimate of the coefficients a2, a3, and a4 and a5 also. And also we have used this lemma, that is lemma 2.2. If this u bar n is equal to un u2 un belongs to the cn, just like rn, with all these uh, components mod uk is less than or equal to 1 and dabba un bar is boundary. If a comma b1 b2 and bn belongs to r and c is a constant such that mod c is less than or equal to modulus of a plus k is equal to 1 to n bk uk on dabba even, then mod c must be less than or equal to this square root of a square plus k is equal to 1 to n bk square is less than or equal to mod a plus this modulus of coefficients of all these bn's. So this is the proof. Also we are given the proof in this paper. And these are the remarks. Also we have used this lemma, and this lemma is also useful for obtaining the coefficients of modulus of a1, a2, a3, and a4. In geometric function theory, obtaining the sharp bonds and coefficients is a major task. So we have obtained, and before this we have defined these two classes, that is sigma alpha beta gamma g and sigma g lambda mu nu delta, and these all parameters are a real number. And this a is nothing but the set of all analytic functions with the normalized conditions f of 0 is equal to 0 and f dash of 0 is equal to 1. And we have defined these subclasses by using the operator or the functions f1 of f of z is equal to 1 minus alpha f of z plus alpha f dash of z plus beta z square f double dash of z. Sorry, am I audible?
Yes, sir. Yes.
Okay, thank you, sir. Okay. And also we have defined this function f2 of f of z by using this condition, that is lambda into f of z upon z raised to mu and this condition. And we have also taken the p and the sequence of real valued polynomial functions of a real number x, and this g of j x comma z is a generative function. And these are the main definition of our two classes. The class sigma g alpha beta gamma, and this is defined in this way: all functions f belongs to sigma, that is a bivalent function, such that this f1 of f of z is subordinate to g of xz plus 1 minus a, and f1 f inverse of z is subordinate to g of x comma z plus 1 minus a. Similarly, we have defined the class sigma g lambda mu neta delta of binomial functions as follows. And by various particular values of the parameters, we have these classes studied by various different researchers, different authors. And this is the bonds on coefficients of the class sigma g alpha beta gamma. So, and if f is equal to f of z is equal to z plus n is equal to 2 to infinity n z raised to n belongs to this class sigma g alpha beta gamma, then
Hello, sir.
the modulus value of
Hello, sir.
sir.
Please conclude in 30 seconds. So time is already.
Okay,
Yes,
these are
please.
our main results.
Yes,
And
please.
similarly, we have obtained the sharp bonds for the functions belonging to these classes and functions belonging to these two classes. And many researchers obtained only up to, also we have obtained the Fick-Zigo inequality, and we have went through obtaining the fifth subclass modulus of the fifth coefficient, that is A5 also. And these are our main results. And we have used that both lemmas, lemma 1 and lemma 2. And these are the sharp estimates of the coefficients for the functions belonging to this class. So similarly, we can define a class and we can obtain the sharp estimates by using this inequality that mod n is less than or equal to bnx.
Okay, thank you,
Okay,
sir.
and these
Thank
are
you so
the
much.
differences. Thank you. Thank you.
Okay, next is Dr. Bodke, sir.
Can I
Hello.
stop sharing?
Okay. Yeah, please.
Hello, sir. Please give me some time. I am
Yeah.
traveling.
Okay, no problem.
So I will present later on.
Dayanand Vyavare. Dayanand Vyavare. Is there?
Hello. May I audible, sir? Hello.
Daya, please start.
Yes, sir. I will start.
Okay, next is Sridhar. After Dayanand Vyavare, Sridhar will start.
Yes. May I audible, sir?
Yes, screen is visible. Please start.
Yes, sir. Thank you, sir. Good afternoon, everyone. My name is Dayanand Kalyanivare. Today I am going to present my research article on some bounds on line key domination number under the guidance of Dr. Swaz P. Gade, sir. The abstract of my topic is, in this paper, we apply K domination on line graphs. Of graphs, first we take a graph and find their line graph and draw their graph, and we apply K domination on that. At G be any graph and DK be any subset of vertex set of line graph. I is said to be K dominating set of line graph L of G. If every vertex of that vertex set minus DK, that is this dominating set, we can remove from the vertex set. Then every vertex is dominated by at least K vertices. That is the neighborhood of V intersection DK is greater or equal by K. Then the line K domination number gamma KL is minimum kernelity of K domination of G. In this paper, we obtain many bounds on K domination number of line graph in terms of vertices, edges, and other different parameters of G. Further, we develop also its relationship between other domination parameters. So, outlines of my presentation. First, we take introduction, preliminaries, bibliography. So, introduction. This is our basics of our graph theory. That is a algebraic graph. If U of G denotes the vertex set and E of G denotes a set, kernelity of U of G is equal to vertex set. Kernelity of E is equal to Q. These are the basic notations of our graph theory. So these are the basics of our graph theory. Also, vertex edge covering number, and it also I define here. So these are the basic definitions of our notations. So what is line graph? Line graph, and it is denoted as L of G. It is generated from graph G, where vertex set of L of G correspond to edges of G. So in L of G, our vertex set corresponds to edges of graph G, and two vertices are adjacent in L of G if corresponding edges share common vertex or adjacent to in original graph G. Then we say that this is our graph L of G. Suppose here is an example. Here is a graph K23, complete graph with 2 and 3 vertices. So this is bipartite graph, complete bipartite graph. This is our graph, and this is our line graph. So here in this graph, there are 6 edges, means these 6 edges corresponds to 6 vertices of L of G, and 2 edges are adjacent in L of G if they share the 2 vertices share common vertex. So this is our required L of G, line graph L of G. For that purpose, we also use some basic definitions for our work. So what is dominating set? The dominating set is nothing but every vertex phi belongs to vertex set is either element of that dominating set, or it is either adjacent to another element of D. Then we say that this set is dominating set, and minimum quantity of that set is called as dominating set of G. Similarly, we define here definition of total domination number. Total domination number is an set. Every vertex of D has at least one neighbor in that set. Then we say that this set has total dominating set. Similarly, we define independent dominating set. Next, we also define edge dominating set. These are the definitions.
Last 2 minutes, please conclude.
Yes, sir. Preliminaries for that paper, I will take these 2 results for our further results. So these are the results I have found on K domination number. So this is our result for any graph G, gamma K L of G, that is line K domination number is always greater or equal by Q by delta dash of G plus 1. Q denotes the number of edges of our original graph, and delta dash denotes maximum degree of our edge in graph G. So plus 1. For that result, I have taken set theory. So first for that purpose, first we take a set our graph L of G, A be a vertex set of graph L of G. Then there exists a minimal set such that every vertex of this, that is, we can find out for every vertex set, we can find out K dominating set for that, and that is our A1 is a minimal K dominating set, and this is minimal set. So its coordinate is equal to K domination number of line graph of G. As our dominating set is adjacent at least K vertices, so this contributes this single equality, that is the coordinate of phi of L of G minus coordinate of A1 is less equal by summation like this by using this our K dominating set. So using this theory, we can prove this our result, and this is our some expansion or some steps in that result. So similarly, we using preliminary, we prove this corollary and above result. So this is our corollary on the above result, and using preliminary first. Similarly, we can find out second, third.
Whoever's the last 30 seconds.
Yes, sir. This is also our next result. So similarly, we apply K domination on line graphs, and we find out K domination number, line K domination number, and compare this line K domination number in terms of graph edges, and we find out such type of results and corollaries for our K domination number. These are the some upper bounds, lower bounds for our K domination number. So due to time consumption, so in this paper, I conclude myself. In this paper, I have find out some bounds for K domination number of line graph in terms of edges and vertices and other different parameters. Okay, sir. Thank you, sir. These are the references.
Thank you.
Yes, sir.
Okay, Sridhar sir, please start your presentation. Thank you, sir.
Can I stop, sir?
Yeah, please. Sir, it is visible? Yes, it is visible. Okay, sir. Good afternoon, everyone. Myself. Make it full screen. Make it full screen. Sir, now?
Sir, make it full screen.
Okay, sir. Okay.
Okay, go ahead, sir. Go ahead.
So now?
Yeah, it is okay.
Okay, sir. Good afternoon, everyone. Myself, Sridhar Manohar Rao, research scholar from Gulbarga University, Kalburgi. Today, I'm presenting on the topic of my research paper, stratification, numerical and heat transport mechanism in MHD Maxwell fluid flow with a non-uniform heat sourcing. These are the outlines of this paper. Abstract introduction, basic equations of Maxwell fluid, mathematical formulation of the problem, similarity transformation, governing equations, engineering quantities of interest, result and discussion, graphs, conclusion, and references. This is the abstract. This paper focuses on using numerical methods to analyze the effect of stratification with magnetohydrodynamic Maxwell fluid flow with non-uniform heat sourcing. The flow will take place due to stretched surface. It is distinguished from Newtonian fluid using a well-known non-Newtonian Maxwell fluid flow model. The effect of an applied magnetic field across the flow field is also considered as the advantage in this study. The compilation of partial differential equations that arise from the current physical problem are highly nonlinear attributed, and it is not useful to any direct approach. The governing partial differential equations are transferred to nonlinear ordinary differential equations by using similarity transformation, and then solved numerically by using BVP4C with MATLAB solver. The graphical presentation of the results of numerical solutions for velocity, temperature, and concentration parameters for various physical quantities are made. The impact of various non-dimensional governing physical parameters on velocity, temperature, concentration profile is association with friction factors. The local skin friction coefficient, Nusselt number, Sherwood number are also derived and discussed numerically through the graphs. The effect of magnetic
go to your findings.
Sir?
Go to your findings.
Okay, sir. Introduction. Basic equations of Maxwell fluid from 1 to 5. Mathematical model of the problem. Or mathematical formulation of the problem. Equation 6 to 9. Equation number 6, that is equation of continuity. Equation 7, momentum equation. Equation 8, energy equation. And 9 is the concentration equation. These are the 9 and 9. Equation number 9 are the boundary conditions. Equation number 12 is the similarity solution. Equation 13 to 16 are the governing equations in terms of similarity variable. That is in ordinary equation form. Engineering quantities of interest, skin friction coefficient, Nusselt number, and Sherwood number. The result and discussion. The system of non-linear ordinary differential equation from 13 to 15 with boundary condition 16 are solved numerically using BP4C with MATLAB solver. The results are demonstrated to show the influence of non-dimensional governing parameters, de number, Soret number, magnetic field parameter, Maxwell fluid parameter, non-uniform heat source sink, and the graphs. Figure number 2 and 3, magnetic number is increasing and the velocity profile decreasing because the effect of Lorentz force. Then effect of magnetic number on temperature and concentration. Here, the magnetic number increasing and also increases the temperature and concentration profile. Here, Maxwell fluid parameter increases with decreasing the velocity profile. This is the Prandtl number on thermal profile. Prandtl number increases and velocity profile is decreasing. The stratification here, stratification number increases and
increases the velocity profile because this suggests that the higher values of S1 leads to more pronounced stratification where that is a greater contrast between different layer in this system. The stratification numbers effect on Nusselt number. This is the concentration stratification number on Sherwood number. The conclusion in this study, fluid flow find heat transfer in non-Newtonian viscoelastic fluid magnetic hydrodynamic study. Laminar flow of stretching sheet has been studied. The governing partial differential equations are transferred to non-linear ordinary differential equations by using BP4C with MATLAB solver. The effect of heat and mass transfer, including Soret and Duffer effect, heat absorption generation are results obtained in this study. Based on the numerical study presented, following conclusions are drawn. The effect of magnetic field on the velocity, temperature distribution and concentration is dominant and produces positive impact on the flow. The effect of non-Newtonian Maxwell parameter decreases the velocity and increases the temperature and
Time is
concentration
over.
profile. Okay, sir.
Okay, thank you. Please stop presenting. Okay, next is okay. Anil Chinde is there. Anil Chinde. Ashok Bingi, sir. Naneshwar Survase. Naneshwar Survase. Nawazuddin Patel. Nawazuddin Patel.
Sir, Nawazuddin.
Yeah, please start your presentation.
Okay, sir. 1 minute.
Start presenting.
Yes, sir. Yes.
I think you are muted, sir. So it is saying stop sharing the screen again and again join. Start sharing.
Okay, 1 minute.
Yeah, now again start your sharing your screen.
Okay, sir.
Yes, it is visible. Please start. Nawazuddin Patel sir, you are muted. You are not audible. Try to unmute yourself and then start sharing your screen.
Okay, 1 minute, sir.
Yes, please start your share. You are unmuted. Start sharing your screen.
Sir, can you share your screen? I will send your email, sir. That is, I will explain here, sir. You're going to have problems.
Is there any problem?
Yes, sir. Therefore, you can share. I will explain, sir. Just you share your on about your system.
Okay.
I mail, sir. I mail PPT.
There is a echo on your side. That's why I'm not able to listen to you properly. Now you are muted. So you just start sharing your screen if possible. Otherwise, we'll go for the next and just figure it out, and then we'll come to you.
Okay, sir. I will start.
Okay. So is your mobile is also on? Are you joining by two devices? Oh. Patel sir? Patel sir? Patel sir?
Sir.
Yeah.
My voice is coming, sir. Are you
Yeah,
audible?
it is coming now.
Okay, sir. Sharing screen.
Is it a thing that you are joining with two devices? I mean, with your phone as well as with your laptop. In that case, there will be echo and we cannot listen to you properly. Now we can see your screen, but not your audio. We can't listen you.
But when I am sharing a screen, sir, that I am muted, sir, automatically. Why?
We'll go to the next presenter then. So till then, you just figure it out. What is the problem on your side?
Now you can let us hear, sir. I'm sharing.
Now I can listen to you, but while sharing a screen, you become muted. So we can't listen to you.
Now, sir.
Now there is no screen. Means we could just see your name, but there is no screen at all. Okay, you just try to figure it out. I will go to the next participant till then. Rakesh Kumar sir. Rakesh Kumar sir.
Yes, sir. Yes.
Please start your presentation.
Now, sir? Now sharing, now, sir?
Okay, it is now visible.
Now it's now visible. Audible,
Yeah.
sir?
Yeah, please start. Please start. It is visible.
Okay, okay. Okay, okay. Thank you, sir. Thank you. Thank you.
You just double click to enter to full screen mode.
Right, right, sir. So let us hear, sir. So, thank you to sir. Strong, like I present our paper, strong split line block dominations graph. That is a definition of strong line domination graph. That is a dominating set D graph LFG is a strong split line domination. If every vertex V of L minus D is totally discriminated with at least two vertices in D, strong line domination number SS gamma of SS of L of G is the minimum cardinality of strong split line dominating set of G. This is abstract of stronger split line domination set. This is a know that here totally this definition they same like a dominating set D L of G is the strong line dominating set. If every vertex V of L of G minus D is a totally discrete with at least two vertices in D, then it is called the strong split line domination number. That is a SS gamma of SSL of G of G. The minimum quality of strong split line dominating set of G. This is paper is know that it is a relation with other domination parameter we are find, sir. So now it is a keywords of the strong split line dominating numbers. This know that it is a total so many keywords is there, and this is the introduction part of this strong split line domination in graph. The next the know that it is a totally observe here. If any p of determines P of n means the path of n is greater than vertices gamma of SSL of L P of n is greater than or equal to the quality of n of divided by 2 we can take. The other one is the observation of any non-separable graph G SSL of G is equal to 1. The main results of the for any PQ of graph G is with n is block, then the gamma SSL of G is greater than or equal to n. Then you have to take the proof of this is the statement proof. You can take the number of blocks, even you have to take the dominate this block, then you will get the L of G, the line graph. Then you have to do the strong split line domination number. We have to take the 5 numbers. When 5 is greater than or equal to 3, we have to take. Another example also same, you have to follow these functions. So same this statement you have to prove that in the two cases, case 1 and case 2. This is the proof of line domination, strong split line domination of graph G. Next, another one is the theorem is there for any tree T is a gamma SSL of G T is greater than or equal to you have to gamma edge dominations. You have to take the tree. The proof of the gamma of G is know that it is a G is there. Then L of G is know that it is L of G. You can take the 1, 2, 3, 4. You have two dominations. Then the 4 of is greater than or equal to 1. You have to prove here. Another one example also say you can take here taking the gamma of L of G is equal to 3 is greater than or equal to 2. Same like in this proof, you have to follow these conditions. This is a letter E of E1, E2, E3 edges we adjacent to end of edges, and then we can take. Then similarly result to establish this one. These are similarly established the following results is there for any graph where you edges minimum vertex independent number of G. For any P of Q graph G is the gamma SSL of G is the diameter of G. For any PQ graph of G is the gamma SSL of G of gamma of G edge of G is minus equivalent holds for the P. The for a non-trivial tree which with the P is greater than or equal to 4 vertices, then the gamma SSL of T of less than or equal to n of S of T. Then for any connected graph, you can take the any connected graph, you can give the parameter is the PQ of graph G of gamma SSL of G, means the strong split line domination numbers of less than or equal to P minus P means vertex is a total domination number of G. Therefore, any connected PQ graph G with the P is greater than or equal to 3, then the gamma SSL of G is less than or equal to Roman domination minus Roman domination of graph G is minus 1. Same, you know that is the reference is there. The so many reference you can take here. You have to prove the some different parameter. You can prove the strong split line domination numbers. Thank you, sir. This is my small PPT presentation is there. Are you audible, sir? Are you audible, sir? Hello. Hello. Hello, sir. Hello. Are you audible, sir? Gade, sir. Sir, are you audible? My voice?
Yes, sir, you are audible, but screen is not visible.
Screen not visible, sir.
Yes, not visible, sir.
Now,
No, sir, your name is only there, Dr. Nawazuddin.
sir. I explain once again, sir.
I think, sir, I'm also a participant. I don't know why coordinator is not replying from last 5 minutes. You are audible. There is not problem from your side. I think you're done also, but yeah. Okay.
Yeah, sir. Now
Okay.
visible.
The screen is not visible. It is just I'm getting your name presenting and double click to enter the full screen mode. That is the comment is coming there.
Now, sir, now visible my screen.
No.
Hello.
Hello, sir.
There is a message on the WhatsApp group that due to power cutoff, there is a problem on their side. So that online session is disconnected from their side at the host
Okay, okay,
position.
okay. Okay, thank you, Ashit sir.
Just look into the WhatsApp group, please.
Okay, okay, we've not seen that, I think. Okay, sir. Then, okay, we should wait then.
Sir, that my screen will be sharing, sir. It is visible or not, sir? I think it is not visible.
It's not visible, sir.
Yeah, yeah, yeah. Nice.
अनम्यूट कर देगा हाँ ठीक है हेलो हेलो कैमरा ऑन वीडियो ऑफ कर दो हेलो एम आई ऑडिबल
Yes, yes.
Yes, sir.
Yes, sir. Yes, sir.
So there was a power cut due to which we disconnected. So we'll start again.
Who sir? Nawazuddin, can I once again can explain, sir?
Yeah, you just conclude with your main findings.
Okay, sir. I
Please.
concluded, but it is, I don't know if it's going or not. Once again, I will share it.
Yeah, please.
Is it visible, sir, now? By sharing?
It is visible now. So
Okay,
just
sir.
go to your main results and conclude.
Okay, sir. Okay, right. The main result, this is know that theorem 1. For any PQ graph G with n blocks, then the gamma SSLC of G is greater than or equal to n. The proof will know that the take the number of G's n is equal to 3, and you have to make the line graph G know that G1, V2, V3, V4. Then you can strong split line domination graph of G is equal to 5. Then you know that n is greater than or equal to 3. You know that same like you have to follow the graph G is equal to. Hello. Yes, sir.
Yeah, please. Please conclude with your last findings.
Okay, sir. Okay, right. This is the
I think
proof.
your screen is not visible, but please conclude.
Okay, sir. Okay, right. This is know that is the references of this books. Next, you know that it is a similar result. Okay, this, okay, sir. Thank you, sir. Thank you. Okay, sir. Any doubts or any questions for you? Okay, sir. Thank you, sir. Thank you. Completed, sir. Yes, sir.
Hello, good afternoon, sir.
Okay, sir. Thank you, sir. Completed. Any questions? Sir, are you audible?
Yes, yes, sir, you are audible, but from what side, no response, I think.
Okay, sir. Okay, yes, sir. Is it concluded, sir? I am concluded. Next, you can carry on, sir. Go ahead, sir.
Am I audible?
Yes, sir. I audible, sir.
Yes, sir.
Okay.
Yes,
So
sir.
we'll start. Murke sir.
Yes, sir. Yes, sir.
Please start.
Yes, yes, yes.
Sir, I
Let
drop.
me share. Let me share my screen. Is my screen visible?
Yes.
Okay. Good afternoon, everyone. I am Nitin Sadashiv Gudke. The title of my paper is Hybrid Nanoparticles and Their Role in Modulating Blood Flow Through Stenotic Arteries. The abstract is the simulation of blood flow in stenos-driven arteries is conducted in the presence of hybrid nanoparticles, AU and Al2O3 and blood. The blood flow equations are discretized using finite difference method and they are simulated with the help of MATLAB. The effect of AU nanoparticles and hybrid nanoparticles on velocity, flow rate and resistive impedance to blood flow are analyzed and compared. The results indicate that the hybrid nanoparticles have greater impact on these parameters. Atherosclerosis is the most common disease that affects cardiovascular vessels. The disease is developed due to deposition of fatty material inside the artery, which leads to blood flow disorders. The reduction in the space lumen of the artery due to deposition of fatty material is called stenosis. The impact of these gold nanoparticles and hybrid nanoparticles on flow parameters, it is observed in this study. This is the geometrical or geometry of the stenosis. This is the graphical structure of the stenosis. D is the length where stenosis starts. 2L0 is the actual length of the stenosis. L is the length of the artery which is considered. Z is axial direction. R is the radial direction. These are the governing equations. These are some boundary conditions. This is radial variation of the axial velocity. You can see when we, in the presence of gold nanoparticles, there is increase in the velocity. Now, if you have hybrid nanoparticles, means when you have gold and Al2O3 nanoparticles together, we have it has more impact on the velocity. We can see the rise in the velocity in the presence of AU nanoparticles and the hybrid nanoparticles. This is the axial variation of the axial velocity. Here also we can see in the presence of gold nanoparticles, it is the velocity is more, and then in the presence of hybrid nanoparticles, it is more than in both cases in the presence of pure blood and in the presence of gold nanoparticles. This is flow rate. Here also you can see the rise in the flow rate in the presence of those nanoparticles. This is the resistive impedance. We can see the impedance or the resistance is less in case of nanoparticles. This dotted green line is for pure blood. Then the center one is for it is in the presence of gold nanoparticles, and this is the impedance which is less in case of hybrid nanoparticles. So the presence of nanoparticles, they increase that presence increase velocity, flow rate, and it decreases resistance to flow in the stenosis region. These hybrid nanoparticles, they show better results, and this nanoparticle drug delivery can be used to treat cardiovascular diseases. These are some references. Thank you. If you have any questions, you can ask.
Thank you, sir.
Okay.
Next is Sri Rakesh Kumar, sir. Yes, you are audible, sir. Start sharing your screen.
Yes, sir. My screen is visible.
Yes, sir.
Good afternoon, everyone. I am Rakesh Kumar from Department of Mathematics, University of Rajasthan, Jaipur. I am presenting in the topic C consistency in a sine associate ring graph. My abstract is a sine graph is a graph whose edges are labeled with positive or negative sign in this paper. The preliminary concern is to have a natural extension of the notion of associate ring graph AZR in the realm of sine graph. Viewed in this way, the signed associate ring graph AZ summation R turns out to be balanced and consistent when R is a field. Further, we characterized the commutative ring R for which AZ summation R is balanced and consistent. Several new directions for further research are also indicated. Overall terminology and notions for the theory of sine graph not especially given here. We refer the reader to the survey article by Jaslaki and for terminology and a notion in the theory of graph and algebra. We refer the reader to standard textbook by Harari and Jacobson respectively. My if R be a ring with unity, then the associate ring graph denoted by AZR based on the element of R minus 0 and two distinct vertices X and Y are adjacent if and only if they are associated to each other. An example of associate ring graph in below, it is proved in for this example is AZ5. As Z5 has elements 0, 1, 2, 3, 4, and the graph associate ring graph created by non-zero elements of Z5. That means 1, 2, 3, 4. 1, 2, 3, and 4. It follows that the graph is this graph is undirected graph, and furthermore, each component of the graph is complete. The following interesting theorem 3.3 provides some insights into the structure of associated ring graph and is useful in this paper. Now we go on for the theorem. Theorem 3.1. We are given a commutative ring R. Then AZ summation R is C consistent if R is a field. When R field, then AZ summation R is C consistent. When R is a field, then by the definition of field, each non-zero element of field are possesses multiplicative inverse. That means each element of R is invertible, each non-zero element. So AZ are isomorphic to K, norm of R minus cardinality of R minus 1, where here K represent the complete graph, and norm of R minus 1 is represent the number of vertices of this complete graph. Because the ring R, which is filled, has cardinality R, then associate ring graph created by non-zero element, then one element we discard one element, that zero element. Therefore, the cardinality of AZR will be mod of R minus 1. And in view of definition 2.1, each edge received positive sign. Therefore, AZ summation R is n all positive. So under canonical marking, each vertex receive positive sign. Therefore, AG summation R is C consistent. C consistent mean in a graph.
Rakesh sir, please conclude. Last 1 minute.
Yes, sir. Yes, sir. A summation Z is C consistent. Let Z plus into be a ring of integers. Then there are only two units, namely 1 and minus 1. So each 1 and minus 1, they are multiplicative inverse. So each element A belongs to Z have exactly two associates. 1 and -1 are associated to each other. If A is an element, then -A is A and -A both are associated to each other. Then we put A is 2, then minus is minus, then second element associated with 2 is -2, and so on. Therefore, AZ are isomorphic to K2 union, and so on, finite copies of K2, because every complete graph has two elements, only two elements. For example, 1, -1, 2 and -2, 3 and -3, and so on. In light of definition 2.1, AZ summation R isomorphic to K2 positive. K2 positive is a complete graph with two elements having 1 and -1 units, and K2 negative infinite copies of complete graphs has every graph has two element which are 2, -2, 3, -3, 4, -3, and so on. Due to absence of cycle, each K2 has no cycle, and there are no cycle, then graph is balanced and C consistent. Therefore, all K2 all K2 are C consistent, then total graph is also C consistent, and therefore AZ summation Z is C consistent. AZ summation Zn is C consistent if and only if either n is prime or n belongs to 4, 6, 8, 9, and
Rakesh sir, please
yes, sir.
conclude.
Yes, sir.
Time is over. Please.
My conclusion is in the course of investigation, we found that AG summation R is C consistent. In case of Boolean ring, when R is a Boolean ring, then C consistent, and R is filled, then also the AG summation R is C consistent. And in this way, several new directions are also indicated in this way. And these are my references. And thank you.
Thank you, sir. Thank you.
Okay, sir.
Bingi sir, please start.
Yes, sir. Am I audible to all of you? Am I
Yes,
audible?
sir. Yes, sir.
Okay. I'll share my screen.
Rakesh sir, stop sharing your screen.
Yeah.
Is my screen visible to all of you?
Yes, sir.
Okay, good afternoon to one and all. The title is Results on OA prime elements in multiplicative lattices. So in this paper, we revisit the concept of OA prime elements in compactly generated multiplicative lattices. I give the characterizations and properties and relate to two absorbing primary elements. Let me tell you some basic terminologies. The definition of multiplicative lattice is given here. These four properties: first one commutative, second one associative, third one joint distributive, and one acts as multiplicative identity. So this is the definition of a multiplicative lattice. Now, as in real analysis, you have compact set. When you say a set is compact, every open cover has finite subcover. In the same way here, A is less than or equal to join of X. Then there are finite elements A1, A2, AN such that A is less than or equal to A1 join, A2 join, dot, dot, join, AN. Here join means supremum and meet means infimum. We denote L star as the set of all compact elements, and we consider compactly generated lattice if L is a join of compact elements. This is the definition A restitution B. And root A is join of X belong to L star such that X raised to N is less than or equal to A. Am I audible?
Yes, sir.
So these are the basic definitions. Now let us run to the OA prime. Before that, when you say an element is prime, see AB less than or equal to Q implies A less than Q or B less than Q. On right hand side, if you see, among AB, one is less than or equal to Q. One of the element is, so this is referred as 1, 1 absorbing prime. Okay. Now moving ahead, one absorbing prime. here 3 elements are there. ABC less than or equal to Q. See the last line implication. AB less than or equal to Q or C less than or equal to Q. So this is referred as looking into the right hand side, 2-1 absorbing. If I compare from the first definition, you might understand why it is called 2-1 absorbing. Okay. Now it might happen that among ABC less than or equal to Q, product of 2 on right hand side, AB or BC or CA. So this is called as 2 absorbing. So TA stands for 2 absorbing and OA stands for 1 absorbing. So the relation between these elements is given here. Now, when you say primary, in the previous definitions, if I include root Q, then it is said to be primary. In the same way, 1 absorbing primary or OA primary means root Q comes at the rightmost end. If I compare with the previous slide, 2 absorbing primary means, see at the right hand side, you have CA less than or equal to root Q. So whenever root Q comes, we say it is primary, OA primary, TA primary, or the first one primary and so on. The relation between them is given here. Now, when you say Q is called P prime, see the Q must be prime and root Q equal to P is prime. In the same way, the concept of P primary and P2 absorbing primary. Now, knowing these concepts, let us move to the results. This is the characterization of OA prime elements. All are equivalent. And in the last 4th point, you notice that it's the same OA prime definition, but here elements are from L star. L star is the set of all compact elements. Now, when you say it is semi-primary, if root Q is prime, it is called semi-primary. Now, what is the relation between semi-primary with OA prime is given in this property. Here is a corollary as an outcome of the above property. And this is the definition of POA prime. When Q is semi-primary, then that OA prime is called POA prime element. Now here is the next characterization. And the purpose of this paper is to go for more results with respect to characterization and properties and meet properties. This is the next characterization. As an outcome of OA prime is given here, Q double dot X is prime. Now in the next result, we tried whether the converse of this property 2 holds. We found some conditions so that the converse of property 2 holds. As a corollary to property 2, here is the statement that we get in the last line. Now here are the properties of meet of OA prime elements. If Q1, Q2, Qn are POA prime, then their meet is P2 absorbing primary. If Q1 is P1 over OA prime, Q2 is P2 OA prime, then their meet Q1 meet Q2 is 2 absorbing primary. If Q1 and Q2 are 2 OA prime elements, then their meet is 2 absorbing element. And if Qi is an ascending chain of prime elements or OA prime elements, then their meet is OA prime element. So we got 4 properties with respect to the meet of OA prime elements. Now, as a future scope of this concept, we have this definition to take this concept ahead. Weakly OA primary. In the previous original definition, there was only ABC less than or equal to A. Here, along 0 not equal to ABC less than or equal to Q. So this is referred as weakly OA primary. Now, why only 3 elements? We can go for 4 elements, A, B, C, D. We can go for n number of elements. So this is the definition. See the last line, x1 dot 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 xn plus 1 less than or equal to Q implies the product of first n less than or equal to Q or xn plus 1 less than or equal to Q. So this is said to be NOA primary. So there is a lot of future scope for this concept. These are the references. Thank you.
Thank you, sir.
Okay.
Okay, next is Zabin madam. Are you there?
Yes, sir.
Yeah, please share your screen.
Let me stop sharing.
My screen is visible, sir.
Yes, madam.
Good afternoon, everyone. Myself, Parisha Jabi. My topic of my paper is effect of rotation on thermal convection in a Jaffrey fluid saturated porous. In this paper, the linear stability analysis of onset of thermal convection for a fluid in an isotropic porous medium is done using modified Jeffrey-Darcy model. A horizontal layer of a fluid at a constant and different temperature is taken. And Jeffrey-Darcy problem is modeled by a system of highly nonlinear partial differential equations. The Rayleigh numbers for stationary and oscillatory convections are derived using perturbation method. The effect of Jeffrey parameter and anisotropic parameter on thermal convective motion is examined. It is observed that anisotropic in thermal diffusivity act to delay the onset of thermal convection, whereas the Jeffrey parameter and the anisotropic in the permeability shown the reverse effect. The size of the convection cell enhance both thermal and mechanical anisotropic parameter. It is also noted that the effect of Jeffrey parameter is immaterial on the size of convection cell. Mathematical formulation. Here we have taken two layers. Consider incompressible Jeffrey fluid saturated anisotropic porous layer between two infinite parallel plates. These are two plates. Here, with a distance d, thermal buoyancy is invented to be the cause of fluid motion in the anisotropic porous layer. The lower plate heated at the temperature T0 per Kelvin, and here upper plate is at the temperature T0. These are the governing equations. To examine the effect of leading parameter, gamma, zeta, and eta on start of Jeffrey fluid convection, the expression for the thermal number RAT evaluated numerically. These are showing the figure 2 to 6 in convection. It is well known that the diameter of convection cell is inversely proportional to wave number AC. Therefore, increase in the value of wave number AC cause the decrease in the size of convection cell, vice versa. Increase in the value of wave number, decrease in the convection cell. This is shown here. Effect of Jeffrey parameter lambda on space RAT A. Here, this is the graph showing effect of thermal anisotropy parameter eta on space. Here, this is the unstable mode of the graph. Here, stable. We are drawing graph between wave number and Rayleigh number. Here, in this graph, we are showing effect of mechanical anisotropy parameter zeta on the space. Here, we are drawing graph between RAT and A. Next, in the fifth graph, we are showing effect of thermal anisotropy parameter eta on space. This graph shows the effect of mechanical anisotropy parameter zeta on space. Conclusion of my paper is these are using in the nowadays in polymer industries. In the influence of mechanical and thermal anisotropy on the linear stability of initially horizontal porous layers saturated with Jeffrey fluid is explored analytically. The result demonstrate that the thermal anisotropy parameter, the mechanical anisotropy parameter zeta, Jeffrey parameter lambda display the some novel result on the stability characteristic of the system. The thermal anisotropic parameter eta act the postpone of the start of Jeffrey fluid convection, while the Jeffrey parameter lambda and the mechanical anisotropic parameter zeta show the opposite effect. The size of the convection cell enhance the both thermal and mechanical anisotropy parameter. It is also noted that the effect of Jeffrey parameter lambda is immaterial on the size of the convection cell. These are the references. Thank you.
Thank you, madam.
Thank you, sir.
Okay, next. Koli, sir.
Yes, sir. Good afternoon. I am audible, sir?
Yes.
Okay. My screen is visible, sir?
Yes.
Okay. Can I start, sir?
Make it full screen.
1 minute.
Please start, sir. No worries.
Yes, sir. Is it visible? Hello?
Yes, sir.
Can I start, sir?
Yeah, now it is visible. Please start.
Yes. I am Mr. Koli. My paper my topic is advancements in soft graph theory, a novel approach to uncertainty modeling. I have done my research under the guidance of Dr. Mrs. Jyoti Mashalina. So, subset theory and its applications. Subset theory was actually introduced by Professor D. Molstow in 1999, which is a generalization of fuzzy set theory. So, depending on the subset theory, we have introduced a concept of subgraph. Before going to subgraph, just I will define the subset. A subset is nothing but an ordered pair FA. Describes the properties of some cars as if U is the set of cars under consideration and U be any set with having elements as C1, C2, C3, C4, C5, and C6, and E is a set of parameters such that it includes some parts of that corresponding cars, that is body type, acceleration time, cargo volume, fuel capacity, fuel consumption, model date, number of airbags, and A be any subset of that E, and having elements are denoted by E1, E2, E3, and E4, where E1 is nothing but a body type, E2 stands for cargo volume, E3 stands for parameter model rate date, and E4 stands for the parameter number of airbags. So the image of E1 is nothing but C2, C3, and C4. That one is nothing but C2, C3, and C4 are the elements belonging to the original set U. Then similarly, we can define E1, E2, E3, and E4. That is the F images of that corresponding elements. Then an ordered pair FA is nothing but F of E1, F of E2, F of E3, and F of E4. And that corresponding ordered pair FA is nothing but the subset. Similarly, we can define the subset. It is just like our original subset theory. Whenever A is said to be an subset of B, whenever every element of A is again an element of B. So subset can be defined as whenever FA and GB are any two soft sets over the same universe U, then FA is a soft subset of GB if A is a subset of B, and for any element in A, FA and G have the identical approximation, and we say that ordered pair FA is a subset of ordered pair GB. Depending on these concepts, we have defined one new concept. That one is nothing but the soft graph. Actually, this one is introduced by our guide. That one is nothing but whenever G is a simple connected graph and A be any non-empty subset of V, and R is an arbitrary relation between elements of A and elements of V. That is, R is an relation which is defined on the Cartesian product of A and V. Then F is a function from A to power set of V, and it is defined in such a way that F of X is nothing but it contains all the elements from V which are related to F, and that corresponding FA becomes the soft set over the vertex set V. Then FA is a soft graph of G if for any element X, F of X becomes a connected subgraph of G. One example, whenever G is a graph with vertex set V and edge set E, having vertices are V1, V2, V3, V4, and V5. Let us we take C be any subset of V, having elements are V1, V3, and V4. Now we define a function capital F in such a way that it contains all the elements from V for which d of distance from X to Z is less equal by 1. That is, there is an edge joining between the corresponding elements in where f of v1. Now from this one, whenever distance from x to z is less equal by 1, then f of v1 becomes all those vertices which are connected to v1 by a single edge. That one are nothing but v1, v2 and v5. Similarly, f of v3 is nothing but v2, v3, v4 and v5, and f of v4 becomes v2, v3, v4 and v5. F of v1 contains the vertices v1, v2, v5. Then the edges corresponding to that elements are all those edges which are incident on v1, v2 and v5. Similarly, we can do for the v3 and v4 also.
Sir, please conclude.
Yes. So from this subgraph, some conclusions are there. That one is nothing but we can define the concepts of graph theory such as the radius, diameter, eccentricity. All those concepts we can easily apply on the corresponding subgraphs also. Similarly, we can find out the Hamiltonian and Eulerian graphs, Eulerian subgraphs. So thank you, sir.
Thank you, sir. Patil Sonabai, ma'am.
Yes, sir. Yes.
Please start screening.
I'm audible, sir?
Yes, it is visible. Make it full screen.
Sir. Myself, Patil Sonabai Dashat. I'm working as assistant professor in Sambhajirao College of Mathematics. My title of my presentation is on solution of one-dimensional heat equation using Crank-Nicolson method. These are some outline of my presentation: introduction, problem formulation, conclusion, references. Introduction: the heat equation is a parabolic partial differential equation that represents the temperature variation in area over time. The heat equation is used to solve problems arising in the field of engineering, fluid mechanics, atmosphere, solar physics. There are many numerical methods to solve these equations, such as the finite difference method, Crank-Nicolson method. The Crank-Nicolson method is the most commonly used method for solving parabolic partial differential equation. The Crank-Nicolson method for solving heat equation was developed by John Crank and Philip Nicholson in the mid-20th century. In this paper, we have developed the Crank-Nicolson method to solve one-dimensional heat equation. This is the problem formulation. First, we have considered the heat equation in one dimension. Equation 2.1 is the one-dimensional heat equation. Recall the partial derivative. Equation 2.2 is known as the forward difference approximation. Equation 2.3 is known as the central difference approximation. Then equation 2.2 and 2.3 combining, then we have heat equation. Also, then now putting n plus 1 by 2 and n respectively for dou theta by dou 2 theta dx square. Here taking r is equal to delta t into del x square. Then equation 2.4 we get. Again putting n plus 1 and n plus 1 by 2 respectively for dou theta by dou t and dou 2 theta by dou x square. Then we get equation 2.5. From equation 2.4 and 2.5, we get equation 2.6. Here we have to solve the equation 2.6, we get a equation 2.7. This equation is called the Crank-Nicolson method, which is accurate in both time and space. This equation can be written in the matrix form as, this is A matrix and this is the B matrix. These are some conclusion. In this paper, we have applied the Crank-Nicolson method to solve one-dimensional heat equation. From the study, the proposed method was found to be generally more accurate and also the approximate solution. It may be concluded that the Crank-Nicolson method is powerful and more efficient in finding the numerical solution of heat equation. These are some references. Thank you, sir.
Thank you, madam. Jirge, madam. Jirge, madam. Priyanka Jirge, are you there? Okay, we'll go to the next. Sachin Vyavare, sir. Sachin Vyavare, sir. Trivedi.
Yes, sir.
Yeah, please start sharing your screen.
Visible, sir.
Yes, madam.
Am I audible?
Yeah.
This is Sumita, lecturer mathematics, KR Medical College, National College of Cluster University, Kadi. My topic is introduction to idempotent ternary semiconductor. General introduction. The beginning of the ternary algebra was started before 1932, Lemma in 1932, deliberated definite ternary system known as triplexes, which rolled out to be simplification of ternary circuits. In the algebraic theory, completely regular semiconductors were first studied systematically by Gifford. So, here the preliminaries definition. A non-empty set T is said to be a ternary semiconductor if there exists an internal operation dot from T cross T to T written as A B C implies A dot B dot C satisfies the following identity. AP of CDE is equal to A of BCDE, that is equal to ABC of D. For any ABCDE belongs to T. Example, let T be a set of all non-positive integers without zero, then T is a ternary semigroup where ABC denotes the usual multiplication of integers ABC with ABC belongs to T. An element A of ternary semigroup T is said to be an idempotent if A cube is equal to A. Now that the set of all idempotent elements in the ternary semigroup is denoted by E of T. An element A of ternary semigroup T is said to be a proper idempotent element if A is an idempotent, which is not an identity of T if an identity element exists in T. A ternary semigroup T is said to be an idempotent ternary semigroup or a ternary band if every element of T is an idempotent. An element A is ternary semigroup T is said to be regular if there exists X comma Y belongs to T such that AX AY is equal to A. A ternary semigroup T is said to be a regular ternary semigroup if every element of T is regular. Result, every idempotent element of a ternary semigroup is regular. An element A of ternary semigroup T is said to be left zero or lateral zero, a right zero of T if ABC is equal to A for left zero, BAC is equal to A for lateral, and BCA is equal to A for right zero for all BC belongs to T. A ternary semigroup T is said to be a left zero, lateral zero, or right zero. Ternary semigroup if every element of T is left zero, lateral zero, or right zero element. An element A of ternary semigroup T is said to be a zero if ABC is equal to BAC, that is equal to BCA, that is equal to A, for all BC belongs to T. That is, if it is left zero, lateral zero, and right zero, then it is said to be a zero. A ternary semigroup T is said to be zero ternary semigroup if every element of zero and some results are ternary semigroup, idempotent ternary semigroups. Theorem. The lateral zero ternary semigroup T is regular if and only if T is an idempotent ternary semigroup. Proof. Let T be a lateral zero ternary semigroup, then every element A belongs to T is lateral zero, that is, there exists B comma C belongs to T, such that BAC is equal to A. Suppose T is a regular ternary semigroup, then for any A belongs to T, there exists X comma Y belongs to T, such that AX, AY, A is equal to A. To prove that T is an idempotent ternary semigroup, consider A is equal to AX, AY, that is equal to A, since A is a lateral zero, X, AY is equal to A, that is equal to AQ. For every A belongs to T, AQ is equal to A. That implies A is an idempotent element in T. Therefore, T is an idempotent ternary semigroup. Conversely, assume that T is an idempotent ternary semigroup, then AQ is equal to A for all A belongs to T. To prove that T is a regular ternary semigroup, consider A is equal to A cube, that is equal to A into A square, since it is an idempotent element for A. Here we are writing A cube, that is equal to A cube into A square, that is equal to 5 A, A. It is equal to A. Since A is equal to A cube, because it is an idempotent element, A cube, A cube, A. That implies A is regular. Therefore, T is regular ternary semigroup. Second thing, a regular ternary semigroup T is lateral zero semigroup if and only if T is an idempotent ternary semigroup. Let T be a regular ternary semigroup. Suppose T is a lateral zero ternary semigroup, then for any A belongs to T, there exists to become A belongs to T is such that P is equal to A. To prove that T is an idempotent ternary semigroup, since T is irregular, we have for every A belongs to T, there exists A comma X comma Y belongs to T, such that A is equal to AX AYA, that is equal to AAA, since
Madam,
A is
conclude within
lateral
1 minute.
zero. Okay. So the plus A cube is equal to A, hence T is an idempotent ternary semigroup. So again here, I prove that T is lateral zero ternary semigroup. References. Thank you.
Thank you, madam. Vishwas, VRM, sir.
Hello, sir. Am I audible?
Yes, sir. Please start presenting the screen.
Okay.
Yes, sir.
Okay,
Screen is
exploring.
visible.
Visible, sir. Yes, sir. Exploring graph coloring in graph theory through maximum software implementation. So in this one, as you can see, we are going for the two concepts here. One is of the graph theory. Second, we are going through the maximum software implementation. So there should come to the abstract here. Now, this is abstract and a simple advantage to try to tell us how the graph theory is essential for scheduling, network, and optimization. Now, it is the age of AI and other tools. So we can use Maxima. Apart from that, it is very simple and you can go for offline mode here. So Maxima, what itself tells means it is a computer algebra system used for symbolic computation, algebraic manipulation, calculus, matrix operation, and more. So how do we implement this with graph theory mix? By using its symbolic computation, matrix operations, and algorithm manipulation, we can go for graph theory, and it can be very helpful for the upcoming researchers and the employees. That is what the abstract is, and so. Next, coming to the introduction part, it is just for the introduction of the coloring graph theory. So how the coloring graph theory came into existence in 1862, 1976. Key developments going for the quadratic number, meeting the algorithm, and Brooks theorem. Actually, in this one, the pedagogy and the introduction both are related to same only. Now, recent trends, what we are following is AI-based methods improving efficiency, used in quantum computing, and advanced optimization problem. Now, here, we'll just take one simple example. Application of graph coloring. So, in the exam timetable scheduling, the class timetable scheduling, we are moving the exact graph coloring rotates estimates no to adjustment vortices which have the same color. So by using this one, we can save our time in a less way and we can do a faster way our work. So regarding on this model, I have created a program and the result is also there. I will show it the last one. And next, this is of the Solapur. So by using the graph theory coloring technique and with the programming one, easily we can solve this puzzle. And in this one, I went for some special kind of graphs, say regular complementary graphs and sunlight graph. So regular complementary graph, it is nothing but consisting of two graphs G and G bar. Use the complementary graph G is obtained when they are not adjacent G, and both graphs are regular as they contain the same adjacent matrix. Even we get the same chromatic number for two graphs. A sunlight graph means it is a new kind of a graph. N sunlight graph is on 2n vertices acquired by connecting pendant edges to a cycle graph. In this one, we'll discuss for two cases. One is for dual cycle and for odd cycle. Now, I'll go for the next one. In traffic light, we also implement this. Now, usually the question arises when you see the traffic light mode, usually how it changes the color. Actually, it is a very basic one I have taken. As you can see, the red, yellow, blue. Now, basically, what does they do? They implement the graph theory technique here. Means, how does the graph coloring tells to us? No two adjacent vertices must have the same color, implement the same technique here. Actually, I'm saying the very basic version, but in the advanced version of Python, when we go for this one, we can create a more advanced way of representing this one. And actually, the maxima is much advanced it cannot be done. So it is just a basic way of showing how graph coloring can be implemented in traffic light. Next, moving to my main results and discussion. Here are some programs are here, and I just request all to follow this one. As you can see here, nodes, graphs, G draw graph, NC draw graph. So this I just mentioned here due to because it is using the older version. So some programs are lengthy, it cannot come up here. So as you can see here, you are seeing for this first graph and next second graph. One is for the even cycle and another odd cycle. So in the even cycle, as you can see, only two colors are required, as in the odd cycle required three colors. Next, moving towards, we are having for complete graph, wheel graph. This is for bipartite graph. And next one, as I told you, standard graph operations, we are going for regular complementary graph. So this is the program for codes for it. When you can see here, I have taken the special graph here that is taken C5. As you can see C5 here, and I'm just taking the complement of this one. I'm getting the same chromatic number as well as the adjacency to show it is a regular complementary graph. Moving towards, this is the butterfly graph actually, which you're seeing the first one. The second which you're seeing is the sunlight graph. I think regarding sunlight graph in the previous only I told you, this you're seeing, this is sunlight graph for actually you're taking for odd cycle. This is the first one you're seeing, this is a triangle. It is of the but you're taking normal graph you're taking. Next, we are going for the sunlight graph of this one. And you can see we're getting the chromatic number 3 here. Next one, it is for the even cycle. And next, it is actually a theorem on related to the graph theory. That delta of G with the maximum of the degrees of the vertex of G. Then chromatic number is less than equal to 1 plus delta of G. Now, using the programmatic code here, I have just shown this one. As you can see here, I just taken the code graphs, G complete graph, vertex coloring, and I have shown that exactly according to the theorem. Not only this graph, and furthermore, if anybody wanted this, they can try for another graphs also. For particularly, if they want to check the result or obtain what happens we completely go for theoretical method. In some case, we get stuck. So better way we can use the programming code, so it is easy for us to get the findings. And this one, actually, in the previous one, I told you about real life problem solve arrangement of students in scheduling exam. As you can see there, I mentioned in the question only. So suppose there are 7 students, then scheduling comes here the main problem, because at the first we does not know the name of the students, or no alphabetical order will be there, no lesson number will be there. So how we can arrange the means by using this one, we can even solve the real life problems also. As you can see here, I have taken the graph list here, vertices. Problem what happens in this means, like Excel, how we give the data, the same thing has to be given here, because it does not have its own unique ability as we go for Sage Math, Python. They're having their own ability. Means directly, if I just type the graph by using that libraries, automatically they will create. In some cases, we need to create the graphs and I have to give like the data to it. So later it can present in our favor. So as you can see here, by using this one, we got our result, means 4 chromatic numbers. So this way we can arrange for the students in scheduling the exam, so that the no students can have the same exam at the same time, or else even we can use for scheduling the class timetable also. Okay. The next main aim is to focus on the new kind of programming codes in coloring graph theory and apply it on the standard graphs. Next, to find and implement in all other fields and get the models results, so that any major problem could be solved in quick time by using the programmatic codes.
Thank you, sir. Thank you, sir. Thank you, Vishwas, sir. Tombre, sir. Tombre, sir.
And also audio.
Yeah, sir, you are audible. Start share.
Yes, sir. Only 1 minute, huh?
Screen is not visible, sir.
For 1 minute.
Yeah.
Hello.
Yes, sir.
Screen is visible or not, sir? Hello.
Yes, sir.
Screen is visible or not? My screen.
No, sir. No, it is not.
No. No. Okay. Okay. One minute, sir.
Yes, sir.
Document. Hello, sir.
Yes, sir.
My screen is visible or not, sir?
No, sir, not yet. Now it is visible.
First of all, good afternoon to everyone. Myself, Ashok Dhumre. I am a research scholar student under the supervision of Dr. Gade, sir. I will start my presentation. So, सबसे पहले abstract. So, in this paper, we examine the class of normalized analytic function by employing the concept of Q calculus. Our work to establish coefficient estimation for the initial 4 determinants of the 12-piece matrices T22, T23, T32, and T31 associated with the lambda pseudo star-like function. So mainly here we have to use the star-like function. So सबसे पहले definition, let script A be the family of the function psi, and psi of z is equal to z plus summation n from 2 to infinity a n z raised to n, and there is one condition, this u equals to the z belongs to C such that mod of z less than 1, and script A, this is your class of family of function. Then after that we have to define the Q differential operator. This is given by Johansky Q derivative, and this is defined as, this is definition, dq psi of z is equal to psi in bracket qz minus psi of z upon q minus 1 into z for z not equals to 0 and equals to 1 for z equals to 1. Then we have to use this operation, and this operation operator is called as Q differential operator, and with the help of this we have to define these 4 constants or coefficients. This is my important part. 12-piece determinants. The symmetric 12-piece determinant TQN is introduced by Ali, and this is determinant TNQ equals to first row, second row, third row, nth row, and this is symmetric, and all the diagonals elements are same. That is AN. For n equals to for finding A1 equals to 1 and n greater than or equals to 1 and q greater than or equals to 1, we get T22. This is your just like this diagram, determinant A2, A3, then A3, A2, then T23, then T31 and T32. Our target is to find the value of T22, T23 and T31 and T32. These coefficients are called as 12-piece coefficients. Then we have to find the value of this coefficient. I will goes to conclusion directly. So by using these lemmas, we have to find the value of this coefficient. So theorem number 2, let psi belongs to this family, then we get the mod T22 is equal to 4 in bracket b raised to 4 minus 4 b square n plus 4 n square upon b raised to 4 minus c square minus 4 upon b square, and here the value of b is lambda in bracket, just like this. You have to reply. This is b, this is c, this is n. Then and then by using this we get the coefficient T22. Then after that, theorem number 3, same is here. We have to find the coefficient T23 with the help of this formula. This is value of T23 by using the calculations, and here the value of this delta 1, delta 2, and delta 3 is given, and value of b, n, and c is given in theorem number 2. Also, the next coefficient is T31. Mod of T31 is equal to, in mod, this is value of T31. We get this value, and value of delta 7 is this. Delta 7 equals to b 4 b cube c minus 8 cn minus b raised to 4 plus 4 b square n minus 4 n square, and the value of b, n, and c are in the theorem number 2. Also, we have to find the last coefficient by using theorem number 5. The mod of T32 equals to, this is value in mod a2 minus a4 into a2 square minus 2a3 square plus a2 a4, and this is less than or equals to, we get this value. With the help of basic calculations of mathematics, we have to find this value, and here the value of delta 5 and delta 6 is given, and the value of bn and remaining constants are in theorem number 2, and these are the references.
Thank you, sir.
Thank you.
Rohini
Thank
Deshmukh,
you, sir.
madam.
Yes, sir.
Midkari sir, are you there?
Yes, sir. I'm audible?
Yes, ma'am.
Yes, sir.
Okay, sir. After this,
Good afternoon, sir.
yes, sir. After this, Midkari sir will present.
Okay, sir. Okay.
Can I present, sir?
Yes, ma'am, please.
My screen is visible for all.
Yes, madam, please.
Okay. My title is Application of Laplace Transform in Tumor Growth Model, presented by I. Rohini Deshmukh under the guidance of Prabha Rastogi ma'am and Dinkar Patil sir. Now, my paper content is abstract, introduction, preliminary, application, and conclusion, acknowledgement, references. Now, abstract is the Laplace transform plays important role in modeling contain differential equation. Laplace transform to obtain the solution of 1 minute, sir. Solution of tumor growth model, which is very important in health science. Now, introduction. Laplace transform, integral transform plays important role to solve boundary value problem, and Laplace transform is very simple and easy used in problem. In this paper, we used Laplace transform to find the solution of tumor growth model. Now, Laplace transform is very important in medical science, also in engineering field. Now, this is preliminary definitions of Laplace transform. That means kernel is f of t into function e raised to minus st, integration from 0 to infinity. Okay. Now next is, these are basic theorem, that means properties. For Laplace transform, linearity properties stay as constant. Next is Laplace for derivative. This is main part of my paper, application. Application of Laplace transform in tumor growth model. Now this is logistical model. That means differential equation d by dt is equals to r into n in bracket 1 minus n upon k, bracket complete. Now this is d upon dt. That means change of cell with respect to with respect to time, and R is equals to growth rate of tumor cell. Now N is equals to M, N denotes the number of tumor cell, and K denotes the limit of environmental accommodation. Now apply the Laplace transform of this equation, we get second equation. Now this is solving, we get applying Laplace and Laplace inverse, we get the final equation. That means this is application of Laplace transform in tumor growth model. Now we using that means A is the initial value, and R is equals to growth of cell. Okay, this N, that means rate of change of scale. This change is depends on A and R and K. That means the number of tumor cell at the time t. This is number of tumor cell at the time t is predicted by the equation and substituting value of A. That means this is depends on A and R and K. This is my conclusion. Now acknowledgement. We are thankful to Library of ICT and Mathematical Department of KTHM College Nasik. These are my paper references. Thank you.
Thank you, madam. Medkari sir.
Yes, sir. Yes, sir. Sir, my screen is visible there.
Not yet, sir.
One.
Yes, sir. Visible.
Sir, give me 1 minute.
Yeah.
Sir, someone is ready there.
Screen is visible, but PPT is yet to open. It's not opening, na?
Let me try on PC.
Yeah. So shall I go for the next till then?
1 minute, 1 minute.
Yeah,
Sir,
please.
give me a minute. One.
Okay, okay.
Sir, I think it's visible now. No?
Yes, yes, absolutely.
Okay. Thank you. Good afternoon, everyone. So here I am going to present a paper on the AB fuzzy sublattices and the AB fuzzy ideals of a lattice. Here the introduction, that is the fuzzy set introduced by Gade and Rosenfeld. Use this concept of define a fuzzy subgroupide and the fuzzy subgroup. You studied the fuzzy invariant subgroup, fuzzy ideals, and prove some fundamental properties. Sharma first time introduced and studied the concept of alpha fuzzy subgroup. In H.K. Nimborkar introduced AB fuzzy subring and AB fuzzy ideal of a ring R. We extend the same concept to a sublattice and an ideal of a lattice. So what is that? Is throughout this paper we are denoting L by a distributive lattice with 0 and 1. So here is one definition, that is the let P be a non-empty set. Mapping is a kappa P to 0, 1 is called fuzzy sublattice of P. If kappa and omega are two fuzzy subsets of L, then the kappa is subset of omega if and only if kappa x of less than or equal to omega x. Kappa union omega x equal to maximum of kappa x and omega x, and that is equal to kappa x join omega x. Kappa intersection omega x equal to minimum of kappa x and omega x, and that is equal to kappa x meet omega x for all x belongs to L. Here is the definition of let x and y be a two non-empty sets and G is a mapping from x to y. Let kappa is belongs to 0, 1 and omega belongs to 0, 1. Here this first set is of x and second is of y. Then the image of G of k belongs to 0, 1, close interval 0, 1. And the inverse image G inverse omega is 0 to 1 and defined as follows, that is the G of ky. Here main, I will just conclude this part, that is the introductory part, and I am going to consider the main result, that is the definition. This is important here. A fuzzy subset omega of L is called a fuzzy sublattice if for all xy belongs to L with the following conditions, which are omega x meet y is greater than or equal to minimum of omega x omega y, and omega x join y is greater than or equal to minimum omega x omega y. It already introduced by Yuan and View. So we are just going to consider with the same result AB fuzzy sublattice. What is this? Sharma introduced the concept of alpha fuzzy subgroup, and Yuan introduced the concept of fuzzy sublattice and fuzzy ideal for lattice. We extend the concept of fuzzy sublattice and fuzzy ideal for lattice. Let omega be a fuzzy subset lattice L. In between 0 means 0 is less than or equal to B is less than A is less than or equal to 1. Then the fuzzy set omega AB of L defined by omega AB x equal to minimum of omega x and 1 plus B minus A for all x belongs to L is called AB fuzzy subset of L with respect to a fuzzy subset omega. Here omega is a fuzzy subset of lattice L. Due to that, we can write here some remarks, that is the omega and mu are two fuzzy subsets of x, then omega intersection n over AB we can distribute it. Similarly for the G x to y, that is if supposed to be G is a mapping onto mapping and n is a fuzzy subset of y, define the x and this G is a x to y onto mapping, that you can define this also G inverse. Here the main we are going to define here the AB fuzzy sublattice of L. So what is it? Let omega be a fuzzy subset of L. Let 0 is less than or equal to B is less than or equal to A is less than 1. Then omega is called AB fuzzy sublattice of L. If omega AB is a fuzzy sublattice of L, that is that if following the following condition holds, omega x meet y is always greater than or equal to minimum of omega AB x and omega AB y. Second, omega AB x join y is greater than or equal to minimum of omega AB x omega AB y for all x y belongs to L.
So concluding 2 minutes.
Here is okay, sir. If omega is a fuzzy sublattice of L, then omega is called is also called AB fuzzy sublattice of L. Here is the proof x y belongs to L we have. So by this meet omega AB x meet y, we can consider by the definition what we already defined, that is the minimum of omega x meet y 1 and 1 plus b minus a, which is greater than or equal to minimum of omega x omega y and 1 plus b minus a. We can split it just like this: minimum omega x and 1 plus b minus a, and minimum omega y 1 plus b minus a. So it gives a minimum of omega AB x and omega AB y. Also, we can define for the join. Is it visible there?
Yes.
So omega AB x join y equal to minimum of omega x join y and 1 plus b minus a. Again, it is greater than or equal to minimum of omega x omega y and 1 plus b minus a. So we by this, because here omega satisfy all properties, that is the fuzzy sublattice. Therefore, we can separate it and we'll get the minimum of omega AB x and omega AB y. So it follows that from 1 and 2, that is omega is a AB fuzzy sublattice of L. Here is one example, that is the example shows that converse of this is not true, not holds. What is that? Consider 1 minute. Consider a fuzzy subset of distributive lattice L as shown in figure there is, and I am going to define omega x is 0.3 and 0.4. 0.3 if x equal to 0 and q. Here are the PQRS points. And 0.4 if x equal to P, R, S and 1. If we consider, if we took here the two numbers, that is x, two elements, that is R and S. So omega x equal to 0.4, omega y equal to 0.4. Therefore, omega x meet y. Here by figure we can clear that is the meet of R and S is a Q. And it is equal to 0.3. It shows that omega x meet y is not greater than or equal to minimum of omega x to omega y. Hence, omega is not a fuzzy sublattice of L. But note that if we consider b equal to 0.1 and a equal to 0.9, then 1 plus b minus a equal to 0.2. And that is omega x is greater than 1 plus b minus a for all x belongs to L. Hence, omega AB x equal to minimum of omega x and 1 plus b minus a equal to 1 plus b minus a. So it holds, that is the second omega AB x meet y is greater than or equal to minimum of omega AB x and omega AB y. That is equal to 0.2. It means that it holds the property. So hence the omega is an AB fuzzy sublattice of L. Omega is an 0.1, 0.9 fuzzy sublattice of L. But the converse is not true.
So please conclude.
Yeah. So similarly, we can consider here the fuzzy sublattice, that is the again AB fuzzy sublattice. If we consider the intersection of AB fuzzy sublattices, it is also a fuzzy sublattice. Here is the proof. One more, sir, give me 1 minute. Here is the again one more result, that is AB fuzzy ideal, that is introduced by the Yuan and Wu. The same concept defined for a ring by the Eskin-Borker, sir. And here we are extending it for the lattice. So if omega is a fuzzy ideal of L, then omega is also AB fuzzy ideal of L. Okay. So these are the references. These are the references I used. Mainly this paper is based on the Eskin-Borker. That is in
Thank you, sir.
2020.
Thank you,
Okay.
Saugale.
Thank you, sir.
Okay, next is Saugale, madam.
Sir, can I present?
Yeah, I will let you take your presentation after Bhavikati, sir.
Okay, sir.
Hello, Mamta, madam. You there? Mamta Saugale, madam. Okay, Bhavikati, sir. Kantappa Bhavikati, sir. Please start your presentation. Hello. Okay, Bhosle, madam.
Yes, sir.
Please.
Sir, Lakshmi madam is also.
Bichar, madam.
Oh, sir.
Okay, after Bhusle madam, you can present your prayers.
Okay, thank you, sir.
Hello, sir.
The screen is visible for you?
Yes.
Hello, sir.
Ma'am,
Okay.
go to main results and conclude, ma'am, please.
Hello, sir.
Okay, sir.
Hello.
Yes, sir.
My paper is
My biocati, sir.
Yeah. After this, I will let you present your paper, sir.
So I am Archana Arvind Bhosle. My present paper is Fractal Marder Space Time with Perfect Field by guidance of Prabha Rastogi madam. In this investigation, the anisotropic and homogeneous Marder space time is analyzed within framework of fractal gravity theory, including properties of the perfect fluid. Here solved differential equation, field equation by using Hubble law and assuming relation P1 is equal to Pn square. And also here discuss cosmological parameters by using graph. Now this first graph, that is scale factor versus Cosmos time. And here scale factor is finite when initial time t is equal to 0. Now second graph is Hubble parameter against cosmic time. And here t goes to infinity, all physical and kinematical parameter approaches 0 and statical volume becomes infinite. Now third result is pressure against cosmic time. And the graph is observed that it is initial condition pressure exhibits a significantly large negative value. Next graph is density against cosmic time, and it is observed that energy density correspondingly large positive value. And last result, that is EOS against cosmic time. EOS means equation of state parameter against cosmic time. When EOS is equal to 0, pressure is equal to density, that is referred as stiff fluid matter. And next, EOS is equal to 1, it corresponds dust universe. And EOS is equal to -1, that is system is identified lambda CDM model. EOS less than -1, it is phantom model. Now conclusion, we found that the universe initiates its expansion from Big Bang singularities for large time current model. Initially, our present model behaves like a dust universe as time progresses. It shows that standard lambda CDM model and crosses phantom divide line reaches singularity. Phantom dark energy model for the range M lies between 0 to 1. And for M, n is not equal to 1, that means mean anisotropic parameter is non-zero. Therefore, the model is anisotropic. Now these references here used. Thank you, sir.
Thank you, madam. Stop sharing screen.
Yes, sir.
Maitri, sir. Maitri, sir. Prashant Maitri, sir.
Myself. Hello.
Maitri, sir. Prashant Maitri.
Sir, biocati, sir.
Okay, sir. Please start.
Sir, how to share the screen? Hello.
It is visible. So start, sir.
Hello.
Sir.
Sir, I am
After this, sir.
After this, okay, sir.
Yeah.
Okay, thank you.
Maitri, sir, start your presentation and finish in 2 minutes, man. Maitri, sir. Hello, Maitri, sir.
Hello.
Sir. Start, sir. Directly go to the main conclusion, sir.
I will just briefly give the introduction and I will jump into the result. Just I'm not getting
Yes,
into
yes.
deep dive.
Yeah.
Just I will give the briefly what I'm doing, what I have done. Just I will briefly explain. Okay. Just if you looked at my title is the effects of the radiative convective condition on MHD magnetohydrodynamic fluid flow heat transfer in the third grade fluid flow over a stretching sheet with the non-uniform internal heating, and I have done the entropy analysis. Just briefly explaining what I'm doing. Just if you go for the industry production, especially in the manufacturing field, there is so many processes are there. In that, I have worked on the cooling processes, especially when the metal is going to cool. There we are using the different types of liquids are there. When it comes to the industry, they have the Newtonian and the non-Newtonian liquids are there. Especially when it comes to the Newtonian industry, most of the viscosity is very less is there, and they have the very high conducting liquids over there. And majorly, just what I have done, just what I'm looking at, just I have applied some different kinds of liquids over here, and I have to look at which liquid is the better for the performance, because when I applying the cooling liquid, it shouldn't affect the quality of the that metal sheet. Just maybe sometimes what happen, there is a combustion process is going on within the when you making the metals with a very high thickness. They have using the very high industries. In that case, just we have to which liquid is going to use the better thing, and I have done the thermodynamics analysis also I have done. And basically when I said the majorly fluid flow heat transfer in the metal sheet, just here I have developed my equation based on the boundary layer theory. If you looked at, and here I have considered by the just this is a one of my work. And if you looked at over here I have my sheet over here. The stretching sheet is there, and they have the porous medium is there. Just there is a small pores are there. Just there is a different kind of industries there I am going to use. And here they have the one is the medium is porous is there. Another one we have the thermal boundary layer is that it is nearer to sheet, and then we have the away from that one we have the momentum boundary layer is there. And these are my governing equations. If you looked at here, we have the continuity equation, and this is the momentum equation. Here I have considered one of the non-Newtonian liquid, that is the third grade fluid. This is the one of the property of the non-Newtonian liquid I have done over here. And here I have considered the radiation also. And because if you looked at when I go for when I said the metal sheet, when it comes to the end, there is a very high heat is there. Just I have to apply the liquids. Just to I have to apply the highly heat electric conducting liquids over here. So that is the reason I have considered over here the electric conducting radiation as well as the non-uniform heat source. Okay, and these are my here if you looked at, this is a radiation equation, the specific equation. Here we are going to get the fourth order of that equation over here. And then here I have the boundary conditions. Just here I have convective heating boundary condition, what I have considered over here. And then when I use I have the partial differential equation based on the boundary layer theory, and then I have the boundary conditions also. Here I have considered the convective boundary conditions, and then when I use with the boundary condition, when I got the non-linear equation, this is the ordinary differential equation. Then I have solved for the one of the numerical method, Runge-Kutta method. Just when I solved this one, just I have got this equation. And just if you looked at, just I have done the entropy analysis also, the thermodynamics, the second law, what I have done the entropy analysis here. And these are the some dimensional parameters what I have mentioned, what I'm going to get in the if you observe over here, just if you look at over here, this is a E1, E2. These are the specifically these are the what I said, the third gate fluid. These are the some parameter, the flow parameters. And here we have the magnetic parameter. Here what I have applied the electric conducting fluid. Just and here we have the porous parameters also. And then here we have the radiation Prandtl number, and these are the heat sourcing parameter. When you go for the higher values, it is the heat is increases. When you go for the negative value, it is sinks, because there is some variation over there when I apply for these electric conducting fluids. And then just these are the some of the graphs what I have got over here. Just if you look at the here we have the Grashof number. Grashof number just what it is doing when I increase the value of the Grashof number, the velocity is accelerated by increasing in the buoyancy force. Here the buoyancy force play a key role over here for the higher values. Just what is it? It is indicates the cooling of the sheet over here. And then here we have the porous parameter. The porous parameter, what will do just when you go for the values, what will suggest that it is more porous means they have the some holes are there. Just what it will resist the force and it will try to slow down the flow over here in that field. Just if you go for the higher value for the temperature, it is decreasing due to the high heat over here. And especially moreover here I have considered the radiation parameter. So if you look at the radiation parameter, just the boundary layers are increasing over here. Just if you look at the in the radiation parameter, we have the Russell approximation. It is 10 to the increase over there. And then here that is some of the screen friction. What is how the boundary layer will do. Obviously, when I using some different types of the flip plate is coming out from the connection. There is some skin friction is there. So that overall what I'm trying to say over here, just here there is when you go for the industry some realistic one, they have so many processes. It is one of the cooling processes. What I'm trying to do, just there is some different medium, is there different sheets are we are going to project. This is one of the work just what I concluded. This is my summary, and this is
Thank you, sir.
Thank you. If you have any questions, just let me know.
Thank you.
Okay, thank you, sir. Thank you.
Okay, Bhavikati sir, please. Bhavikati sir, please start your presentation.
Okay, sir. Sir, how can I share the screen, sir?
There is an option, no?
Share screen option. Share
Yeah,
screen option. Sir. Start share, yes, sir.
Yeah, please start. But I am not able to visible your screen.
Shall I open the?
It's there on your account.
Is it, sir, sharing, sir?
Bhavikati sir, do one thing.
Okay,
I have shared the Google Meet link.
Okay,
Sir, can I give present?
No, ma'am. Just join with that link. I'm already in the link meeting now, Google Meet. So just
Sir, please
join there.
ask.
So, hello.
Hello,
Hello,
tell
sir.
me, sir. Tell me, sir. Hello.
Hello. I have
Hello.
shared the Google Meet link. Please join there.
Okay, sir. Please share that Google Meet.
It's in the chat box.
Okay, sir.
Chat box. Okay, sir. I will see that.
SSG.
Okay, sir.
Chat box. Sir, what is the link, sir? Where is it? Are you shared, sir? Hello. Is it chat box?
ये है आपकी जिंदगी के कुछ खास हिस्से जिनके बिना आप जिंदा नहीं रह सकते। क्या एक्सेप्ट करे थे? ये है आपका टीवी जिसके साथ आप हंसते हैं, रोते हैं। आई ओके? ये है आपका मोबाइल जिसके साथ आप जागते हैं, सोते हैं। ये है आपका चार्जर जिसके बिना आपका मोबाइल सांस नहीं ले पाता है। हेलो, पर जैसे ही ये पुराने होते हैं, ये कर देते हैं आपकी पोजीशन में पंचर। तो फिर आप क्या करते हैं? रात गई बात गई, अब तू कौन मैं कौन। अब तक आपने जिससे आपकी जिंदगी के कुछ खास हिस्से जिनके बिना आप जिंदा नहीं रह सकते। जिसके साथ आप हंसते हैं, रोते हैं। ये है आपका मोबाइल, जिसके साथ आप जागते हैं, सोते हैं। ये है आपका चार्जर, जिसके बिना आपका मोबाइल सांस नहीं ले पाता है। पर जैसे ही ये पुराने होते हैं, ये कर देते हैं आपकी पोजीशन में पंचर। तो फिर आप क्या करते हैं? रात गई बात गई, अब तू कौन मैं कौन। अब तक आपने जिससे लिया मजा, वो आज देता है दुनिया को ग्लोबल वार्मिंग की सजा। अब तक आपके घर की जो था शोभा, वो आज फैला रहा है किसी और के घर में बीमारियां। यानी कि हमारे इलेक्ट्रॉनिक उपकरण जब हमारे काम के नहीं रहते, तब वे पर्यावरण के लिए बन जाते हैं ई वेस्ट। और ये वेस्ट कोई मामूली वेस्ट नहीं है, क्योंकि इन उपकरणों में मौजूद होते हैं मर्क्यूरी, लेड, कैडमियम, क्रोमियम और प्लास्टिक्स जैसे टॉक्सिक पोल्यूटेंट्स, जो इंसान और पर्यावरण दोनों के लिए हानिकारक हैं। आज देश के असंगठित क्षेत्र में कार्यरत हैं देश के लाखों लोग।
Very good evening to one and all present over here. दोस्तों, सुबह से बहुत सारे सत्र हुए. उन सत्रों में हम सब एक दूसरे से मिले, डिस्कस किए. उसके आउटपुट एक दो शब्द आपके लिए मैं बोलना चाहती हूँ. आपके साथ कुछ लम्हे, कई यादें बतौर इनाम मिले. आपके साथ कुछ लम्हे, कई यादें बतौर इनाम मिले. एक सफर पर निकले और तजुर्बे तमाम मिले. एक सफर पर निकले और तजुर्बे तमाम मिले. So with these words, once again I welcome you all for the valedictory function of one-day national conference on recent trends in mathematics. Dignitaries on the dais, President of the program, Professor Alankar sir, beloved Principal Dr. Rudraj Bua sir, today's chief guest Dr. Prashant Pawar sir, Dean of Science, Punyashlok Ahilya Devi Holkar, Solapur University, Solapur, Dr. Kore sir, convener of the one-day national conference on recent trends in mathematics, Dr. Dhone sir, co-convener Dr. Gade sir, all delegates, management council members, head of the various departments, faculties from different part of India who joined online and who were present for offline sessions, and my dear student friends. I am very happy to welcome you all once again for this valedictory function. Now I request convener of this conference, Dr. Dhone sir, for welcome and summary of the program.
Thank you, ma'am. Good evening, one and all. Respected today's chief guest, Dr. Prashant Pawar sir, Dean of Science, Solapur University, Solapur. Our principal, Dr. R.P. Bua sir, Dean of Arts, Professor Dr. Vasant Kore sir, President of our today's function, Professor Dr. Sanjay Alankar sir, my guru, all participants, students, session chairs, and other delegates also. Once again, I welcome to this valedictory function in this. Since from the early morning, we have gathered here for various exchanges in advanced mathematics. Friends, we have started the program with nice inaugural address by Dr. V.B. Patil sir. After that, very healthy session by our Professor Dr. M.M. Sekhare sir. on mathematical modeling of some real world problems. The second session is very fruitful to us by Dr. Balla sir. He is from Central University, Telangana. The last third session by Dr. M.G. Srigan sir also delivered a very nice lecture on geometry of complex variables. Online and both offline paper presenters are also presentations are also conducted very nicely. I am specially very much thankful to Dr. V.V. Kharat sir and Dr. Kaji, who is the alumni of our college, who helped us in organizing this conference successfully. Almost all paper presenters presented their papers, and they are from various corners and also from many states, remarkably from Andhra Pradesh, Telangana, Rajasthan, Karnataka, and various corners of Maharashtra. Sir, I am very grateful to let you know that more than 125 students and researchers registered for this. Many of them, they have attended through online, offline also, even though since morning these people are waiting. So all healthy sessions, I think so, from your side, we have conducted. So once again, I am very much thankful to the organizing committee of this national conference. Once again, thank you. With these words, I am going to conclude my speech.
Thank you very much, sir. Now we will listen Sangameshwar Gade. This empowers everyone to keep going, encourages the mindset of learning, and makes the journey of learning enjoyable.
मार्गक्रमिते संगमेश्वर सारधेनु सारताहे सारुहामि निरंतर शिक्षणात्मानासके मार्गक्रमिते संगमेश्वर कर्मयोगी बीजधारी कराने करके सिंचना
Thank you, one and all. Respected audience, today we are honored to have Dr. Prashant Pawar, Dean of Science, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur, amongst us as chief guest. Now I request Dr. Pratap Sinha Gore Patil sir to introduce the chief guest to the program.
Thank you, madam. Good evening, one and all. It is my great pleasure to introduce today's chief guest, Dr. for this validity function, Dr. Prashant Pawar sir. Dr. Pawar sir is currently working as a professor at Sweri College of Engineering, Pandharpur. He completed his BE in Civil Engineering from Shivaji University, Kolhapur, and M.Tech from IIT Guwahati. He obtained his PhD from the IISc Bangalore. Dr. Pawar sir has published near about 63 research papers in reputed international peer-reviewed journals. And till date, he has 8 books published on his credit. His total citations are 1025, H index of 34, and I-10 index of 35. He has published 6 patents in engineering innovations. Now 7 students are completed their PhD under the guidance of Dr. Pawar sir, and currently 3 PhD students are working. He has successfully completed 9 research projects funded by DCT, AICTE, and UGC. He got the Best PhD Thesis Award in 2006 by IISc Bangalore, and also AICTE Vishwesvaraya Best Teacher Award in 2020. Currently, he is working as an in-charge dean, Faculty of Science and Technology, and as a chairman, BOS Civil Engineering of Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. I am once again thank you to organizing committee for giving this opportunity. Thank you.
Thank you, sir. Atiti Devo Bhava. According to these words, I request beloved principal, Dr. Ruturaj Bua sir, to felicitate today's chief guest. Thank you, sir. I request Principal Sir also to felicitate President of the program, Professor Sanjay Alankar Sir. Thank you, sir. Now I request dignitaries on the dais to share a token of love from the conference in the form of memento to the session chairs. First of all, I call upon Dr. A.M. Mahajan, sir. Sir, please. Thank you, sir. Next, I request Dr. J.D. Mashale, madam, to receive the memento. Thank you, madam. Now I request V.V. Kharat, sir. Then we had a technical session where we had the online and offline paper presentations. The chairman of the sessions are Professor R.D. Mahimkar, sir. Thank you, sir. Dr. A.R. Reshimkar, sir. Thank you, sir. I request Professor Yanai Dhanshetty, sir. Sir is Head Department of Mathematics, CB Khedgi College, Akalkot. Thank you, sir. Dr. Prashant Sutkar, sir. Sir is from Department of Mathematics, Science College, Nanded. Now I request convener of the program, S. Dhone, sir, to felicitate Kore, sir. Now I also request Dhone, sir, to felicitate. Thank you, sir. Felicitate our principal, Dr. Rudraj Bua, sir. Thank you, sir. Now I request our beloved principal, sir, and senior professor, president of the program, Sanjay Alankar, sir, to render the token of love, the memento to chief guest of the program, Dr. Prashant Pawar, sir. Thank you, all the dignitaries. We are honored to have the chief guest, Dr. Prashant Pawar, sir. Now may I request, sir, for valedictory address.
Good evening. So, Honorable Principal Bua sir, my friend and in charge Dean of Humanities, Kore sir, my Guru Alankar sir, and organizer of the conference, Dhone sir, Gade sir, all the dignitaries, other dignitaries, participants, dear friends. When I received this invitation for this function, I thought I am the odd man out for this function because I'm neither from science nor from maths. But I have close relation with maths because I feel sometimes maths is in my gene because my father is maths teacher. And to my surprise, when I was coming for this function, I was telling Kore sir that This is the Sangameshwar College where I didn't get admission for my 11th. And I have been invited as a guest for some function, and I get opportunity to come for various activities for this. And then Bua sir introduced me to Alankar sir, who helped me to get the admission for Walchand College for 11th and 12th. What a great coincidence. And I also remember, maybe I have little short memory loss problem. I remember very few things, but I remember incident with Alankar sir, which he may not remember. He might have guided several students. I remember I came from a small village called Khardi, where my Marathi mother tongue was like a typical Pandarpuri Marathi, you can understand. With that, this very sophisticated Marathi speaking Solapurkar used to teach me. And in first unit test of maths itself, I got 30 out of 30 maths. That's another coincidence. After that, I had trouble to get marks in various tests, and even in 11, 12. Somehow I cleared my 12th. That is different story, but these are some kind of preamble, good memories I got through this program. Thank you, Done sir and Kore sir, for inviting me for this function. So it's great. Like sometimes we wonder how or what things should be discussed in such a national conferences related to basic subjects like mathematics. But we must understand like maths is a mother for various sciences. And if you see, I treat it as like mathematics is in gene of every one of us. Everything in the nature, everything in our life is governed by maths. And if you see, my close friend Kore sir is from arts. So his faculty is the most difficult mathematics. The things which we will not able to model, or it took almost some of the things, for example, some of the notes of music or some of the phenomena of arts, or maybe like why things look beautiful. If you see, like for example, in maths, golden number, right? So if you see, our body is designed by God through golden numbers. So you took like maybe Da Vinci invented like the golden number, where our body proportionality is governed by the ratios of the golden numbers. And that was a kind of, when by the time it was invented as a with some mathematical correlation, by that time it was art. So Kore sir, your branch, sometimes we keep on discussing like, so I feel like, and that's how I after getting bored with maths and mathematical modeling, I have shifted to looking into arts, because that's the typical maths. That's one thing I want to pose. So many problems in nature and in arts are still needs to be modeled, and that's where mathematics is required. That's one point I want to address. Second point, very important point, which I learned through applied mathematics. And so why our students are getting alienated from mathematics is we are making things difficult. So I feel what we should do is, when we teach maths, we have to take the examples from physics or physical life. So I give you example. For example, the rotation of fan is governed by mathematics, RPM and things like that. So when we have to explain that mathematics, we have to take example of the physical examples. And the moment person becomes expert in mathematics, he should visualize everything in maths. If someone is walking, someone is talking, like if I am talking in slow speed, if you take the person who is speaking, let's say Lalu Prasad is talking, his speech, so a lot of mathematics is involved, or the person who is talking with a high speed. So these things, if we start correlating, it will become easy. So when I teach like some of the engineering subjects through mathematics, first I give lot of examples about the real life problems. So to give you example, it will be very difficult for me to give examples. So I will give two examples. One example, I teach dynamic subjects, and all of you know Newton's laws. So how I teach Newton's first law, Newton's second law, Newton's third law, which required us in dynamic analysis. So what I say, if child falls down, he will get less injury, whereas elderly person falls down, he will get more injury. How it happens? If you see with Newton's second law, our mass will be quite higher than the kid's mass, and that's why mass into acceleration will be high. And when the person falls down, when he touches to the ground, which law acts? Newton's third law. That is, every action will have equal and opposite reaction. So if we start simplifying our complicated subjects by taking such example. Another example I give, that is the our dynamics, the addition of, let's say, what do you call, inertial force, damping force, and then what do you call, restoring force is equal to external force. So I give them example of our rigid chair. If we sit and jump on the rigid chair, what we will have is Newton's third law. We will have the amount of force we apply, that much impact will be there for us. But if we have a chair with spring and damper, that phenomena is different. So the moment we start giving these example, mathematics will become easy. And that's what our role as a teacher is important, how we attract people on the subjects, difficult subjects like maths for mathematical modeling. And to tell you, as I told you, maths is a mother for so many subjects, let it be chemistry, maths, engineering, computer science, and the advanced one is AI. If your maths is not good, you will become, I keep telling the example of aptech. Do you remember aptech computer? So you don't understand. If you don't understand maths, then it will be just like a black box. Whatever computer things you are using, it will become a black box. And that's, again, I want to relate with that. What is the most difficult part in our life is language. How we speak, how we talk, it is very difficult to model mathematically. And that's why it took these many years. Lot of advancement took place, lot of mathematical development took place, but natural language processing was the most difficult part. And with the advancement of these mathematical calculation, mathematical computation, you see now, after almost in the 21st century, it took for modeling of NLP, and that's where your Chat GPT and new DeepSeek, etc., is coming into picture. And still, it is not able to model equivalent to that of our, what you call, dumbest person who talks in our language. If you say, write something in mathematics, or if I say, when I and Ronge sir travel to some places, we don't talk the pure Marathi, because we don't want people to understand what we are talking. So it is that difficult. So even though you model, you use computer, and modeling what human does is difficult, and still lot of scope is there. The last example I will give and conclude my speech is that how the base of mathematics becomes important even when we have to model or do the advanced things in the hardware or electronics or computer science. I was working on one of the problem in image processing, and we wanted to burn that software on small chip so as to make a standalone application. We were doing the kind of classification of bedana, what is called it as a resin, drakshacha bedana. So classification, and in that image processing, there was one algorithm about the inverse of matrix. And if you see inverse of matrix, there is a one way of doing, or if you search on Google, if you ask the code for the C in inverse of matrix, you get it through what you call Kramer's rule. That is adjoint of A by determinant of A. And if you see, that is the most difficult part, or it takes, if you, the size of matrix increases, then it is the highly computational problem as compared to your what is called A into A transpose, sorry, A into A inverse equal to I. That approach, what do you call, elimination method, Gauss elimination method type of approach. And my student who was doing that modeling, he got easy code from that, and he was telling, sir, he's getting error that memory is not sufficient. And if you see, the person who is computer engineer, if he is not having good base of mathematics, he will not able to solve the big problem. And that's where the importance of maths come. And that's what we have to project, highlight how some of these fundamentals are important to solve even the difficult problem. And I see, and if you see in Western countries, the like maths graduates are highly paid than that of the computer graduates. And that's what you'll have to play the bigger role by connecting this technology with maths and the other problems. And then only students will get attracted, and then will again the good days will come for the maths, and then only we will have some good people, or the people with beautiful mind like John Nash. That's what I see. All of you I see as a people with beautiful mind. Again, I thank all of you for inviting me and listening patiently from the person who is odd man out here. Thank you.
Thank you very much, sir. Explaining the importance of mathematics with your real life examples. Thank you once again for being amongst us. Okay, now may I request the delegates, if anybody voluntarily, please come and give the feedback of the conference. Please come forward. Yes, please.
Good evening, everyone. Myself, Priyanka Lokhande. I am a postgraduate student from a DB of Dayanand College of Arts and Science, Solapur. So, and I feel honored to have attended this one-day national conference on a recent trends in mathematics. The conference was exceptionally well organized with insightful sessions and thought-provoking discussions. The expert speakers provided deep knowledge of emerging trends, and the research presentations showcased innovative ideas in the field of the mathematics. So the interactive sessions encourage the learning and collaboration, making the experience truly enriching. So I sincerely appreciate the efforts of the organizers and speakers for making the conference a great success. So I'm looking forward to more such opportunities in the future. Thank you so much.
Thank you. May I ask one more feedback from left side of the dais? Pratik Ugral from Punyashlok Ahilyadevi Holkar, Solapur University.
Good evening to all of you. I am Pratik from Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. And I would like to thank, first of all, the Honorable Dhoni sir. Being a student of statistics, I am a single statistician who participated in the conference of mathematics. and I learned a lot of basic things which I need to learn from mathematics. My our head of the department, Gade sir, say statisticians should know more maths than mathematicians. Basically, if I'd like to conclude in simple terms, if there is no mathematics, then there is no statistics. In simple terms, mathematics is nothing but statistics is nothing but the applied mathematics. So if I talk about the conference, everything was perfect, I say, and most important part is that the food was delicious. I like the most part is food was delicious, and ultimately, my friend, I am a student of Sangameshwar College. So my teachers, I'm quite happy that I got an opportunity to meet all of them and enjoy the beautiful minds and the get together of researchers. Thank you to thank you to all of you.
Thank you very much. May I now request President of the program, Professor Sanjay Alankar sir, for presidential remarks.
मी मराठीत बोलणार आहे. तर प्रथमतः मी संस्थापक काडाजी साहेब आणि काडाजी मॅडम यांचा आभार मानतो की त्यांनी मी इथलाच विद्यार्थी होतो BSc मॅथमॅटिक्स. तसं मी डबल ग्रॅज्युएट आहे. BSc केमिस्ट्री झालं होतं, मग BSc मॅथ्स वालचंद कॉलेजला नसल्यामुळे मी इथं आलो. त्यामुळे मी इथलाही स्टुडंट झालो आणि मला या कॉलेजमध्ये इथं पार्टिसिपंट आणि प्रेसिडेंट व्हायची संधी मिळाल्याबद्दल मी आधीच संस्थापकांचे आभार मानतो, तसंच ऑर्गनायझर्सचे आभार मानतो. माझा बायोडेटा म्हणजे आता तुम्ही सगळा पाहिलाच असेल. हे माझे विद्यार्थी आहेत. ते ढोणे सर विद्यार्थी आहेत, दर्गो पाटील सर स्टॅटचे विद्यार्थी आहेत, समोर एक आहेत माझे सहकारीच आहेत बाकीचे. तर हाच माझा बायोडाटा. आणि कारण का तर ते आता आमचे हेड आहेत सगळे. आणि मला आता प्रोग्राम विषयी बोलायचं. तर ही जी नॅशनल कॉन्फरन्स रिसेंट ट्रेंड्स इन मॅथमॅटिक्स मध्ये घेतलेली आहे, एक दिवसामध्ये अगदी सुटसुटीत परंतु अगदी प्रभावीपणे मांडली गेलेली आहे. त्यामध्ये 3 महत्वाचे चांगले लेक्चर्स झाले. शिखरे साहेबांचं कीनोट एक्सप्रेस झालं, त्यानंतर बल्लाळ आणि श्रीगंध सर हे अगदी वेगवेगळ्या अशा मॅथमॅटिक्सच्या ब्रँचवर आणि आधुनिक अशा गणिताच्या पद्धतींवर ते झालेलं आहे. विशेष म्हणजे बल्लाळ सरांचं तर ते नवीन इंट्रोडक्शनच होतं, म्हणजे रिसर्चच्या दृष्टीने, तर तेही महत्वाचं होतं. तर अनेक नवीन मॅथमॅटिक्सचे जे संशोधक आहेत त्यांनी त्या विषयाकडे लक्ष द्यायला हरकत नाही असं मला वाटतं. तर या सगळ्या 3ही महत्वाचे लेक्चर्स झाले आणि त्या अजून विशेष म्हणजे पेपर प्रेझेंटेशन यामध्ये भरपूर सहभाग झालेला आहे. ऑनलाईन मला वाटतं 27 झाले असतील आणि ऑफलाईन जवळपास 14 ते 15 असे पेपर प्रेझेंटेशन अगदी पूर्णपणे पार पडलेले आहेत असं मला आमचे राजकुमार साहेब यांनी सांगितलंय सरांनी. आपले या कॉलेजचे प्राचार्य RP बुवा यांचे मी आभार मानतो की त्यांनी मला इथं येण्याची संधी दिली. तसंच माझे हे इथले ऑर्गनायझेशनचे को कन्व्हेनर आणि कन्व्हेनर गाडे सर आणि ढोणे सर या दोघांचेही मी अभिनंदन करतो, कारण त्यांनी अगदी व्यवस्थित कार्यक्रम राबवलेला आहे. सर्टिफिकेट प्रेझेंटेशन हे सगळं व्यवस्थित पूर्ण केलेलं आहे आणि त्याप्रमाणे सगळ्यांना व्यवस्थित वाटप केलेलं आहे. बाकी जेवणाबद्दल या आपल्या विद्यार्थ्यांनी सांगितलेलंच आहे, मी सांगायची काही गरज नाही. एकूण व्यवस्थापन सगळं छान होतं आणि आपला सगळ्यांचा सहभागी चांगला होता. तर आपलेही अभिनंदन, आभार, सहकाऱ्यांचेही अभिनंदन, आभार आणि कर्मचाऱ्यांचेही अभिनंदन, आभार. एवढं बोलून मी माझे 2 शब्द संपवतो.
Thank you very much, sir. Now I request Sheikh sir from Department of Chemistry for vote of thanks.
गुड इव्हनिंग टू वन अँड ऑल. मला माहित आहे सगळेजण दिवसभर थकलेले आहात, परंतु ज्यांनी हा कार्यक्रम घडवून आणला त्यांचा आभार व्यक्त करणं खूप गरजेचं असतं, कारण हा आभार मानल्याशिवाय त्यांना पुन्हा दुसरा कार्यक्रम करायला उत्साह येणार नाही. त्यामुळं संत ज्ञानेश्वराच्या ज्ञानाने, महात्मा फुलेच्या संघर्षाने, डॉक्टर बाबासाहेब आंबेडकरांच्या प्रज्ञेने, छत्रपती शिवाजी महाराजांच्या पराक्रमाने पुनीत झालेल्या महाराष्ट्रामधील सोलापूर जिल्ह्यातील रामेश्वराच्या नगरीमध्ये कैलासवासी आप्पासाहेब काळोदी यांच्या आणि कैलासवासी मेघराज काळोदी काका यांच्या पदस्पर्शाने पुनीत झालेल्या संगमेश्वर कॉलेजमध्ये आपण सकाळपासून आलात. आल्यानंतर त्या ठिकाणी तुमचं स्वागत तर झालंच, परंतु आभार मानणं देखील तेवढंच गरजेचं आहे. म्हणून मला या ठिकाणी असं म्हणायचं आहे की उपस्थित जे कोण आजचे पाहुणे सकाळपासून आतापर्यंत, तर पाहुण्यांचं येणं फक्त येणं नसतं मित्रांनो. पाहुण्यांचं येणं फक्त येणं नसतं, त्यांनी लोकांच्या हृदयावर कोरलेलं लेणं असतं. त्या लेण्यातून देखील काहीतरी समाजासाठी आणि लोकांसाठी देणं असतं. त्या देण्याने किंवा दातृत्वाच्या वतीने प्रेरित झालेले आज सकाळपासून आतापर्यंतच्या कार्यक्रमामध्ये ज्यांनी व्याख्यानं दिली असे सगळे जे कोण असतील त्यांचे या ठिकाणी आभार मानणं गरजेचं आहे. प्रथमतः मी संस्थेचे आभार मानतो. कमळावरती भ्रमर पाय ठेवी आळवार, कुचंबेल केशर या शंका. ज्या वेळेस भ्रमर कमळावरती पाय ठेवतो त्यावेळेस त्या भ्रमराला देखील चिंता असते की माझा पाय फुलातील पुंकेसर आणि स्त्रीकेसरला लागू नये, अशी काळजी वाहणारे आमच्या संस्थेचे सचिव आणि अध्यक्ष माननीय धर्मराज काळादी साहेब आणि सचिवा ज्योती काळादी मॅडम हे नेहमीच आम्हाला सपोर्ट करतात कार्यक्रम घेण्यासाठी. त्याबद्दल प्रथमतः मी त्यांचं या कार्यक्रमातील कन्व्हेनर जे असतील म्हणजे डोने सर असतील किंवा आणखी गाडे सर असतील तर सर्वांच्या वतीनं प्राचार्यांच्या वतीनं मी त्यांचा आभार मानतो. या कार्यक्रमामध्ये पहिलं लेक्चर झालं किंवा इनॉग्रेशन झालं, त्या इनॉग्रेशन साठी वेळेत वेळ काढून या ठिकाणी आपल्या विद्यापीठाचे फिजिक्स डिपार्टमेंटचे हेड आणि इन्क्युबेशन सेंटरचे डॉक्टर बी पाटील सर यांनी वेळेत वेळ काढला आणि या ठिकाणी आले. त्याबद्दल संस्थेच्या वतीने, प्राचार्यांच्या वतीने, कॉलेजच्या वतीने, आपल्या सर्वांच्या वतीने मी त्यांचं या ठिकाणी आभार मानतो. नंतर आजच्या कार्यक्रमासाठी आपल्याला जे व्याख्यान देण्यासाठी आले ते पहिले कीनोट ज्यांनी दिली ते डॉक्टर शिकारे, फॉर्मर हेड होते सावित्रीबाई फुले पुणे युनिव्हर्सिटीमध्ये मॅथमॅटिक्स डिपार्टमेंटचे. नंतर ते आज प्रोफेसर म्हणून काम करतात JSPM युनिव्हर्सिटीमध्ये. त्यांनी या ठिकाणी आले आणि मॅथमॅटिकल मॉडेलिंग वर उत्तम रीतीने त्यांनी आपल्याला व्याख्यान दिलं. त्याबद्दल त्यांचेही मी या ठिकाणी आभार मानतो. त्या सेशनला चेअरपर्सन म्हणून वालचंद कॉलेजमधील मॅथमॅटिक्सचे हेड डॉक्टर महाजन सरांनी भूषवलं. त्याबद्दल त्यांचंही मी संस्थेच्या वतीने, प्राचार्यांच्या वतीने आभार मानतो. दुसरं सेशन झालं डॉक्टर बल्लाळ सरांचं. त्यांनी ग्राफ, हायपरग्राफ याच्यावर बरंच काय सांगितलं. मला त्यातलं एवढंच कळालं होतं की म्हणे टॉपोलॉजिस्ट कांट डिस्टिंग्विश डोनट फ्रॉम द कॉफी मग. खूप चांगल्या भाषेमध्ये त्यांनी, सोप्या भाषेमध्ये आपल्याला समजावून दिलं. चांगला त्यांचा आर्टिकल होतं. तर त्याबद्दल मी त्यांचे, बल्लाळ सर हे तेलंगणाहून आले मित्रांनो. नाही स्कूल ऑफ मॅथमॅटिक्स, युनिव्हर्सिटी ऑफ हैदराबाद विनंतीला मान दिला, ते आले, त्याबद्दल त्यांचंही मी या ठिकाणी आभार मानतो. नंतर मग तिसरा सेशन झाला श्रीगन सर म्हणून जे SPM युनिव्हर्सिटीचे मॅथमॅटिक्सचे प्रोफेसर होते. त्यांनी देखील मला वाटतं जॉमेट्रिकल फंक्शन थिअरी इन कॉम्प्लेक्सस व्हेरिएबल असं त्यांनी उत्तमरित्या आपल्याला सोप्या भाषेमधून सांगितलं, त्याबद्दल मी त्यांचेही आभार मानतो. नंतर आभार मानत असताना ज्यांनी कालपासून या कार्यक्रमाला सेशनला ज्यांनी चेअरपर्सन म्हणून काम केलं ते सिंहगड युनिव्हर्सिटी मधले डॉक्टर खरात सर, विनोद खरात सर. काल गेस्ट आल्यापासून ते आमच्या बरोबर राहिले आणि आज दिवसभर देखील त्यांनी या ठिकाणी सहभाग नोंदवला, चेअरपर्सन म्हणून काम केलं, जज म्हणून देखील काम केलं. तर त्याबद्दल मी संस्थेच्या वतीने, प्राचार्यांच्या वतीने, कॉलेजच्या वतीने, सर्वांच्या वतीने त्यांचे आभार मानतो. नंतर या ठिकाणी रजिस्ट्रेशन फार महत्वाचं असतं. रजिस्ट्रेशन साठी सकाळपासून आमच्या सहकारी मॅडम, फक्त शिंदे मॅडम असतील, चव्हाण मॅडम असतील, कलसट्टी मॅडम असतील आणि त्यांचे सहकारी यांनी देखील या ठिकाणी काम केलं, त्याबद्दल त्यांचेही संस्थेच्या वतीने, प्राचार्यांच्या वतीने आभार मानतो. नंतर आत्ताच्या कार्यक्रमाला दिवसभरामध्ये ज्ञात अज्ञात त्यामध्ये आत्ताच त्या फीडबॅक देत असताना त्यात फीडबॅक देणाऱ्यांचाही मी आभार मानतो. कारण का फीडबॅक हे मित्रांनो आजच्या कार्यक्रमाची पावती असते. कारण का दिवसभरामध्ये काय झालं ते विद्यार्थ्यांच्या रूपातनं जर आलं तर ते अगदीच उत्तम असतं. त्याबद्दल ते लोखंडे मॅडमचं आणि आमच्या सायंटिस्टचं, नाही सायंटिस्ट म्हणतो मी त्यांना, कारण का न्यूटन म्हणतो आम्ही त्यांना, तर त्यांनी आभार मानलं, त्याबद्दल त्यांचंही मी या ठिकाणी आभार मानतो. नंतर आता इव्हिनिंगला जो व्हॅलिडेटरी फंक्शन झाला या निरोप समारंभासाठी नाही आपल्या विद्यापीठातील सायन्स फॅकल्टीचे डीन नाही डॉक्टर पवार सर यांनी विनंतीस मान दिला आणि न्यूटनचे 3 नियम अगदी सोप्या भाषेमध्ये समजावून सांगितले. त्याबद्दल या ठिकाणी त्यांनी वेळेत वेळ काढून उपस्थिती दाखवली. म्हणून संस्थेच्या वतीने, प्राचार्यांच्या वतीने, आपणा सर्वांच्या वतीने नाही या ठिकाणी मी त्यांचे आभार मानतो. तसेच आर्ट फॅकल्टीचे डीन आमचे सहकारी मित्र डॉक्टर कोरे सर या ठिकाणी उपस्थित राहिले, कार्यक्रमाची शोभा वाढवली, त्याबद्दल मी त्यांचंही या ठिकाणी आभार मानतो. तदनंतर आज दिवसभरातून आपल्या सिनियर मॅथमॅटिक्स मधले सिनियर आज कार्यक्रमाचे अध्यक्षपद ज्यांनी भूषवलं ते आमचे गुरुवर्य डॉक्टर आळनकर सर. त्यांनी या ठिकाणी आले, उपस्थिती दाखवली. दिवसभरामध्ये वय झाल्यानंतर देखील मन कसं हर्षित असतं ते त्यांच्याकडून शिकावं, तर त्यांनी या ठिकाणी आले, त्याबद्दल त्यांचंही मी संस्थेच्या वतीने, प्राचार्यांच्या वतीने आणि कन्व्हेनरच्या वतीने या ठिकाणी आभार मानतो. जो लग्न समारंभ होता दिवसभराचा, आज दिवसभरामध्ये तुम्ही सामील झाला, परंतु ज्यांनी हे ओझं उचललं मग ते शोले मधली जय विजयची जोडी आमची सहकारी मित्र कन्व्हेनर आणि को कन्व्हेनर डॉक्टर ढोणे सर आणि डॉक्टर गाडे सर यांनी उत्तमरित्या हे रणांगण जे युद्ध करून जिंकलं, त्याबद्दल संस्थेच्या वतीने, प्राचार्यांच्या वतीने, आपल्या सर्व सहकारी पार्टिसिपंट जे असतील त्यांच्या वतीने मी त्यांचे या ठिकाणी मनपूर्वक आभार मानतो. आपल्या कार्यक्रमाला फक्त सोलापूर, पुणे इथून आलेले नाहीत मित्रांनो, राजमाता जिजाऊच्या जन्मभूमीतून देखील, ज्या राजमाता जिजाऊच्या पदस्पर्शाने जन्मभूमी पावन झाली असे बुलढाणा जिल्ह्यातील सिंदखेड तालुक्यातील डॉक्टर कोतळीकर सर या ठिकाणी आलेत. म्हणून जिजाऊंचा निरोप घेऊन आपल्याकडे आले, त्याबद्दल त्यांचंही मी या मध्ये सहभागी झाले, त्याबद्दल त्यांचं मी मनपूर्वक आभार मानतो. इथं सकाळपासून उत्तमरित्या अँकरिंग केलं, नॉट अ जोक अँकरिंग करणं देखील, कारण त्या वेळेस तेवढं माइंड प्रफुल्लित ठेवावं लागतं. जो स्पीकर बोलला त्याचा सारांश घ्यावा लागतो आणि तो सारांश या ठिकाणी रिफ्लेक्ट करावा लागतो. अशा आमच्या सहकारी मॅडम डॉक्टर मेत्री मॅडम इलेक्ट्रॉनिकच्या हेड आहेत त्यांनी अगदीच उत्तमरित्या या ठिकाणी अँकरिंग केलं, त्याबद्दल त्यांचंही संस्थेच्या वतीने, प्राचार्यांच्या वतीने, आपणा सर्वांच्या वतीने मी आभार मानतो. आभार मानत असताना बरेच जण राहिले असतील, परंतु मीडियावाले आमचे डॉक्टर संतोष पवार सर असतील मराठीचे, किंवा आमच्या तिथं बुक्का सर आहेत, किंवा काळे सर आहेत, ज्यांनी डिजिटल काय असतं आम्हाला माहित नाहीये, त्या डिजिटल युगामध्ये नेणारी आमची पिढी तिथं त्या ठिकाणी बसली. त्यांनी 2 दिवसामध्ये 3 दिवसामध्ये जे काय सर्टिफिकेट असतील, किंवा डॉक्टर कावळे सर असतील, नाही डॉक्टर गोरे पाटील सर असतील, या सर्वांनी मिळून हा कार्यक्रम पार पाडण्यासाठी मदत केली, त्याबद्दल सर्वांचे मनपूर्वक आभार. उपस्थितांचे सर्वांचे आभार. बऱ्याच ठिकाणाहून आलेले, सगळ्यांची काय नावं घेता येत नाहीत, मला वाटतं रेशीमकर सर देखील इथे दयानंद कॉलेजमधून आलेले आहेत, त्यांचं देखील मी आभार मानतो. विद्यार्थी जे आहेत मॅथमॅटिक्सचे, त्या विद्यार्थ्यांनी देखील यामध्ये हिरिरीने भाग घेतला. मग ते करवाला म्हणून घेऊ दे, नाही तर करवली म्हणून घेऊ दे, परंतु त्यांच्याशिवाय हा कार्यक्रम उठाळून दिसत नाहीये. त्याबद्दल त्या डिपार्टमेंटच्या सर्व विद्यार्थींचं संस्थेच्या वतीने, प्राचार्यांच्या वतीने, कॉलेजच्या स्टाफच्या वतीने आभार मानतो. गणपती शेवटी नाही. हा नाही, प्राचार्य तर आपले हे आहेत. नाही, अर्थ माझ्या म्हणण्याचा असा की सरांनी माझ्या कानात येऊन सांगितलं, या कार्यक्रमासाठी ज्या आमच्या नॉन टीचिंगनी नाही रात्रंदिवस अहोरात्र कष्ट घेतलं आणि या ठिकाणी काम केलं, त्याबद्दल मी सर्व आमच्या नॉन टीचिंग कर्मचाऱ्यांचं, प्राचार्यांच्या वतीने, संस्थेच्या वतीने आभार मानतो. आणि सर्वात महत्वाचं, या महाविद्यालयाचे आमचे लाडके प्राचार्य नाही डॉक्टर बुवा सर, त्यांच्याकडे बघितलं की ते हसतात आणि हसल्यानंतर आम्हाला एवढा जोश येतो की कुठलाही कार्यक्रम घेत असताना जर आम्ही सरांना म्हटलं की आम्हाला असा असा कार्यक्रम घ्यायचा तर पहिल्यांदा घ्या, कारण का त्यांच्या चेहऱ्यावरचं हसू सांगून जातं की नाही व्यक्ती त्याच ठिकाणी ओळखू येते मित्रांनो. त्यामुळं या कार्यक्रमाचा भार, कारण का त्यांच्या त्या व्यापातून नाही या ठिकाणी लक्ष देऊन कुठपर्यंत आलं हे नेहमी विचारणारे आमचे लाडके प्राचार्य डॉक्टर बुवा सर यांचंही मी या ठिकाणी आभार मानतो. ज्यांनी उत्कृष्ट असं जेवण दिलं ते आमचे वनकडे सर आणि त्यांची टीम नाही, यांनी देखील आपल्याला नाश्ता देखील उत्तम दिला आणि जेवण देखील उत्तम दिलं. कारण का जेवण केल्यानंतर जर का त्रास सुरू झाला तर निश्चितपणानं आमचं मॅथमॅटिक्सचं वन डे नॅशनल कॉन्फरन्स इन रिसेंट ट्रेंड्स मॅथमॅटिक्स हे तुमच्या आठवणीतनं गेलं असतं, परंतु जेवण उत्तम झालं. त्यामुळं तुम्ही या ठिकाणी दिवसभर बसलात. त्यात जेवण देणाराचं माझे मित्र आहेत ते वनकडे सर, प्राध्यापक आहेत मित्रांनो, ते केटरिंगचं पण काम करतात, तर त्यांचं देखील मी या ठिकाणी आभार मानतो. ज्ञात अज्ञात इथं आमचे भाऊजी बसलेले आहेत, माहिमकर सर आहेत, बरेच जण आहेत या ठिकाणी, आमचे धनशेट्टी सर आहेत, सहकारी मित्र आहेत, तर सर्वांचं इथं विजापुरे सर आहेत, पाटील सर आहेत, कारण का यांच्याशिवाय हा कार्यक्रम होऊच शकला नसता. कारण मॅथमॅटिक्सच्या डिपार्टमेंटचे ज्युनियरचे असू दे, सिनियरचे असू दे, सगळ्या कॉलेजमधला स्टाफ, मग ते टीचिंगचे असू दे, नॉन टीचिंगचे असू दे, या सर्वांनी यामध्ये सहकार्य केलं. त्याबद्दल कन्व्हेनर दोघं डॉक्टर ढोणे सर आणि गाडे सरांच्या वतीने मी आभार मानतो. शेवटी सर्वात शेवटी ज्ञात उत्तम म्हणजे मी हे राहून गेलं, काल आम्ही गेस्ट हाऊस बुक केलं होतं, शासकीय गेस्ट हाऊस, परंतु शासनाच्या गेस्ट हाऊसला जरा उशीर होत होता, ऐन वेळेला पाहुणे लवकर येणार होते, म्हणून मी स्टडी सर्कलचं आपलं गेस्ट हाऊस आहे विद्यापीठाचं पवार सर, तर त्या ठिकाणी गेल्यानंतर त्या ठिकाणी एक रूम होती, 2 बेड होते, पण आपले 5 जण येणार होते. एक रूम रिझर्व फॉर व्हाईस चान्सलर आणि घारे मॅडम यांच्यासाठी असते म्हणून सांगितलं. परंतु माझा स्वभाव जरा वेगळा आहे. मी काय केलं की महानवर सरांनाच फोन केला आणि सरांना फोन केला की सर आमचा अकोमोडेशनचा प्रश्न उपस्थित आहे, इथलं जे रूम आहे गेस्ट हाऊस ते तुमच्या नावासाठी रिझर्व ठेवलं. ते म्हणले कोण म्हणतंय असं, आता कोणाचं नाव घ्यायचं. मी म्हटलं मला असं कळलं म्हणून मी तुम्हाला फोन केला. तर सरांनी फोन केल्यानंतर फोन रिसिव्ह केले नसतील, काल रविवार दिवस होता, मी मेसेज टाकला, साहेब स्टडी सर्कलच्या गेस्ट हाऊस बाबत प्राध्यापक शेख संगमेश्वर कॉलेज, एवढंच टाकला. तर एक 10 मिनिटांनी सरांचा फोन आला आणि सरांनी सांगितलं तुम्हाला ते गेस्ट हाऊस आहे ते जा आणि ताब्यात घ्या. अशा या महनीय व्यक्ती जे आपले कुलगुरू आहेत डॉक्टर महानवर सर, त्यांचंही या ठिकाणी मी आभार मानतो. संस्थेच्या वतीने, प्राचार्यांच्या वतीने, आपल्या सर्वांच्या वतीने. आणि उगवत्या सूर्याला नमस्कार करत असताना बुडत्या चंद्राची आठवण ठेवायची असते. जरी आपल्यामध्ये या ठिकाणी तिन्ही गेस्ट नसले, ते गेले, तर त्यांना परत त्रिवार अभिवादन करून हा छोटासा आभाराचा कार्यक्रम या ठिकाणी या ठिकाणी अध्यक्षांच्या परवानगीने संपवतो. कारण का आभार मानत असताना मित्रांनो आभार मानलेच पाहिजेत. त्याशिवाय मान्य आहे आपलं संपलंय, परंतु ज्यांनी कुणी या ठिकाणी हिरिरीने भाग घेतला त्यांचं कौतुक करणं, त्यांचा आभार मानणं खूप खूप आदराचं असतं आणि त्यामुळे ते गरजेचं आहे. माहित आहे आपल्याला की आपल्याला वेळ झालेला आहे, तर जास्त काय बोलत नाही. प्राचार्यांच्या आणि अध्यक्षांच्या परवानगीने हा कार्यक्रम या ठिकाणी संपला असं मी जाहीर करतो. धन्यवाद.